the exam today, but all of the content for the exam will be covered in today's class. So just while people are joining, we'll just go through what the plan is for today. So in terms of the slide deck, we'll have a few slides in today's deck that are not covered in the standard slide deck that you'll receive at the end of class, probably tomorrow at this rate. We do add extra content because this is a partner class. The slide deck matches the general public class. So you'll see a few slides today that you won't see in the slide deck that you get tomorrow. We don't record these sessions. We don't record any of the training class sessions. But if you do have to miss any of the content, there is the digital version of this class in your training account. So you'll be able to find the digital account, and I'll show you where that is as we go through the day. The chat can be anonymous, so feel free to ask anything. And as we go through today, we'll go through some of the sample questions for the exam. And it can be really helpful. If you're not sure what the answer is, just send the message back to me rather than to everyone. And that way I'll know, have we covered the content sufficiently for people to pass. Having said that, today's class is not a deeply technical class. There are no labs. So if anyone asks any deeply technical questions, we have a lot of people registered for today's class, over 120 people. And so we do have to keep the content to suit the class content itself. So any tech questions, feel free to ask. If it's a simple question, I'll answer it. But if it's going way off track, I won't. I don't want to lose 120 people. For lunchtime, this class is running on Sydney, Australia time, where it is just after 9 a.m. Sydney time. Now, I know that there's people from all around the region on this. Typically what we do is we spend about 3 hours on content, three and a half hours, depending on questions and depending on timing. And then we'll take a lunch break. However, I do know that we could be expecting a very large body of people from places where the time is almost 6 a.m. In that case, we'll try to juggle the time to suit it, depending on the agenda that we've got to get through. So the plan is that we will go for three and a half hours, just depending. We'll take regular breaks. I don't like to talk for more than an hour because my throat starts to fade. More importantly, your attention span would fade. So that's the plan. We'll do that. We've got lots of content to get through, so let's get started. So thanks everyone for being here on time. Okay, what are we going to cover today? We're going to start gently. This class is designed for technical and non-technical people. And by that I mean salespeople, pre-sales people, but finance, marketing, legal people. We've had every kind of person, every role to do with any kind of IT organization and a partner organization specifically on these classes. And you will learn something. I'm not allowed to say I guarantee it, but you will absolutely learn something that you can use in the field tomorrow. So we'll start off at a very high level. We're going to look at the customer view of the cloud because I joined training 18 months ago. Before that, I was a technical account manager. So I was a TAM in enterprise support, and I worked with some of Australia's largest commercial and government organizations. And I'm going to inject some of that experience into this class because quite often you may be surprised what customers know and don't know. And I'll give you an idea of how you can use this content in the field to help your customers and your prospects. So we'll start off the AWS cloud, and then we'll look at how do you do computing in the cloud. Typically, when you engage with a customer, the customer might say, I've got 100 Windows and Linux servers in my computer room, Glenn. How does that look in the cloud? And we'll spend some time in there because what we're going to see is customer can really take advantage of doing things differently in the cloud to make their business more efficient, to drive down their costs. And if you understand some of the content that we cover in the module 2, you'll be in great shape to help your customer take advantage of that. Module 3 looks at where do our data centers sit geographically. And that's going to be important, especially if you deal with government customers. So we'll talk about that. Module 4 talks about networking, but again, at a high level, just so you're familiar with the terms that we have, so that when you're sitting in a customer meeting, you can follow along. You're not expected to be able to configure networking. And same thing with storage and databases. Again, you'll be aware of the terms. You'll also know the different services that we have. because when we get to storage and databases, you will have seen compute, networking, and storage. And this is much, much broader than what a typical customer can deploy in their on-premises environment. And that's why it's important to understand the different services that we have and how to talk about them. Module 6 talks about security. Now, this often comes up as a sales objection, and we'll cover that. And we'll look to see how our customer in the cloud can typically be far more secure than they can be in on-premises. Module 7 looks at monitoring and analytics side, and that's a very powerful module. When customers start working with this, they start to really understand the power of the AWS services and the way they connect together. We then start to round out the day. We'll look at pricing and support, and then migration and then innovation. And then we'll spend just a few minutes on the Cloud Practitioner exam. So anyone who's going to do that exam will cover off the basics there. Okay, so that's the plan. We start off gently. We start off nice and high level. And then we start to dive in a lot more as we go through the day. So let's get started. Typically, these modules go for about 40, 45, maybe 50 minutes in the morning. So we'll do that, then we'll take reasonable breaks. So 5 or 10 minutes, depending on how we're tracking for time before we get to the lunch break. Okay, what is Amazon Web Services from a customer's viewpoint? Because this is going to help you as partners to find how can I best help my customers and my prospects take most advantage of the AWS cloud. To do this, we're going to look at 3 cloud computing deployment models. And why is that important? And we're going to look at 6 benefits that customers have told me when I was their TAM that they saw from cloud computing. Now, hopefully you didn't bring a lot of things along today, but you did bring your imagination. And what we need to do is all through the class, we are going to use this model of a coffee shop. And you're going to see that some very technical concepts can be easily explained if we look at how do things work in a coffee shop. So if we look at a coffee shop, let's say you win the lottery or you win a lot of money and you decide to, I'm going to run a coffee shop. I'm going to open my coffee shop. So you set up your coffee shop, you open the doors day one, and you're standing behind the counter as the barista ready to make coffee. And what happens? Nothing happens. Nothing happens until that first customer comes through the door. And that's what we're going to do today. We're going to look at the cloud from the barista's side and the customer side, because there's 2 very different sets of expectations here. And we'll cover it here. And then you're going to see that as we go through the technology today, what impact does it have on IT? What impact does it have on customers? So if we say that you're standing behind the counter, waiting, and a customer finally walks past your coffee shop, they go, "Ooh, coffee. I'd really like a coffee." So they have a look at the shop, looks nice, clean, someone's there, and they walk in and they say, "Hello, can I please have a coffee?" Now, from the customer's viewpoint, this customer doesn't know the barista's name, doesn't know their background, doesn't know if they make good coffee or okay coffee, but they just know that they want one right now. From the barista's side, the barista doesn't do anything until that customer makes a request. And then he or she springs into action and makes the best coffee they've ever made that day because it's the first one. And they go, "Here you are," they take the money and the customer leaves. Now, this may sound really, really simple, but there's a lot going on here. And we're going to see that as we go today. From the barista's viewpoint, if this barista took half an hour to make the coffee, the customer would probably go, "Oh, this is slow, I'm going to go away. I'll just walk down the road, there'll be another cafe soon." But if the door was shut, the customer would just keep going right past. From the barista's viewpoint, how many baristas are there waiting for customers to come in? And these are the challenges that people face when they're trying to run IT systems. When we look at the cloud, we've got what we call the client server model. And this is going to seem really simple, but it's a really powerful idea. Instead of having a customer who's just walking down and they go, "Oh, I feel like a coffee now." In cloud, we have clients. And a client is a person with a device, or it could be a machine with a device. It could be a robotic device that is trying to stack equipment in a automated factory. But we've got a client system. What are they using? What kind of device? Well, it could be a smartphone, it could be a tablet, it could be a corporately issued laptop or desktop, or it could be their own home PC or gaming PC. could be running Mac OS, could be running Windows, could be running Linux, all different combinations, plus all different combinations of browsers. And the user goes, click, I want to see what Amazon.com has on offer. And something somewhere in the cloud responds to them, and it gives them the Amazon.com homepage. User doesn't know where it is, has no details of, is it running Windows, is it running Linux? So much like it doesn't know the barista's name. But it just knows that I want to sit here on my device and go click, and I want something to tell me or respond to my request. On this side, we've got some servers, and they do nothing. They're twiddling their thumbs until, hey, there's a request here. We have to show the Amazon.com webpage. From a customer's view, from a IT department's viewpoint, these customers could be anywhere in the world. Are they allowed to see the Amazon.com webpage? What language do they want to see it in? What time of day do they want to see it? Because, what happens if the server fails? A disk fails or a memory module fails? Well, if I can't still serve my customers, those customers will go elsewhere, off to eBay or something like that. What if I have to upgrade my software, new version of the web page? Well, I can't say, hey, everyone, wait a minute, I'm upgrading my website. These customers will go somewhere else. And this is the challenges that we're going to walk through today. What are the Cloud Practitioner essentials that you need to know to help customers deliver always-on, highly reliable services at the most efficient price points to a wide variety of clients anywhere on the planet? Now, if this is the most important class that you'll ever do, and I think most trainers think it is, because you learn how to start thinking, how does the cloud differ from on-premises or traditional IT, and how can customers take advantage of it? If this is the most important class, then this is the most important slide. Assume that tomorrow you've got your corporate PowerPoint deck, you wander out to your customer, and you're about to give a presentation. Why should that customer work with you? And just before you start, the CIO or CEO, senior exec, comes over to you and he or she says, Glenn, before you talk, can you just explain what cloud computing is? Because some of us are not technical. Now, what are the basics? How would you explain cloud computing? What terms would you use? Because at AWS, we use the following 4 attributes, and each attribute works by itself. But when you put it together, you can very deftly or very competently explain what cloud computing is. And to give you an idea of how powerful these 4 attributes are, whenever I, as a TAM, sat with customers in meetings and sat with the AWS and partner teams, we would always come back to these 4 attributes when we were looking for what's the best way forward when we had a challenge to solve. And the 4 attributes are these. So cloud computing is the on-demand delivery of IT resources via the internet using pay-as-you-go pricing. And we're going to spend some time on these attributes because you might think, Glenn, that is so basic. Why did you spend so much time on such a basic concept? If you can master these attributes, you'll be way ahead of your competitors. You'll be able to efficiently help your customer solve some of the problems that they just cannot solve with their current environment. So let's look at it a little bit more. Accessing services on demand. Now, if you've ever worked in an on-premises data center, you probably know that it takes maybe 6 to 8 weeks for you as a IT manager asking for, I need a brand new server, until that server is actually in the computer room and functional. I mean, you write up the specifications that you want. I want a Dell R750 rack server with this much memory, this many CPUs. Hey, finance or procurement, can I have one, please? They take that, they send it out to 3 or 4 resellers. And those resellers, they wait for them to come back with quotes. When they finally come back, maybe it takes a week. Procurement says, okay, who's the cheapest? We'll place that order. Then they order it. It takes maybe 2 to 3 weeks lately to get equipment to come in. So that's a month gone already. Then I have to unpack it, find space in the computer room. And that's not easy in some computer rooms. You've got to check, is there enough electrical power? Have I got enough cables? Is it close enough to switches? So that can take time and planning. Then I rack it and stack it, connect it up. find the software that I want to install that all up, then hand it over to the network team. Hey, this is a database. It has to be in the protected environment of the network. Or this is a web server. It has to be public facing. So the network team has to cable it up. Then you give it to the storage team. Hey, storage team, this is a database server. It needs to have high performance storage. All that kind of thing, easily 6 to 8 weeks. In the cloud, I can have a server up and running in 6 to 8 minutes. Probably even faster if I don't talk while I do it. But that's the difference. And why is it important to you as a partner? Well, if you're in the pre-sales or sales side and you're working with a customer, you're talking to, say, a senior exec, maybe it's the chief marketing officer, and you're talking about what projects have you got, planned for this year? And that marketing officer, he or she might say to you, well, Glenn, we'd love to have a better email engagement system with our clients. Well, you could build something within a couple of days up and running as a pilot. And that's a very common sales strategy, using pilots and proofs of concept. And you experiment a lot. Most customers, or my customers when I was a TAM, they were experimenting all the time. They were trying out ideas because they knew that they didn't have to order in equipment, order in software licenses. They could just go, hey, this pay-as-you-go idea, if I start a server up, I pay for it, and I pay for it only until I turn it off. That's a great idea. I can run more experiments than customers do, especially with projects that make the business better. Either customers spend more with them, or customers are much more satisfied with the service they're delivering, or costs are reduced. So this accessing services on demand is very, very important. And what's more important is the services that we have that partners can take advantage of. For instance, if I show you the portal that we have, so these are some of the services. Now, we're not going to cover all of these services today, but if you go to aws.amazon.com, this is the homepage. And if I go just products, what have we got? There's over 200 different products and services that we offer to customers and partners. If I take compute, for instance, so I'm talking to my customer and I go, Glenn, we've got 100 Dell and HP servers in our computer room running a mix of Windows and Linux. Well, I could say, well, here's a service that AWS has to run virtual servers in the cloud. And they go, great, we can do that. We like that. But there's a different service down here. I can run applications without worrying about servers. Customer can't do that on-prem. How do you run something without a server? In this case, we have a service that does exactly that. We have other applications as well, other ways to do computing. Here's one that says, I can develop applications using the mobile phone or hand phone for 5G networks. Very low latency, very high performance. Well, here's a service purpose-built for that. Imagine your on-premises customer trying to develop something along those lines. When we come to storage, very similar. Lots of ways for your customer to really optimize how they store their data. But there's more. What if your customer says, I want to do satellites? I'd love to be able to use a satellite. And we in Australia have customers doing that. We have a partner who is developing software in North Queensland. And for those of you who are not familiar with the area, we have cattle stations in North Queensland that are bigger than the US state of Texas. Imagine trying to find your cows. It's a massive area. Well, they're using our satellite system. They rent them by the hour. And they're tracking where the cattle is because they have little transmitters in the collars that they put on the cattle. So that's something that most on-premises environments just can't do, have their own satellite systems. What about robots? You might be working with a customer who says, Glenn, we'd love to have a smart warehouse, with robots in it, just picking things or storing things. Or we want to have a smart building. If no one's in this area, it dims the lights. What's the power? What's the cooling? All having smart sensors and safety cameras, things like that. Well, we have our robotic systems. We also have our Internet of Things services. Why is this important to you, though, as a partner? Well, what it means is you can be talking to a customer who says, oh, we'd love to be able to do that, but we have no space in our computer room. We don't have the skills. We haven't got the budget. And you go, well, we could use AWS's services here, and you don't have to build them from scratch. They're already built. You just have to configure them. And so you can help the customer configure these systems up, and that's usually a very quick task. And then the customer's going, hey, this looks really good. You're running a small pilot or a proof of concept, and that can be up within days. If I give you a real-world example, here's a contact center. Now, we don't cover this in today's class, but we have cloud-based call centers. One of my customers in 2020 had their on-premises contact centers, and they were doing $200,000 worth of business every hour. When the pandemic first impacted, they could not have their staff come into the office. Some of them were locked down. Other people had travel restrictions. And so this customer was in a real problem. Their call center was not going to be operational because they could not get staff in to man it. And yet they were doing $200,000 worth of business every hour. One of our partners said, hey, we could use this Amazon service. And they very quickly built up the prototype, tested it, and the call center went operational within 5 days. And it absolutely saved that customer because the staff could work from home. They could connect into our Connect call center system, take calls, the business continued to operate. That's the kind of value that partners add by knowing about some of these services that customers absolutely struggle to do by themselves in an on-premises environment. Avoiding large upfront payments is also very important. Most customers with on-premises environments, they've got their computer room that they've got to pay for, or they've got to rent. So they've got all that gear in there. Plus they've got the hardware, the servers, the storage units, the switches, the cables. And then they've got the staff to manage it all. So that customer is usually committed to pay the bank. If they've got a lease, they're going to pay the bank a certain amount every month for the next 3, 4, 5 years. And they're doing that whether the business is doing very well or not doing so well. And especially over the past couple of years where some customers have said, hey, our business is going backwards. We have all these IT costs, but people aren't coming in, they're not purchasing, because of the pandemic. In the cloud, that wasn't a problem. Customers just pay as you go. If I want to have a big system now because we're having a big sale, great, I'll pay for that now. And as soon as the sale is over, scale it back down again. So I don't have to commit my company to spend a lot of money up front. Provisioning resources when we need it. We're going to see this as a very powerful idea, and it's almost impossible to do on premises. So you'll be doing that. You'll see a sample of that in action. But the key piece that's probably the most important piece of today's class is only paying for what you need, paying for what you use. And you're probably thinking, well, Glenn, that's obvious. But in an on-premises environment, that's really tough. And we'll look at that as we go. So these are some of the benefits of cloud computing. And at the end of the day, you'll be able to go, hey, I get all this, and I can work with my on-premises customer to show them how the cloud will improve their business. The 3 deployment models we have. Cloud, everything's in the cloud. There is no data centers, no servers, no storage. It's all in the AWS cloud, and the customer is running quite happily with that. They don't have to have staff looking after that hardware. They don't have to have, when a disk drive fails, they don't have to have someone, hey, quick, call the vendor, we need to get some parts replaced. Then they have to hang around after hours while the parts turn up and get it in there. Not the customer's problem in the cloud. We look after that. On-premises is your traditional computing environment. So I have a number of data centers if I'm a large customer, or I've got some computer rooms. I may have the production one and the disaster recovery site, or I've just got a few computers under the desk. And I'm just looking after the hardware. I'm looking after the environment, so the power and the cooling, looking after the system software, so the operating system and the applications. And periodically I have to replace that. I've got to upgrade it or replace old with new. So I'm looking after all that. On the right-hand side, we've got hybrid, and that's a combination that you'll encounter in 2 different ways in the field. First one is you're working with a customer who has got on-premises, and they go, Glenn, let's go to the cloud. You've worked with them to say cloud is going to have all these benefits. They're going, look, our data center is getting really old. We'd have to fit it out again because battery backup units fail, air conditioning units wear out. Servers themselves wear out, power supplies and disks start to fail. And they go, Glenn, we're sick of maintaining all this. Let's give it to AWS and they can look after that. So you're helping a customer migrate from on-premises to the cloud. While that migration is happening, the customer has some of their systems still on-prem and some of them moving to the cloud. And that can take weeks. In fact, it can take months and years, is what some of the customers I work with, that's what they had. And so while that's going on, your customers, users are going, hey, I want to connect to the sales system. Where is it this week? Or do they need to know, has it been migrated to the cloud or not? And the answer is no. The system says, end users, you connect to the sales system, the expenses system, the HR system, and the cloud will direct their requests to, if it's on-prem, it'll go there. If it's in the cloud, it'll go there. The other area that hybrid turns up is where a customer says, Glenn, we have to keep some processing on premises. But don't think computer room, think about factory floor. Think about safety cameras, think about hospitals and medical equipment or laboratories or schools, where there is a need to have some sort of computing capability on the actual site itself. But it's also working with systems in the cloud. For instance, it's a factory floor and it's producing widgets. Well, every hour it might say, hey, I just made another 10 widgets. Send that data up to the cloud so those widgets can be sold on the website. Or it could be a school where teachers are going, okay, today's lesson is, and they connect to the cloud and they download the content. Or laboratories. We have a lot of customers in that field that take lab results coming out of microscopes and scanning gear, and they send it up to the cloud for machine analytics. So looking to see what patterns can I see. And so this hybrid component, you'll come across a lot. So don't think everything has to go straight away into the cloud at all. It's tying tying on-premises and cloud together. Cloud, this is where customers have got everything running in the cloud. And for a partner, this means that you can then talk to the customer about, well, let's start taking advantage of the cloud. You know, you've got a customer with 100 Windows and Linux servers and you've moved them into the cloud. And if it's a rush, you've probably got 100 virtual servers in the cloud. What's the next steps? And we're going to look at that when we do the computing in the cloud module. How can you help the customer modernize the way they're building their applications? On-prem, this is where a customer goes, you know, hey, Glenn, let's go for a tour of our data center. And you're in the data center and you point to a server and you go, hey, what's that server running? What application? Well, your customer might say, Glenn, that's our database. You know, it's running Oracle. Or they might say, well, we run a private cloud in here. You know, we've got VMware, we've got Hyper-V or OpenStack or OpenShift. We've got one of those virtual clouds where it depends. You know, one day that server might be running all of the sales systems. And it's part of a cluster. It's working with these other servers. So customers will sometimes, in fact, quite often, if they're the medium to large customers, say we're running private cloud software like VMware or Hyper-V, and so that their applications are not tied to specific hardware. If you come across that, that's great. The customer is already educating themselves about cloud technologies, not having an application tied to a physical unit. So that if that physical unit has a fault, what do you do then? You know, you have to wait till that fault's repaired. In a private cloud, you don't have to worry about that at all. It moves around to suit. Then we looked at hybrid, and as I say, this is turning up a lot. And we'll see some techniques today because some of you operate in many different countries, and what we have available in different countries varies a lot. These are all the different services, and we saw some of them before. Now, don't just think, oh, it's all about server storage and networking. We looked at, satellites, robots, Internet of Things. Another hot topic is data science and data analytics. Now, we have our pre-built frameworks, and partners who have skills in that space have been very successful taking those frameworks and very quickly building up a proof of concept for a customer. You know, it's typically days, and the customer goes, that's exactly what I want, or it'd be good if we could just change this little bit. And away you go. Your customer has a brand new system in production that would take them months if they were trying to do it on-prem. So if that's what it is, what are the benefits? And sometimes here there's going to be sales objections, and we're going to cover those off. And the first one is an on-premises type customer will have these large upfront costs. Excuse me a minute. So they're used to, hey, we've got to pay the rent on the computer room. And if you're from, say, Singapore or Hong Kong, you'll know that those costs can be very expensive because of the cost of real estate. So the customers had to budget for that. They've got, hey, this is my monthly rent on the computer room. Here's the monthly lease on equipment. And they go, so we know how to budget for that. When we move to the cloud, we have what's called variable expenses. So these variable expenses are pay for what you use. Now you might think, well, that sounds like a good idea, but some customers go, well, how do I budget for that? What we do here is we look at what has the customer got in their computer room. And this is a very big difference. This is almost like they have to start thinking differently. The key idea here is that your customer has 100 servers in the computer room. They probably have that to handle all of their peak workloads because, it takes 6 to 8 weeks for something to turn up. Now, if your customer is going to have, say, end of financial year reporting, so lots of activity, they've got to have all of that equipment already in the computer room. But what happens if it's not busy? So take a school, for instance. Your school customer might say, hey, we've got all these servers in the computer room, and during term when all the students are working with the systems, it's great. Then you think, well, what happens during vacation time? What happens if your customer is a web retailer? And they go, we have a big sale every, 6 months, every year. And that's what we need all this equipment for. Well, what happens when the sale is not happening? And we're going to start to unravel that, asking questions of the customer, and it helps to turn this potential sales objection about how do we budget for this variable cost into they become your allies, that they can see exactly what's going on and they go, yeah, okay, we can't budget anymore, but we can track our costs versus our business outcomes. And that's a key factor. We cover that kind of information in, say, the cloud economics classes. We look to see if you're expected as a pre-sales or salesperson to build a business case. Cloud economics covers that. We show you all the tools to do that, but we won't have time today. We've got too much else to get through. But the big item here is changing from I have a fixed amount of money I have to spend every month, whether the business is booming or busting. We move that to variable expenses, and we'll see why that's a huge advantage a little later when we come to the compute modules. Cost optimization is where we start to free up some of the customer's expenses that they have to incur because they're running a computer room. If you've got 100 servers in a computer room, then every so often, every month or so, the hardware vendor will release brand new firmware that you should apply for security reasons usually, but other reasons to fix problems. You've got switches to maintain as equipment comes in and out. You're changing the switch configurations. You've got cabling. You've got power and cooling to look after. A lot of the budget of an on-premises environment is spent doing just those tasks, what we call undifferentiated heavy lifting. If you've got 100 servers in there and it's peak time, the customer needs all those 100 servers running, then yeah, you're going to have to look after those servers. But in the off-peak time, say nights and weekends, that still has to be maintained. That's the challenge there. When we move to the cloud, though, customer doesn't have to look after hardware. They don't have to look after computer rooms and security systems and aircon. They don't have to patch hardware. They don't have to reconfigure switches. We take care of that. So the customer's IT budget now has more budget available for innovation, doing new projects. And this is a very common strategy that I've seen. When I was working as a TAM for some of the large customers migrating to the cloud, there was often a second IT team, especially with a partner involved, to help them go, hey, we're in the cloud now. Those extra services that Glenn showed us, those satellites and robots and all this kind of thing. Now, not every customer is going to want to do all of that, but many customers will find something, typically data warehouse, that they have not been able to do on premises, that now they can do that in the cloud quite easily with your help. So that's where that 80% of the budget gets spent on just keeping things running, and only 20% is available for brand new projects. That switches when we come to the cloud. And that is something that we see all the time. Customers are now going, hey, we can finally have this brand new project. A partner is going to help us configure the AWS services to deliver. In terms of capacity, this was a very stressful thing for an IT manager. You're sitting there with these 100 servers in the data center and you go, oh gosh, they're 5 years old. We've got to replace them. What do we need? So you first go, well, what have we got? How busy is it? So if it's a 5-year-old server, it's probably running, harder than it did when it first started because software got bigger, more users. Then you've got to go, well, what does the business need? Because if you've got 100 servers, that could be, a couple of $1 million you're about to spend to replace all of that. And you want to get it right because you don't want to underspend. And in 6 months' time, your users are going, hey, Glenn, this stuff is really slow. Do you know what you're doing? So what IT managers used to do, and I was one and I did this, is you would always work out what you think you need and then ask for more. Then you hope that you don't outgrow it. The business doesn't acquire something or do something differently. When it comes to the cloud, who cares? I can change the characteristics of the servers and the software, day by day if I so want. And you'll see that today. We'll have servers magically appear when they're needed and disappear when they're not needed. So this whole idea of predicting or forecasting, what does the business need? That problem doesn't happen anymore because things are so dynamic, especially in this current economic and climate. Is the business going to contract if people can't come in? Is it going to go really well because customers that used to come into our shops are now going onto our website? We can scale in and scale out as we need. In terms of economies of scale, yes, we get really good discounts on hardware because the volume of hardware we purchase. But more importantly, because we're operating with millions of customers and we're operating a global network, we have our policies and procedures in our services very tightly tuned. And we make those available to customers at a fraction of the cost it would take for them to build them themselves. Take security, for instance. Trying to protect a customer's network from, say, a denial of service attack. A customer could spend a lot of time, money, and skills trying to build one of those. We make our service called Shield, and we'll see that later today. We make that available to customers at no cost. So your smallest customer up to your largest customer can take advantage of our services at a fraction of the cost and time it would take for them to build it themselves. So that's a very good thing to show a customer, and I'll show you how to find it and present it to a customer. How do you protect any internet-facing services? We'll talk about that when we talk about security. In terms of speed and agility, this is just getting things happening. One of my old customers, before I joined AWS, I used to work at Dell. One of my old customers was a global bank, and they used to send teams of server specialists and data center specialists all around the world to supervise the setting up and then hardware and software refreshes whenever that was happening in one of their remote data centers. So they had to spend, a lot of money flying people in and accommodating them while those builds were going on. When we look at what we do, I can sit here in my little room here and I can go click, I want to have a server in Italy. I want to have a server in Sweden. I want to have a server wherever. Or I want to have a lot of servers in the US or Ireland. I don't have to fly anywhere and I have those systems up and running, within minutes. Huge advantage. Sometimes we'll look at these when we do storage. I'll give you a real world example where a partner helped save a customer's SAP project by knowing that they could do this. Going global, this is where a lot of customers have started off with a small idea. I mean, even Amazon.com started off small and grew and grew and grew. We have the same thing, especially in the ASEAN region. If anyone is from the Indonesia area, you've probably heard of Gojek. If you're in Malaysia, you would have heard of Foodpanda. They're AWS customers who have started off small. They took an idea and they built on it in their country. And then they took it, they added extra services, and then they said, well, let's go regional. Well, having AWS hardware in place all around the planet has helped them achieve that. In Australia, we have, New Zealand, we have some of our own companies that have done the same thing, that have taken their software development environments and their accounting systems and taken it to the world. And they're running on AWS data centers all around the world using our global infrastructure. The core services that we're going to talk about today, because we're not going to talk about everything because we would be here till April. We're going to focus on these core service categories because this is what your customer who is in on-premises is going to think about. This is what their view of IT is. Computing. So Glenn, I've got 100 Windows and Linux servers. What does that look like in the cloud? And in the next module, we'll start to look at all the options that you get depending on the customer. So, are they bleeding edge? Are they wanting to be on the leading edge of technology, or are they conservative? How much time have you got? How many systems have you got? We'll look at that, and we'll look at all the ways to run computing in the cloud. We'll look at networking and content delivery. So how do you serve customers that are not close to data centers? You may have a customer, say, based in Australia, and they've got offices all around the country. Well, how do they all get very high levels of performance? We'll look at that. Storage is a big item. Compute on a customer's AWS bill is usually number one, the biggest item. And then it's usually storage and database. They're numbers 2 and 3. And what can we do in this space? And how can partners help customers? Especially customers who are coming from an on-premises environment, you do things very, very differently. Absolutely, we'll look at security. This can be a concern. The customer goes, Glenn, all of our systems are in our own data center. We don't share it with anyone. And you want us to go to a public cloud where our competitors are, where the internet is, hackers are, all that. Explain to me how this is going to work. And that's what we'll spend some time on in case it comes up as a sales objection. Lastly, we'll look at management and governance. And this is where the real power of the cloud comes out. And partners can add a lot of value with a customer's organization, showing the finance people what IT is doing and helping IT show finance and business leaders what they're doing and how do they add value. So that's what we're going to cover in the next modules. What we're going to do during the day, though, is some of you are preparing for Cloud Practitioner Essentials exam. So we'll go through some sample questions. Now, these questions, if you want to have a go at the questions, but you're a bit shy or you're a bit uncertain, just send the answers back to me because we're going to look at the various exam question types and we're going to look at some answering strategies. So the first question that I'll put up in a moment, it's very simple. It's so simple. All the answers are correct, but one answer is much better than the others. So first question for the day. So thinking caps on, ladies and gentlemen. What is cloud computing? What would you say? So we have, a few brave souls are putting in their answers. Okay, lots of votes for C. So what do we think? Well, C is really good. C is probably the best answer there. In fact, the only way that C would be better would be if it had using pay-as-you-go pricing, because that is the definition that we use internally. But let's look at A. A is, for many small to medium customers, my first cloud project. If you have a customer who has a computer room, say it's a school, or it could be a small shop, what happens if that shop has a power fail or a flood or a fire? And so many customers of that size will say, hey, we need to keep our data somewhere else in case there is, a loss of our computer systems. So cloud comes in there. But that's usually, for many customers, my first cloud project, just storing my data somewhere else. Back in the old days, we would have, we would do our backups to mag tapes. A courier would come every day, pick up the box of magnetic tapes and take them away, take them off site in case there was a problem. Here, customers just connect to the internet and they go, cloud. Move it to the cloud. So that's a good one. B is the definition of hybrid cloud. I'm connecting my on-premises systems to cloud-based applications. And that's, as we saw, a cloud deployment model. D, running code without managing servers. We are going to see when we look at our Lambda service, our serverless computing. So that's a great answer as well. But in this question here, the best answer, and sometimes the exam will ask you that, what's the most cost-effective? Or what is the best, or what's the optimal or most efficient? When you get a question like that and there's one answer, C would be the best one here. Okay, here's another question. What's another name for on-prem? And if you don't know the obvious answer, what could you eliminate as a wrong answer? Okay, lots of answers for C. Now, this is the 5th day in a row I've run Cloud Practitioner. And this is the second question where the answer is C. All I want to say is the answer is not always C. In this case, it is though. So on premises, that's where I'm maintaining my computer room or my data centers and my hardware. So that's on premises. It's not a cloud-based app because that would be in the cloud. Hybrid, well, on-prem is a part of hybrid, but that's not strictly speaking what it means. It's really C. A customer will often, if they're running VMware or Hyper-V, and VMware is extremely common. When I was at Dell and I used to run these classes for Dell customers and partners, out of 20 partners, 19 would have VMware and one might have Hyper-V. So customers saying, I've got VMware, I've got Hyper-V, that really means I've got a private cloud. I have got my applications that I can move from physical server to physical server. The AWS cloud, yes, we're going to see a little later on that I can put AWS cloud components on-prem, but the best answer here is private cloud. Okay, the next question is an example of read the question twice. There is a key word in there. All of the answers are correct if you miss the key word. When you see the keyword, you go, okay, only one answer can be correct. And this is a very common exam strategy as well, looking for keywords. Lots of votes for B. And see, I told you it wasn't always going to be C. If I missed the keyword, if I said, how does cloud computing help you save costs? They'd all be correct. And you'd sit there scratching your head. But as soon as you see the scale, how does the scale of cloud computing? And this is because we have probably tens of millions of customers now on our global network. And so we've got very efficient at purchasing and we've got very efficient at building systems and then passing on those savings back to customers. So it's really the aggregated usage from all our customers. You know, we're building out global security systems and we can pass those systems on to your smallest customer. I mean, if you went home at the end of the day, if you're not working from home, and set up an AWS account and go, I'm going to have a web page. That web page is using the same security systems that our largest customers are using, and that costs $0 for you. So that's that one. Okay, that was module 1, the advantages from a customer's viewpoint of cloud. What we're going to do, we'll take a 5-minute break. If anyone needs more than 5, just shout. But we usually take 5 minutes and 10 minutes and 5 minutes and the lunch break. So we'll take a 5-minute break. We'll come back and then we're going to go do computing in the cloud. And this is where we start to see the really big differences between on-prem and cloud. Okay, so one more slide, back soon. Take a 5-minute break and then we'll resume. Okay, a comment in the chat about spotting trick questions. It's going to turn up a lot today because there's two purposes to today's class. One is for people to pass the exam, because often your manager or supervisor or team leader said, Glenn, we want you to have certification. And certifications are important. When I was at TAM for many customers, I'd sit in meetings and the customers trying to pick from one partner and the other one. Who should we pick? And having AWS certifications sometimes was the deciding factor, because it actually says this customer has been tested out by AWS partners, partner exam certification, to say, yes, you have got skills. So that's important. But more importantly, it's how do the skills work in the field? And that's what we're going to cover today. So yes, there's going to be an element of, if you see this word, this is the other word you're looking for. We'll see that definitely in the later sections. But more importantly, you're going to understand the differences, what's important to a customer. Because often when I run this class, especially today's Wednesday. Yeah, the two classes I run this Monday, Tuesday, they were for people new to the IT industry, so graduates, if you will, university graduates. And so if they went out to visit a customer, let's say they bumped into a grizzly old industry veteran like me who's been working in on-prem for, lots of years. Then they're going to go, well, we can do this in the cloud. You're not going to have a sense of, well, how does that improve the customer? What are the customer challenges? And that's absolutely what we're going to cover in this next module. This is where you have a customer who has 100 servers in the on-prem environment. How can we look at some of the challenges that they face? What are the challenges, and how can cloud solve them? I mean, a while ago, before I joined Dell, I was an IT manager. And I know from personal experience how painful some things in on-prem are. The cloud just makes go right away. I don't have to worry about those things anymore. And that's what we're going to look at in this module in particular. We're going to start to build out, how does cloud work? We'll start off using compute, but these techniques you'll be able to apply to other areas, so that when you're talking to, say, the IT team, maybe it's a server team or the network team, the storage team, database team, or you're talking to their leaders, you'll be able to say, well, cloud does this. Is that of interest? And you can bet they're going to say, absolutely. But let's start with cloud. We're going to start off doing a like-for-like comparison. So 100 servers on-prem, 100 servers in the cloud. But then we'll start to see, well, are there better ways? Are there better things we should be looking at? And we're going to look at all these different terms. Don't worry about these names right now. We'll get straight into it. So remember client server. This is where we're going to focus on the barista, the coffee shop owner's experience. Because typically a coffee shop owner, much like a webmaster, I have to have my systems up and running as much as possible, 24 hours a day in some case, all the time. Yet what happens if a part fails? What happens? How do I do my upgrades? How do I apply patches? All the while keeping systems running so our customers and clients can keep using them. So that's what we'll look at now. The first compute service that we'll look at is this one, Elastic Compute Cloud. And it's elastic because the number of servers that are running at any time can vary. On-prem, I've got 100 servers. That's 100 servers until I add another one or retire one. But I've pretty much got 100 servers this week, next week, the week after. In the cloud, I could have different numbers of servers running at any hour of the day. And that's what we're going to explore. How does this work? And how does it work for the benefit of the customer? So the first service, Elastic Compute Cloud, EC2. It's very, very scalable. So our data centers, as you could imagine, we have a lot of equipment in them, a lot, more so than any single customer would. So it's very sizable. And we often have customers who go, hey, Glenn, I've got a project on the weekend. Can I have 1,000 servers? Thank you. And they get 1,000 extra servers to run, say, a scientific or an engineering project just over the weekend. And at the end of the weekend, they go, okay, shut them down. Don't want them anymore. Well, we have that kind of capacity in our computer rooms. It's also extremely secure. That surprises people. And when we do the security aspects, you'll see that. The important piece, though, is I can say, I want a brand new Windows or Linux server, and it's running in minutes. In fact, sometimes it's even faster that it's running within a minute. Depends on what you've asked the server to install. But yeah, I can have it, very, very quickly. And I can change it. That's the other aspect. I can say, hey, we've outgrown this server that we started last month. Can we have a bigger one? And you can switch it up very quickly. So you can upgrade it. The important piece, though, is you pay only for what you use. So when you start an EC2 instance, you start to pay for it. And when you shut it down, you stop paying for it. That's very different to on-prem. Think about, for instance, a backup server in on-prem. It might only run for 2 or 3 hours a night every night. But you have to pay for the hardware plus the operating system license for 24 hours. You've got to have a subscription. Well, in the cloud, that problem goes away. If you're only running it for 2 or 3 hours, you only pay for 2 or 3 hours worth of hardware and software. How does it work? Well, we don't use the term server. We're not supposed to use the term servers. Hang on a minute. Sorry, during the day, if I go quiet, it's just I have to cough because I've been talking continuously since, I think, January. We don't use the term server. We don't use the term virtual machine. We use the term instance. So we have an instance of Windows Server running, or we have an instance of Linux or Mac OS. And you say, I want to launch an instance. You tell it which country you want to run it in. So you sit there in the console and you go, I want to run it in this country or this city. I want it to run this software. I want it to have this much CPU, this much memory, this much networking and storage. Click, and it launches. Once the instance is up and running, the server administrators can connect to it and they can configure it. So adding users, installing whatever patches, updates, operating system, applications, things like that. It's then ready for use. So we'll talk from now on about EC2 instances. So it's an instance of Windows or Linux, Windows Server or Linux running with applications on board. So the next question you might have is, well, Glenn, how do I tell how much memory, how many CPUs do I have, and what combinations can I get? And this is where we look at what are the EC2 instance types. So we have different types, different sizes. Basically, it's the equivalent of, say, physical hardware. So I've got 2 CPUs or 4 CPUs or 24, whatever. How much memory? This is where we pick an instance type. Now, just back to the coffee shop for a moment. Let's say your coffee shop is running and you're the barista, you are the cashier, you are the accountant, you do all of the tax and the sales processing and inventory. You've got all of the skills. So you can do anything depending on what's needed at the time. But you're thinking, oh man, it's getting really busy. I'm working Monday to Friday. Now my customers are saying, what about weekends? When we come past the cafe, we love your coffee, but Glenn, we can't get it on weekends. So you think, okay, we'll open every day of the week. And you start to get a bit tired, or you go, I want to go on holidays. So you might employ more employees that could make coffees, that could operate the cash register or the FPOS terminal. And they can do, ordering extra coffee beans if they start to run out. So they've got access to all of the systems. So they have all of the skills, general purpose employees that can do anything. On the other side, you might go, well, we get really busy in the morning. People are heading into work, heading into the office, so they pick up a coffee on the way. Then an hour or so later, they come down from the office or their workplace and they go, could I have another coffee, please? Sure. So you need more baristas and maybe more cashiers, but you don't need more accounting people or inventory people at the same time. So you just decide, I'm going to get specialists. I'm just going to employ people in the morning that can make coffee. And then when they get busy, and maybe 1 or 2 more cashiers just to process all the orders as people are coming in and they're in a hurry. At the end of the month, though, you might say, well, we've got paperwork, all the government paperwork, the payroll, tax, all those accounting bits and pieces. We'll get an accountant in, someone who really knows what they're doing. We'll just get them in at the end of the month. And so you pick and choose different skills to match the requirements at any one time. Computing in the cloud is the same. Some of the instance types we have, the most common one is our general purpose instances. So they have a really nice balance of computing capability with memory and networking, and they'll suit a broad range of workloads. It's a very common way to start customers in the cloud is to pick a general purpose one. Now you're probably thinking, do I have to know all these? No, you just have to be aware of them, because the cloud itself, EC2, will make recommendations. It watches how the instances are running, and if it can find a better instance, and better usually means cheaper, if you can find a better instance, it will recommend it to you. But you usually start with general purpose. You may, though, have a customer who's doing some heavy number crunching, say scientific, statistical, financial calculations, where they need very fast processing capabilities. They could be processing stock transactions in real time. So they want the fastest possible processes. Well, that's where our compute optimized instances come in. So they bias towards fast processes. They have memory and networking, but you're paying a little bit extra for the faster processes. However, if you're running a database, databases love extra memory. If I can hold a database, or if I can hold all of the index tables for a big customer in the memory of the machine, that application will go so much faster compared to accessing disks. Memory is just so much faster. We have memory optimized instances that go all the way up to 24 terabytes of main memory. And some of our customers use that for applications such as SAP with the HANA database. So where you have a customer who's got some, databases that they say these are mission critical, high performance, those instances are probably best suited to the memory optimized instance types. A very specialized type of instance is the accelerated ones. Now, this is usually universities or scientific organizations where they're using graphics processors. The same processors basically that go in high-end gaming machines, and the application can run on those accelerators. You can have up to 8 accelerators in a server or an instance, and that will make those applications absolutely fly. They're very specialized. You don't usually come across them in government and commercial environments, but if you're working with a university or a research organization, they may say, hey, Glenn, can we have an accelerated app because it'll make this thing absolutely fly? Well, in that case, you'd start looking at the accelerated computing instance types. On the other side, some customers go, 24 terabytes of a memory optimized, that's a lot, but we have hundreds of terabytes. We have petabytes of data in our data warehouses. In that case, we can use the storage optimized instance types. They have very high speed storage. They're great for data warehouses and data lakes and any applications that are processing that, say, machine learning. So where a customer has got just, collecting databases for years, and they say, can we put it in a data warehouse? And that often happens when people move to the cloud. They can take advantage of these. So just in terms of what goes where, high performance database, memory optimized. If I can hold databases or the indexes, this application will absolutely fly compared to, say, a general purpose. A data warehousing, so petabytes of data, that's going to be storage optimized. Whereas our general purpose ones, they have that balance, and that's suitable for most applications. That's where you tend to start when you work in the cloud, and then you let EC2 make recommendations for you. Then compute optimized has the high performance processors. So that's how we start to work with customers. We help them to start moving their applications from on-prem into the cloud, and then they can start to tune it based on how the application is running. That's important because if you're working with a customer and they've got some, equipment in their on-premises environment, well, they may have 2, 3, 4, 5-year-old servers. And you want to move them into the cloud using our latest and greatest technology from our tech partners such as Intel and AMD. And you go, well, how do I know what I want? And so it can be a bit of a trap to fall into, to go, okay, let's look at exactly what we have on-prem and let's do all of these calculations. No. What you do is you let the migration tools help you to migrate the customer's on-prem workloads to the cloud. And then if you know where to look, and that's where we'll look, I'll show you a little later. If you know where to look, you can find the compute optimizer. It will go, hey, Glenn, you've got this server that you've moved into the cloud, but hey, it's running on new hardware. You don't need all this memory. You don't need all these processors. Make it smaller. When you hear things like that, here's a better choice. You know that it means it'll be cheaper. So if that's the instance types, so what does it look like? What does the virtualized hardware combinations look like? How do you pay for it? Now, this is probably the biggest challenge for customers to get their heads around. We have on-demand pricing. So that if you go into EC2 and you say, I want a Windows server, I want to run it in Sweden, click run. We start to charge. And then we keep charging until you go, okay, finish with it, shut it down. So turning things on and turning things off. So just running things on demand. There's no upfront commitment. If you create an AWS account and you don't do anything, there's no monthly bill or anything like that. There's no subscription service. It just sits there going, okay, I'm ready. Let me know. It says there it's ideal for short-term irregular workloads. Now, here's a question for you. A customer has their computer room and they have their 100 servers sitting in that computer room. Typically, they're leasing them and they have annual subscriptions on the operating systems. That means that they're paying for that 100 servers, whether they're running and whether they're busy. So your customer, out of those 100 servers, they may have about 50% of them are running mission-critical, always-on applications, such as the SAPs of the world or customer relationship management systems. Email, calendars, because executives tend to work strange hours. So they're always on. But that customer may also have some applications that don't need to be always on. You know, the backup servers, they run a few hours every night. You may have a customer who has a test or development environment. Well, that probably only needs to run Monday to Friday when the developers are working. You may have business support applications, used by your office workers. And again, Monday to Friday. Here's the challenge. If you have on-prem, you're paying for everything 24/7, whether it's running or not, and how busy it is. When you come to the cloud, though, you can ask your customer, what applications need to run all the time and which ones don't? And it's usually about 50% of a commercial or government customer's workloads can be turned on and turned off. Why is that important? Well, if it's running 24 hours a day, 7 days a week, that's 168 hours every week. And let's say it costs $1 an hour, and it's $168. But you work with the customer and he or she says to you, Glenn, for these applications, these ones here, they only need to run when workers are online. They log in the morning, maybe at 7:30 for the early starters. And some of the other people, they go home a little later, maybe 7:30 in the evening. And that's, a pretty wide time frame. And it only runs Monday to Friday. So Monday to Friday, 5 days a week, and running 12 hours a day. That's 60 hours. And at $1 an hour, that's $60 compared to $168 on-prem. And this is where on-demand can offer customers huge savings. If we switch from that 24 hours a day, 7 days a week to 60 hours, that's a 38% cost compared to on-prem. Because remember, it's not just hardware, it's power and cooling, it's also operating system. Plus, it's also the savings that people aren't maintaining the hardware. They don't have to worry about refreshing it. They don't have to worry about breakage, if something fails. So on-demand is a very common pricing strategy. But to get best benefit out of it, talk with your customer about what needs to be running at any one time. Now, you might be thinking, well, that's great, but how do we turn things on and off? There is a system called the Instance Scheduler that you can have it automated. Start this application at this time, so start the instance, shut it down at this time, stop the instance. And that works. Many customers use that to automate starting and stopping systems so that they're only running when they're needed. So that customer with 100 servers in the computer room, when they move to the cloud, there will be many times when they may only have, say, 30 or 40 instances running, say nights and weekends. During peak time, they might go to 100. They may even go more because, many customers are going, look, we've only got 100 computers in the computer room. They're all running flat out. And people are going, oh, gee, it's slow in peak times. In the cloud, we can burst over that. We could go to 110, 120, no problem. We can go as high as they like, and we can go as small as they like. So that's on demand. Spot instances. These are a strange little beast when you first hear about them. Basically, in our data centers, we have excess capacity. At any one point in time, you'll probably find there are some servers just sitting there twiddling their thumbs, waiting for a customer to go, hey, I've got a new workload to run. So what you could do is you can take your on-demand workloads that are running and you go, well, yeah, I'll run them as a spot instance. Why would you want to do that? Because a spot instance can run at a significantly discounted rate. So I could run a spot instance somewhere between 70 to 90% discount compared to on-demand. So, 10% of the cost. The only caveat, the only restriction is if we need that extra capacity back for on-demand customers, the spot instance system gives your application 2 minutes notice before we shut it down. So you're probably thinking, well, that's going to be hopeless for my production databases, my production SAP, for instance. And you'd be right. That's not the use case for Spot. But where you can use Spot is you could take, say, the end of month sales processing. Let's say you're going to produce every month, at the end of the month, sales figures. You're going to produce what we sold this month, who do we sell it to, all that for the sales managers. And then at the very end, you're going to go through the database and you're going to say, okay, we're going to reset the month-to-date sales for all our customers back to 0. Great. You write it as an on-demand application and it will just run. But you could slightly change it and then you could run it as a spot instance. If you do that, what's the saving? Well, 70%, you're running at 10 to 30% of the cost of an on-demand. How do you do that? So I'm running, I'm running through the database. Here we go again. Cough, cough. Sorry, it's because I have to do all the talking. If we were in a classroom, I'd let you all talk, but I have to do all of the talking and it just gets a bit weary. So we're going to run through the sales database. We're going to start at account number 001 and we're going to reset the month-to-date sales figures back to 0. So we do. What we do in a spot instance is we just go, I'm going to write a little checkpoint to a database, and we'll look at one good candidate for that a little later when we do databases. But I'm going to say in this database, I just updated account 001, and I'll move on to 002. I reset 002, and I go, I just reset customer 002. So I update the checkpoint. And as I walk through the database, I write these little checkpoints so that if I do get interrupted, let's say I'm at customer 0057, when the spot instance service gets extra capacity back again, if it's thrown me out, and it restarts my instance for me, the first thing my instance does is it goes, where did I get to? Oh yeah, I'll read that little database. I was up to account 0057. I'll move on to 0058, 59, and it keeps walking through the database like that. So partners use this a lot when we're talking about, workloads that don't need to be always on, that can get a result, say, within a few hours, a few days kinds of things. So Spot's great for that. What was the question? Can you show us an example instance and instance scheduler? Yeah, I can a little later. I'll actually show it how you set that up. I won't show you the scheduler because that's the code's on GitHub. I think it's going to be included in the resources that we send out, where to find it, because it's not part of Cloud Practitioner, the exam. But yeah, I'll show you where to look. So that's on demand. So that's workload starting and stopping. The key word here for Spot is the workload can be interrupted. So you write it so it can expect to be thrown out on 2 minutes warning, and then it can resume. So that's the easy way. If I terminated an on-demand instance and I hadn't written it as a Spot instance, it would start at the very beginning again, and it would probably never ever finish. Whereas here, this one goes, yeah, okay, I know where I was up to. For workloads that are running all the time, though, that your customer goes, Glenn, this is our production SAP system. I'm happy to commit to a 1 year or a 3 year period because it's what our business needs all the time. Then you can get a discount. So you would say, for instance, I want this instance type available for Oracle database, production Oracle database. I'll commit to pay for it. I'll pay for it every second of every hour, every day sort of thing for the next 1 or 3 years. If you do that, you get a big discount. This is the old way we did discounted computing. So a customer would say they'd pick an instance type. So how much CPU memory, all that, they'd say, I'll commit to pay for this type. Over time, though, customers said, yeah, but our demands change, our instances change. And so we came out with compute savings plans. This commits to an instance. This commits to a consistent dollar amount. So your customer looks at their AWS invoices for the past couple of months and they go, hey, we've been paying $2 an hour on average for all the different compute instances we run. And you could propose to the customer, well, what if you commit to pay for $1 an hour? So you take half of what they're running, and only because this is the way it works in the field. You pay for half what they're running, and they go, great, I'll get a discount up to 66% of the comparable costs I was incurring to run my compute. Now, why did I pick half? Because many customers want to start conservatively. But you can add, as they become more comfortable with what's going on, as they can track their costs over time, you can help the customer increase this to whatever they're comfortable with. And I say that because every customer is different. Some are very aggressive when it comes to must save costs, must save costs. Other customers are going, okay, but we've got these roadmaps coming up. We're going to make these changes. So you can just go in small, comfortable steps to suit your customer's culture. But again, these two pricing options give you discounted compute costs, provided the customer will commit to either 1 year or 3 year. They're the only two periods that we offer. Okay, so that's for your long-term, always-on workloads. We have two other, and these are a bit niche. So you don't usually come across these, but if you do, it's great to be aware of them. Dedicated instance says we will allocate hardware to your customer's account. And that customer can run whatever they want in that hardware and no other account can use it. This addresses any concerns your customer has about running in a public cloud where it's shared infrastructure. So, I've got my competitors. They could be running in the same physical hardware as we're running, Glenn. That's not acceptable. Or they run in a regulated industry where the industry rules are no shared infrastructure. In that case, you can propose dedicated instances. And that's why the costs are a little higher, because that hardware is restricted only to instances from your customer's account. Dedicated hosts solves a different problem. Some customers run software that the licensing needs to see the physical server details, how many CPUs, how much memory, things like that. And they license it according to the physical hardware, not the virtualized hardware that an EC2 instance would typically have. Think Microsoft SQL Server or Oracle. They're the two most common applications. And it's the most expensive because of the way we have to manage that hardware. So it's like dedicated hardware specifically for that customer. It's the most expensive hardware option, but it will typically save a lot more in the software license costs. Now, all you need to do is be aware of this. If you come across this in the field, if you're working with a customer and they go, hey, we've got a lot of Microsoft SQL Server or Oracle licenses, and there's probably other software as well, reach out to the AWS partner team, because we have licensing specialists that's all they do. They can work with your customer to say, well, you've got this. If we switch it to this size dedicated host, this is the savings that you would incur. And I've seen this done, and it would save customers thousands of dollars compared to using the other instance types. But as I say, it's very specialized, and it's typically you've got to have a software license that matches this. I want to see the physical hardware details. If you do, the partner team can loop in the licensing specialists. So they're the pricing options that we have. So just a quick check, what would be the difference between the compute savings plans and spot instances? Compute savings plans are great for a consistent, and I always say a dollar amount. It's not like everything is running, you're going to run SAP HANA 24/7. You may have things turning on and turning off, but your dollar amount on your AWS invoice, you can find what's the minimum cost over time, and you commit to pay that, and you get discounted computing. In fact, the way it works, it's super clever. I mean, just assuming there's some technical people on today's class, if I was running a workload at 8 a.m. And I had a savings plan, the savings plan would apply the discounts to my workload. At 9 o'clock, you start up a instance that has a better discount rate under a savings plan. The savings plan switches to yours, and anything left over also is shared with mine. So it's continually hunting for what's the best discounted rates to give to the customer. But yeah, it's always a consistent dollar amount. Spot instances, if there's ever an exam question about what's the cost optimal way to run a workload, and if it says can withstand interruptions, you know that that question is hinting at, have you thought about spot instances? Because that's the trick with Spot. They can be interrupted, and it's relatively straightforward to architect your applications to be interrupted. So we have many of our services these days can be interrupted. Say our machine learning data science systems, they're written to do that because typically they can run for a long time. They usually want large instance types. And so to drive down the costs, customers can optionally specify run the Spot instances. Now you can combine all these pricing options. When we come to the demo, I will show you how a system is turning things on and turning things off, and it is combining on demand with Spot to get best possible compute performance at lowest possible cost. So that is take 100 servers, move them into the cloud, and I've got 100 EC2 instances. Is there something better we can do? And there is, and that's where auto-scaling comes in. So far so good. Auto-scaling is much like the coffee shop. So we start looking to see, are people queuing up? Are the baristas busy, or are they, got time for Facebook and Twitter and WeChat and all that kind of thing? And we look over time and we say, well, look, if there's about 2 customers in the shop, 1 or 2 customers, then we only need 1 barista. And he or she can handle it. People are not waiting too long. Barista's not too busy, but they're not goofing off either. So that in our peak time, if we get twice the number of users in, we probably think, well, we need twice the number of baristas. And so we would work out as the manager, we'd work out the roster. Hey, we need 2 baristas on in the morning, but only 1 in the afternoon, that type of scheduling. But that's not very flexible. I mean, in terms of rostering on employees, it's great because people have to travel into work. You can't tell a barista, hey, suddenly 8 people came into the shop. We need 3 more baristas. Quick, can you all suddenly appear by magic? Doesn't work like that. So you'd have to set up your roster. You'd have to schedule it. Same thing happens in the cloud and on-prem. Now, this chart came from one of my customers who sold building products, so concrete, for instance, as well as other building products. Their peak day was Wednesdays. That's when all the orders were coming in from home handy people, tradespeople, big corporate building organizations. On weekends, it was just the home handy person pottering around the house or the home or the unit. But on Wednesdays, that's where the big skyscrapers are getting concrete floors poured. That's when it got really busy. In an on-prem environment, they would have to have all of the computers online all the time ready to handle this, because that's how computer rooms work. So here's my 100 servers all sitting here ready just for this one day. On weekends, that equipment is still there. It's still powered on. I still have my software license subscriptions running, even though they're not in use. And this is the big cost saving that cloud brings to the table. Auto-scaling says only pay for what you need. So on weekends, auto-scaling would go, if I only need the computing resources to process this workload, only have them turned on and running. Then on Mondays, turn on a few more. Tuesdays, turn on more. Here we're at peak. Then on Thursdays, shut them down again. Shut more down, shut more down. So real pay as you go. Remember that, what is cloud computing? Pay as you go pricing. This is the cloud capabilities in action. So this is where servers magically appear when they're needed and magically disappear when they're not needed. This is what the auto-scaling groups do. So if you've got a customer who's running, say, schools, they're serving the students Monday to Friday during school hours, then some of them shut down at night, a lot more shut down on weekends, and even more shut down during vacations. This is the advantage. You no longer have to provision all of the servers I need to handle the peak anymore. Auto-scaling automatically starts them and stops them on your behalf to drive down your compute costs. So what it's doing, you can say, I want a minimum number of servers to handle, say, the website. So let's say we talk about retail website. In my web server farm, I want a minimum of 2 EC2 instances. They're always on. But when the CPUs get busy and they're busy for, say, a few minutes, so it's not just a momentary spike, it's busy for a few minutes, auto-scaling can be told start a third one. Then it starts watching again. Are they all busy again? Yep, start a fourth one. So you can set a minimum and you can set a maximum, and then it works out at any point in time, it's monitoring the statistics. It's going, hey, these are getting busy, turn more on. These are not so busy, turn some off. And it happens. On-prem, people usually get phone calls or paged. Hey, the system's going slow. Glenn, can you wake up and do some magic? Make something, shuffle some workloads around. Here, this just happens. It also means, too, one of the other functions it does is that if this server failed, if a disk failed or a memory module failed, autoscaling will go, hey, I have to have two. One's failed, start up a third one to replace it. So automatically make a spare server appear out of nowhere. And when I talk to customers in on-prem about this solves many, many problems. And you'll see this in action a little later when we do the demo. So rather than having to roster on baristas, here these things just appear because, you're a coffee shop. It might be, you might be peak period. You've got all your baristas on duty. What happens if a tourist bus appears? How are you going to cater for that? Well, auto-scaling would do that. So auto-scaling is where EC2 instances appear and disappear according to the demand that's of network traffic or CPU utilization. But how do you manage that? How do your users connect to a variable number of web servers? Well, that's where load balancing comes in. So load balancing addresses this problem. I've got my 4 customers, got my 2 baristas, but everyone's queuing up behind the barista that's been around forever, as opposed to few people know the new barista. Go, oh, okay, I'll see how this barista goes, see if they're as good as the old barista. These customers are getting great service. This barista is not so busy. These customers are getting, it's taking a little while, but it's probably worth it because this guy down here, he makes great coffee. This guy's running flat out. You want to have the workloads balanced. So everyone's getting the correct amount of service, same service times. The baristas are working equally hard. How do you handle that? Well, that's where the load balancer comes in. Your users don't connect to individual servers, they connect to the load balancer. So they go to Amazon.com, for instance. Amazon.com probably has load balancers in there, and you connect to that. And then the load balancer knows, hey, right now I've got 2 servers. And it directs your connections to one or the 2 servers. As they get busy, the auto-scaling group does its magic, and I've got now 3, I've got 4. The load balancer automatically knows, hey, now I've got 3 or 4 to pick from. I'll direct the traffic across all of them. So when things aren't too busy, I've only got 2 EC2 instances in my auto-scaling group. My users connect to the load balancer. Get me to Amazon.com or glenscoffeeshop.com. Load balancer goes, great, I've got 2. You go here, you go here. Third user would go here again. So we use round robin here. As these got busier and busier, and auto-scaling goes, I'll give you 3, I'll give you 4. The load balancer knows, hey, now I've got 4 servers to pick from. I'll direct traffic to suit. So it's much like when you go to the airport and you've got, say, your passport in hand. If you ever fly into Sydney Airport in the morning, Sydney Airport is probably at its busiest in the morning because all of the international flights coming in from overseas, they fly overnight. So they all turn up. So they've got, full number of counters for passport officers, all active. Then as the morning peak drops, some of those passport control officers can go and take a break. There's a person at the head of the queue for people coming in, and they go, okay, can you go to this counter, this counter, this counter? A load balancer is doing the same thing. As the counters are staffed by passport control officers, and then as they go for a break, the load balancer, the person at the head of the queue, says, okay, now I've only got half the number of counters open. You have to go here, then the next passenger, you go there, next passenger, you go there. So think of a load balancer as like a person controlling a queue, and the first person you encounter is always the load balancer, the person at the head of the queue, and they just direct you to whatever system is going to serve you. So these 2 often work hand in hand, load balancers and auto-scaling groups. So whenever there's questions about is it a load balancer or auto-scaling, anything that removes or adds the EC2 instances based on how busy they are is going to be auto-scaling. So that's auto-scaling. Adding a second EC2 instance when it's a popular sale. That's auto-scaling. And this is a really common technique. If you've ever seen those poor websites that they go, we're going to have a Black Friday sale, and people go, they all jump on at 5 minutes to midnight or whatever it is and crash, they're not using auto-scaling. They're probably not AWS customers. When you use auto-scaling, you can say, hey, automatically start these things up when it gets busy, or you can go proactive and you can say, we're going to have a sale at midnight, proactively start up a few more. So you can provision these things to a schedule, or you can have it work automatically, or you can do both. So that's auto-scaling, starting and stopping EC2 instances. It's the load balancers that connect incoming requests from customers, internal or external, to the EC2 instances. So that's load balancing. And it also makes sure that not one EC2 instance is working hard and the others are just idling. Does that. Adjusting, auto-scaling, the single point of contact piece is the auto-scaling group. Should I show it? Yeah, let's show it. Okay. So for anyone who sort of followed along, great. If you didn't, here's one I prepared earlier. This is just a very quick sample of what we can do. This is the load balancer. Now, if the technical people want to follow along, I'll put this link in the chat. Here I have a website. It's a very simple website. I am not an HTML coder, but this is just the basics. Hello, training world, blah, blah, blah. Except this time you'll see that these numbers appearing down here. And there's going to be two different numbers. That one and that one. See, it went from 39,220 to this. This is the address of the load balancer. There are two little EC2 instances sitting in my data centers. And the load balancer is sending incoming traffic to one or the other. And some of you are probably seeing different, the same two numbers, but they flip around. Now, usually on a website, you would not show this detail because people don't need to know, hey, which web server served me? But I've got it here so you can see what's going on. Okay, so far so good. That is, I give you the address of the load balancer, and it's the load balancer that connects you to these little servers here. Okay, so far you've got that. Yeah, that's not too bad, because if the auto-scaling group says, hey, Glenn, one of those servers failed, it'll just automatically give me a replacement, but my customers are still getting served. How do I know this? Because we're going to break one. Here we are in EC2. Here are the two servers. Where are they? Running. Here they are here. Now remember those 8.200 and 39.220, if we go back to the website, 39.220 and 8.200. So that is, these two little web servers are responding to incoming requests. Now, why is an auto-scaling group really common? It solves multiple problems. Here is where I set up the auto-scaling group. Now, we're not going to dive into huge detail, but you'll see here, minimum 2, maximum 3, desired capacity 2. Don't worry about this. We'll cover this real soon in the next module. Don't worry about that. You'll see down here, where is it? Activity. And this is what's going on. So yesterday, to get ready for the class, because I've been showing this class, I think, for the past 5 days straight, I was setting things up and breaking things, and I wanted to reset it for today's class, so I ran an instance refresh. I said, just reset everything back to normal. Okay, let's go back to the servers, the little EC2 instances. Let's find the running ones. Let's simulate a server failure. So a hard disk fail, memory module crash, Glenn's written buggy code, data center failure. I am going to terminate it. Server will now start to shut down. Wow, that was quick. Server is now gone. Yeah, it's shutting down. Yep, excellent. Web server, what's going on here? Well, the load balancer is still working, but see how this number is not changing. Now, some of you may have seen temporarily, or really in a really quick burst, you may have seen an error message pop up. If you refreshed it, it would come back up with just this server. So this is how I can build my systems out to be highly reliable. Now there's some more magic that's about to happen. Let's just go down to here. Let us go back to, those two instances. It's shutting down because I terminated it. So that causes it to do a nice orderly shutdown, but it means basically it's going to go away. If I go down to here though, you'll see some magic about to happen. So I'm not doing anything behind the scenes. I'm not doing anything that you can't see on the screen. Here's my auto scaling group. Here's my activity. It's going to report something in a minute. Now, it always takes a little time to make sure, have I really seen a fault or not? And it's going to happen anytime. So this is real time. It's the load balancer has detected I have had a fail. Where is it? Soon we'll see it soon. See, you can tell it's live. Okay, here we will see a message in a minute that it's going to fire up the replacement. What time is it? Yep. Let me check my details just to make sure I haven't broken it from yesterday's class. Yeah, minimum 2 that. Cool. Soon, real soon, because this should still be working. This is still working. The load balancer is still responding. Well, it did this yesterday. It just took about a minute. It takes about a minute for it to detect the server has gone away. Here we go. Here we go. Here we go. These ones. This is today's date. So this is using the time zones. So here, terminating that instance. It's detected. This is the load balancer says, hey, a server has disappeared. So it's terminating that instance. And the next thing it's going to do, because this is right here, right now, so it is 10:40 Sydney time, it's now starting up a second one. So it says there was an instance was started. So a brand new server has popped up. And it's going to warm it up and then put it into service. So if we go back to here, we will see that number soon will start to change. It usually takes about a minute or so because the load balancer sees a new server came up. I'll give it a few minutes. I'll give it a minute or so to make sure that it's all set up, ready, configured, ready to rock and roll. And soon, slow day here in Sydney, soon we will see, where is it? Up here. I'll show you first what it's doing. I'll look at all the instances. That was the one that we shut down. Here is the one, the 23rd. So a minute ago, you'll see it automatically started up the replacement one because our auto scaling group says we always should have 2. So this happened automatically. I wonder if this is now ticking over. Not quite yet, because it usually takes, it runs what's called health checks. So the load balancer connects to the server and it tests, I think 3 times I've got it set for. Is the server ready? Because it does that in case it's installing any software. Let me come to this one. This was the one that just started. We should see a number 20.189 pop up soon. Yep, it's just provisioning itself up. And this is how we launch. This is automatic launching. Like some of you are probably already seeing it. Soon. This is the slowest it's done it all week. So apologies for that. It usually goes a lot faster than this. We could be a little busy somewhere. Let me just check. It'll come up. Oh, I know what. Sometimes my browser caches. Other people usually go, yeah, I can see it. And that. There we go. There he is. It just took a little while. My stress levels have now resumed. But you can see there, it's automatically given me that one. Freshly baked by website. Yeah, exactly. That's it. And that was the new server that popped up. Where was it? Yeah, that was this one. It's 20.189. The advantage behind this is we just simulated data center failure, hardware failure. The other thing I didn't show you is Let's say we had this new server just popped up with whatever the latest version of the software that the developers had produced. Because in an auto-scaling group, the other problem that this solves is this one. How do I update my servers if the developers have said, hey, we've put in this case, a different web page with a different number, or we say we want to go from a 1 gig machine, 1 gigabyte of main memory, to 2 gigs, for instance. I can do that really easily using this instance refresh, and it does a rolling upgrade of the software and the hardware while the load balancer keeps load balancing. So this solves the problem of how does IT have highly available systems that tolerate planned outages, such as updating software, and unplanned outages. So this thing should still be ticking along, and it's flipping between the two. But that number changes. So hardware failure, imagine talking to a on-prem person and you say, what happens when hardware fails? Well, we've got a load balancer. This is on-prem. You go, but how do you replace the failed hardware? Because while that hardware has failed, you're probably not in a highly available configuration. Well, here, because we have so much spare hardware, autoscaling just goes, hey, I want another server. They just went and grabbed one off the rack, gave it to me, and my systems keep running. A huge advantage operationally compared to on-prem. Okay, so that's why we talk about this a lot. Now, we'll come back to see this a little later, because when we talk about global infrastructure, this is how you can help customers go very highly available. So that was that. So that was load balancing and auto-scaling. So right now you've seen something that makes servers appear magically, and I could make these things go super busy, and it would start provisioning up more. If we get time later, I'll show you that. It takes about 15 minutes to show, but I can show you that piece, say maybe over the lunch break. But when you're talking with a customer who's got 100 servers on-prem, now you've seen, hey, well, most times you don't need 100. Now, that's a trap that you can fall into when a customer says, I've got 100 computers in my computer room. What's the equivalent for 100 servers in the cloud? But now you've seen, well, maybe you don't need them all the time. But if a customer says, no, I want 100 servers in the cloud, that's not a fair comparison, because you've seen servers can turn up, and you can flip it around by saying, well, backup servers. We can turn them on only when they're needed. We can turn business applications off at nights and weekends, so we don't need them then. So it's not a fair, give me 100 in the cloud because that's what I've got. Next step, what can we do? This is where customers, and with your help, can start to modernize how their applications work. So now we're going to go one more step. In the old days, when I was a programmer on mid-range and mainframe systems, someone say, hey, Glenn, we want you to write the end-of-month sales processing. Great. What have I got to do? Well, I've got to do extract the data, sort it all out. So component one is getting the data ready. Then the next thing it does is it runs the Australian sales figures. So it runs all the reports for the Australian sales managers, sends them emails, you have done that. The next step it does is it runs it for the New Zealand customers and New Zealand data, does all that. And I could have multiple of these components. And it's only when all of the sales reports are finished that I go, great, now I can reset the database. And what used to happen in the real world was someone here would go, oh, Glenn, can we have another report? Okay, so I have to take this, I have to add in this extra report. When it runs, now my program is going to take a little longer because it's producing this extra report. And then New Zealand sales managers go, oh, we like that report. Can we have a copy of that too? So I have to add in the code for the New Zealand reports. This is getting longer and longer and longer. And every time there's a request to change it, I have to rewrite the entire application, and then I have to retest the entire application. We call that monolithic. Everything's in the one big program. When we come to the cloud, though, many customers want to adopt this idea of modernizing their applications to use microservices. And what a microservice does is it says, well, I'm going to split my application here up into 4 components, 4 separate components that I'm going to do the initial data preparation piece. So, maybe producing a temporary database, extracting all the data from production into the production temporary database, and then my reports can run. I'm going to have all of the, say, Australian sales reports here. And here's all my New Zealand sales reports. but they can run at the same time. They can run in parallel. So that if if the Australian customers go, oh, we want to have more reports, well, it takes a little longer for their stuff to run, but this is also running separately. So it can run at the same time, but it might run shorter or faster. It also means that I can give this program to one developer. Hey, Glenn, can you write this other report? I can give this application to another developer. So my development time is reduced because I can have multiple developers, each one looking after one piece of the program. Here it was poor Glenn had to do all of it, but here my developers are doing multiple things. And it's when all of the sales reports are finished, then I can do the reset the end of, the month-to-date sales figures back to 0. But there's a problem. This can't start until this one is finished. How does it know when this is finished? And this can't start until this is finished. And this can't start until all of the sales reports are finished. How do I tell different components that for the components that they rely on, how do I tell them that they've completed? And that's where messaging services come in. If component 1 says, I've finished, and if component 2 and component 3 go, hey, I just saw that component 1's finished, then they can get started. And 4 has to see, well, 2 and 3 have finished. We will use messaging services to link our microservices or my smaller programs together. It also means too that these are running much faster. So if these are running in parallel, this is probably going to start earlier because these could be auto scaling. We could have different instances, whatever we need. And then this can complete earlier. So much better service all around. How do we do that? There's 2 messaging services. The first one is notification service. Component 1 goes, I finished, and it publishes a I finished message to the component 1 topic. And components 2 and 3 subscribe to that topic. And they go, okay, component 1's finished, and they can both 2 and 3 kick off together. So that's notification service. I have a message and I publish it to a topic. It's like Twitter, Facebook, WeChat, whatever you use, where you go, here's my post or my tweet of the day, and all your subscribers, could be 1, could be 1 million. They'll go, oh, wow, Glenn just posted something. Notification is the same. It's much like a newsletter. So all your subscribers get to see, hey, here's Glenn's Coffee Shop monthly newsletter. But then these people might complain, Glenn, I'm really only interested in the discount coupons. I come in every day and you say, what's the discount coupon for the day? And you go, oh, I've got to go through my social media feeds and find when did Glenn last publish his newsletter? Can't you just post on a separate coupons channel or a coupons topic? Just here's today's coupon. Great. So okay, I'll do that. I start up a new Twitter feed or whatever Facebook has, and I go post. Here's today's discount coupon. These users go, look, Glenn, we live too far away. We don't come in for hot coffee, but we buy coffee beans or coffee machines or coffee information. Can you still publish the monthly newsletter? And you go, okay, well, what I would do here is I'll set up a channel or a topic for Office Coffee Trivia. I'll set up another one for new products, and only the subscribers that are interested in these different topics will subscribe to them, but they all get to see it. So notification service is like a newsletter. I publish a message and all my subscribers see it. But there are times when you don't want that. What if component 1 was producing financial transactions? And if it was financial transactions, you don't necessarily want components 2 and 3 to see it. Say, think an auto scaling group. If I've got an auto scaling group that if it's on the weekends, it might not be very busy. I've got 2 servers in that scaling group. If I'm processing financial transactions, I only want one of them to process the financial transaction. You know, Glenn deposited $10 into his bank account. If they all did it, I'd be great. I'd be lucky. But you only want one to do it. And then as the auto scaling group scales, it goes out to 10. I still just want one to do it. And that's where queue service comes in. Queue service says component 1 produces a message to a topic, but it's only the first subscriber that reads that message gets to see it, and then they can process it. So it's much like the coffee shop. So assume you didn't have any queuing system in your coffee shop. Customer comes in and places the order. The cashier processes the order, writes it down on a piece of paper or the coffee cup lid, and walks around to the barista area. And the baristas are busy. So the cashier just stands there waiting for a barista to get freed up. Could take minutes because there could be a queue of people coming in the door. So he's just waiting. Finally, a barista goes, okay, I'm free. And the cashier hands over, here's the next order, walks back to the cash register and goes, next customer, please. That's not like any coffee shop I've ever seen. What happens, the cashier takes the order, writes down the order, pushes the order over to the barista area, and there could be nothing in the queue. There could be lots of things in the queue if it's super busy. But as soon as the cashier pushes the order around to the baristas, cashier goes, okay, next customer, please. So the cashier can get on with his or her job without worrying about the next step in the process. Then down in the barista area, the first barista who's free goes, oh, look, a new order, I'll take it. So you don't want all the baristas producing all of the orders. So that's how queue service works. So it's similar, but it's different to notification service. Notification, every subscriber sees every message. In queue service, it's just the first one to read it gets it. So if you've got a customer, I mean, one of the common applications for this these days is marketing teams want to process social media feeds. What are our users or potential users saying about our service? Is it good or bad? Well, they'll have it processing systems that go scanning through the text, looking for the sentiment of the text. Then I go, oh, got one. This is a problem. We better get straight onto it, kind of thing. So that's where queue service is often used, where we have a stream of data coming in, and we may have auto-scaling groups processing that. Serverless is magic. There's quite no equivalent in on-prem. You're a developer. Let's say you're the world's greatest Java coder or Python programmer. If you're working in an on-prem environment, you always have to bear in mind that I can only write my application to run on what equipment we have in the computer room. And if it's old stuff, if it's old software, then that's what I have to develop to. And you might get frustrated. You go, but yeah, I just read something on the weekend. We could do all this cool stuff if we were using this version of software. When it comes to serverless, that's what you do. You just say, I'm going to write my code. And it's the serverless compute service that goes and gets the hardware for you. All it means is I can run my code without having to set up any EC2 instances. I just go, here's my code, run it. So I only pay for it when it's running. And you can tell it when to run. So I take my program, my Java, Python, Go, Rust, whatever, upload it to the serverless service called Lambda, and you tell Lambda, hey, Lambda, run my code when it's 1 minute past midnight on the 1st of the month, because I'm going to do end-of-month processing. Or Lambda, run my code when a new file gets uploaded to my website, because I want to scan it for an antivirus. We could be doing, say, class photos. I could say, here's my website. I want everyone to upload their class photo, their photo of themselves for the class. And you go, oh, okay. So you all sit there and you all upload a photo. I can have a Lambda code go, hey, a new photo just arrived on the website. Run a virus scan on it, then produce a thumbnail, then move it to the actual website itself. And so that works really, really well. And many customers use this functionality to link different systems together. It's a very common technique in AWS land to use Lambda functions to say, I saw an event, run my code if a certain event happens. It could be a security event. It could be a data event. You know, a new file appeared or someone deleted an entire folder, do this, do that. So it's a great way to help automation. It's only when that trigger happens, so first of the month, or a file gets uploaded to the website, my code only runs at that point. If it's never triggered, it never runs. It costs 0 cents to run. So you really do only pay for the amount of time. We use Lambda when we want to use event-driven programming, and the event typically could run up to, say, 15 minutes or so. After that, we don't use Lambda, we use other techniques to do it. But Lambda can trigger Lambda can trigger lots and lots of things. And Lambda can be triggered. So remember those messaging services. I might have a Lambda function that subscribes to component 4, that says, hey, the database is finished, now send out emails to everyone. Okay, ready to go. So that's a great use of Lambda to listen to events and respond to events. Another way to do computing, this is what we call containers. Now, you may have heard of containers, but containers is a way where I can take my application. Say I've got 100 servers in the computer room. Each one of those servers is running an application. If I can containerize some of those applications, what it means is that one or more applications can run with other applications on the same EC2 instance. So they're sharing not only the EC2 hardware costs, but also the operating system costs. What it can mean is that I've got hundreds of these applications in their containers, but I only need tens of EC2 hosts. So it's a great way to drive down costs. It also addresses the concerns that customers might have about data portability. You know, Glenn, you're talking about coming to AWS, but that's vendor lock-in. What happens if AWS puts up its prices? What happens if it goes broke? You know, I don't want to be locked into the AWS cloud. Customers often, especially governments, often ask that concern. How do I address vendor lock-in? Containers are highly portable. I could develop my application on my laptop here, or even a Raspberry Pi if I so want, develop it there, containerize it. I can move it to the AWS cloud. I can move it out to on-premises systems. I can move it to other cloud vendors' systems without changing my code. So if a customer does say portability is a concern, we have to have multi-cloud environments, then you can talk to them about containers. Containers are extremely popular. EC2, for instance, runs Windows, Linux, or Mac OS. We run 5 times as many customer applications as containers as we do those EC2 instances. So many customers are looking to containerize their applications. Software developers are looking to containerize their applications because they can now develop their application independently of the customer environment that's going to run it. I mean, you could seriously put containers in a customer's AWS cloud environment using our container registry, and then push those applications out to the factory floor, running, say, Raspberry Pis or on-premises servers. And those applications then keep running, and then when you update your application container, it'll push updates out to those environments. So containers are a very popular way to have portability and easy ways to change up application code. We have 2 container services. The first one is Elastic Container Service. So again, it's Elastic. Customers can add and remove EC2 instances as they want. Now, this is different to EC2 in that it's the EC2 instances, but with pre-built container frameworks up and running. So if a customer goes, look, I want 10 EC2 instances to run containers, they go click in Container Service, and the servers are pre-provisioned with container environments, say Docker in this case. Or the customer might go, look, Glenn, we really prefer the Kubernetes open source, community-driven container framework. No problem. They go, I want 10 instances. Boom, up they come with Kubernetes up and running. So the customer just launches their containers. So that's great. Many customers are using this to give them a lot of operational flexibility and portability. These 2 say, yeah, how many instances do you want? And provisions it up. Fargate says, don't worry about how many do you want. Just tell me, hey, Glenn, here's a new container. Or sorry, hey, Fargate, here's a new container. Can you go run it? So for customers that have different workloads that run different times of the day, different times of the month, and they want to run them as containers, Fargate's a great solution for that. It's serverless containers. So you don't have to say, look, I want 10 EC2 instances to run containers. You just go, hey, Fargate, run my container. And it provisions up the hardware and the containerized software. We also have Red Hat OpenShift. So for customers that have an investment in, say, Red Hat's OpenShift on-premises, and they're looking to either migrate or add additional capacity, just be aware that you can run that same OpenShift software on top of AWS hardware. It's fully managed by the Red Hat team, so it's a very low-risk option for your customer. because Red Hat's site reliability engineers, their support team, is running it for the customer. It runs exactly the same way as it runs on premises. So if you come across a customer with a big Red Hat investment, and I know it's common in some of our ASEAN country areas, if you come across this, don't think, oh, I have to migrate them to EC2. Not at all. You do your customer a bit of a disservice if you suggest that. What you can say is, well, AWS has a fully managed service called ROSA, Red Hat OpenShift service on AWS. How about that? And for a customer who says, look, we just need some extra capacity for a project that's going to run 6 months, perfect option there. Or they go, look, we love Red Hat, but we want to migrate. We don't want to look after hardware. That's another option. Same thing with VMware. We run VMware Cloud on AWS. And back in the old days before this came out, we did have to talk about migrating their virtual machines to EC2. But for many customers, they go, look, we love VMware. We've got a lot of skills. We've got a lot of processes. We've trained all our people in this area. But we don't like maintaining hardware or data center. In that case, they can pick up or set up a VMware Cloud on AWS account. And they may need it only for excess capacity, so a special project, or they might want to migrate to it. Now, we've had a customer do this. They moved their virtual machines from VMware on-premises to the cloud while they were in production, and no one noticed. They did that during business hours. So it's a very powerful idea if you come across a customer with a big VMware investment and they go, look, we don't want to have to convert. We don't want to migrate. We just want to get our virtual machines running on someone else's hardware. So that was that. So we looked at EC2, we looked at auto scaling, we looked at we did a lot. Let's take a break now. I've been talking for a long time, but you've now started to see some big differences, some great simplifications that when you talk to a customer in on-prem, you go, well, the cloud can do this and this and this, handle hardware fails, handle data center fails, do software upgrades while having systems still running. Is that of interest? I'd be stunned if any IT manager says, no, I don't need that. This is where cloud is such a powerful idea. And we're going to start to explore that next, but we'll first take a break. How long does this one give us? It's either 5 or 10? 10 minutes. So we'll take a 10-minute break. When we come back, we're going to do global infrastructure. So how does all this magic start to come together? And how can you use it to start helping your customers get highly reliable, highly available systems? So 10 minutes, and then we'll launch into that. All right. Let's do a quick knowledge check because we just did a lot in that module. Because from an on-premises viewpoint, some of the things that you saw then are techniques that you can take into the field, and customers literally could be blown away. It's that easy to do the following. You can do all of this. That solves a lot of problems that on-premises IT teams face. But just to make sure that we're still on track for anyone who's attempting the exam, now this is another question, a trick. It's not a trick question, but there's an option in here. Well done if you picked A and C. The option is select 2. If you're going to do the exam and you only put one answer in there, there's no half marks. You've either got to get the question correctly right or it's classed as incorrect. But when you get to the end of the exam, and we'll look at it as a strategy, it will tell you, hey, Glenn, I wanted 2 answers. You only gave me one kind of thing. You can go back and quickly review it and go, oh, yeah, second one. But 1 year and 3 years. Don't ask why those combinations. It's probably in the deep history of AWS. Okay. Another question. Now, if you're not sure what the answer is, eliminate the ones you know that are wrong, and then sometimes just guess. But see how you go with this one. Woohoo, people are picking D. Now, why did I say eliminate the ones that you know are wrong? Okay, some of the key question parts here. A total of 6 months. For reserved instances, you'd have to pay for 12 months, whether you use 6 or not. So that wouldn't be cost efficient. So A is out. Dedicated instance solves the challenge of a customer saying, I don't want to share infrastructure. So that doesn't really apply to costs. That's out. In fact, it's more expensive than these two. So that's out. So now you're down to on-demand or spot instance. Now it says the most cost efficient, and it also says can withstand interruptions. So these two kind of could fit. This one definitely fits. On demand, yeah, well, it could withstand it because it'll just restart. So it's probably not the most efficient. And comparing price for price, because it says cost efficient, spot is more cost efficient than on demand and it can withstand interruptions. So you want D. Okay, here's another one. When in doubt, you'll be left with a choice of 2 if you're not sure. Then pick which one you want. Okay, lots of votes are in. It's not Lambda. Lambda is serverless computing, and this is about one of our messaging services. So Lambda's out. Kubernetes, that's a container system. That's out. So is it queue or is it notification? Now, if you don't get this one right, just be aware that sometimes this is a real English as a first language question. You want to give users messages. It really should say you want to give all your subscribers all your messages. But this is notification. Queue service just gives a user messages. So the first one who reads it gets it. Whereas this is really suggesting that you want all your users or all your subscribers to see all the messages that you publish. So this would be notification service. So think newsletter, think coffee queues. So you just want one barista producing the coffee. You want everyone to read your notifications. So that was messaging services. That was computing. That was a whole lot of things. So your customers probably be thinking, yeah, this cloud now, that solves a lot of problems. I don't have to take 100 servers and always end up with 100 EC2 instances. I can have them appear and disappear. They can certainly appear if there's a fail. Tell me about where does this stuff live? So this is where we look at global infrastructure and how you can use our global infrastructure, basically our data centers, to help customers get very high availability. So we're going to look at some terms such as global infrastructure. We'll use the term region. We'll look at availability zones. We'll look at some services here that accelerate traffic to all around the world. And then how do you start provisioning these things up? So here's a very common problem for a small, medium customer. You got your coffee shop and all things are working fine, and then there's a parade and the streets are blocked. Or there's a power fail or a flood or a fire. What happens? The business stops. Customers can't come here. So what you'd probably think is, well, yeah, what if we had a franchise or even a coffee stall pop up, something like that? So at least my customers could come down here and get what they want. That way they're not going to go to my competitors. And this is very common with small to medium customers. They'll talk about, we have our production data center and we need to have a disaster recovery data center, so a second site, so that if some problem happens in production, at least the business can operate at least some of the key applications in the disaster recovery site. But here's the problem. That's a second site plus all the equipment that you have to pay for and manage. And it may or may not be in production. It's like insurance. You pay for the insurance on your property or your car or whatever you have, and you hope you never have to make a claim. But if you do, it's ready to go. Except here, you've got to patch the hardware. You've got to periodically replace it, because even though it's the stuff in the disaster recovery site, yeah, that has to be retired and replaced. Otherwise, it's just getting worn out. So that's another burden on the IT team. So I've got to have resources maintaining this system and this site as well. How can the cloud help? This is where our global infrastructure comes in. So again, rather than talk about it, I'll show it. We have multiple regions. I think we're up to 26 regions now, which is basically cities where we've got data centers all around the planet. So if I look in our Asia Pacific basin, for instance, what do we got here? All of the orange circles are current AWS regions. So I'm based in Sydney. I work with the Sydney region, but I also can put systems into Jakarta, Singapore, Mumbai. We've got a few in Japan, a few in China, and more are on the way. For anyone here from New Zealand, we'll have our region in Auckland, I think, at the end of 2024. We have a second region spinning up in Melbourne. Jakarta went live in December last year, so it's brand new. Well, it's been running for a little while, and they're still putting new systems into place in there. So this is where our infrastructure is sitting. A region consists of the data centers that we have. And you'll see down here, for instance, Sydney region. We have what's called 3 availability zones. So we take all of the data centers in the city and we group them or cluster them into availability zones. Each availability zone is physically isolated from any other availability zone within a region. So Sydney's got 3, they're about 20 kilometres apart. So they're on absolutely separate power grids, flight paths, floodplains, fire zones, the whole shooting match. So that if we did have an issue, say an impact or something like that with one availability zone, customers could keep running their applications in our other availability zones and still be within that region. We'll see that's why that's important soon. The third piece of our infrastructure is called edge locations. Edge locations are a tiny amount of AWS hardware and software that we typically install in an internet service provider or a telecom partner. And that acts as a cache or an accelerator serving customers close to here that are not near the regions. Why is that? Hands up if you thought that we would be talking about Albert Einstein and the speed of light today in this class. And every time I ask that, no one puts their hands up. But that's what we're going to talk about. If I'm in Perth, so Australia, on the other side of Australia, if I go click, so if I make a request of a service that's in Sydney, my communications request travels at the speed of light effectively, well, close to effectively the speed of light. It takes 11 milliseconds if I have the fastest dedicated connection to go from here to here. In fact, going through Australian networks, it's probably a bit slower than that, but 11 milliseconds, because it takes light a certain amount of time to travel distance. So it's 11 milliseconds here, click, and the servers respond. Oh, okay, I've got what you want, send it back, 22 milliseconds. If I send it up to here, it's going to take longer because it's further away. If I send it to the US, it's going to take longer again. Edge locations are used to accelerate the performance of systems, such that if I'm in Perth and I connect to the Perth edge location, if the edge location is caching data that I want, it says, zip, much, much faster. Within milliseconds rather than 11 here and 11 back, or 100 here and 100 back. So that's what edge locations do. They do not run any processing as such. They run a tiny amount, but they don't run any major processing. It's not going to run EC2. EC2 runs in the availability zones within a region. But if I'm sitting out here and I say, hey, I want to connect to Glenn's coffee site, my coffee site runs here, but if I've had other users in Perth try to connect to it, they go, oh, I've already got most of that coffee site here. Here it is, much, much faster. So that's how our global infrastructure works. It's where our hardware and system software is sitting, delivering these services. So we have these regions. So we've got the Sydney region, Hong Kong, Singapore region, Japan, Hong Kong up there, Jakarta. And within those regions, we have our groupings of data centers called availability zones. So first things first. How do you pick which region? The first criteria is nearly always a customer who says, Glenn, our data must reside within our country. So data sovereignty or data governance. Typically governments, so countries' governments will say, our data cannot go offshore. In which case you pick the closest region. So in Australia, we would pick the Sydney region. Elsewhere, you'd pick the region in your country. The next criteria is putting services close to the users. Now, when 2020 and COVID first impacted, I was at TAM for some customers who were working with partners who had offshore development and support teams. So we were working out of Sydney, but we had partners who were based in Mumbai and the Philippines. Those partners were saying, hey, things are getting really slow because work from home networks were starting to bog down, and then communications channels across the oceans really getting slow. So all we said was, we'll move your virtual desktop services that were currently in Sydney, we'll move it out to Mumbai, or we'll move it to the data centers very close to the Philippines, so that any latency, because of that distance and communications bandwidth, that was greatly reduced. So moving systems close to customers. Some of our media streaming customers will use services in all our regions so that their subscribers get the fastest possible performance. Depending on your applications and depending on your customer, having a design that says I will put parts of the applications in multiple regions can be often a quite effective way to do it, as opposed to the customer flying their server teams and data center teams into remote countries to set up data centers. And that's why my old Dell Merchant Bank customer now runs on AWS. Having services available within a region. Now, we're very lucky in the Asia Pacific area that I think just about all of the services that AWS offers are available locally. Jakarta is still spinning up, so they're gradually onboarding more and more services. So they're a little behind everywhere else, so they don't have everything ready. But most of our established regions have all the AWS services available. However, sometimes if we're releasing a brand new service or we're updating a significant feature to an existing service, we may have those updates and new services available only in a specific region. To give you an example, I was working with an Australian government health organisation, and they wanted to have a chatbot so that you could ring up and you could say, I'd like to find a doctor, please. And the chatbot would answer, not in a robotic voice, but basically, where are you? Which city or which town are you in? Now, I don't know if you've ever been to Australia, but we have some unusual place names like Woolloomooloo and Wollongong. And the voice to text translator struggled with Australian place names and Australian accents. Because if you look at how do you spell Wollongong, it does not look like Wollongong. And Woolloomooloo is the same. We had a whole lot of these. So our development team was working on, can we incorporate Australian place names and Australian accents into the voice to text translator? Because that way the chatbots could then read the text. They go, okay, I know where you are. Here's your closest. While that system was being built and tested, that update was only available in the US. Now, my Australian government customer goes, hey, Glenn, this production data cannot leave Australia, but test data could. So that customer was working with their test systems and they built out their prototypes ready to go, so that when we said, great, this service has gone general availability and it was made available in Australia, they had their service running up on day one. But it did mean that for that period of time, they had to use the development service that was sitting offshore. I think it was in the US. So sometimes we have services not yet available in your nearest region. You may work, or you may need to work in another region. The last one, and this doesn't really impact us at all, is the cost of services. Again, in this region, we're lucky that the AWS service costs pretty much mirror elsewhere in the world. But say in South America, they have very high tax rates. And so many of our South American customers will run their production systems in South America because of data sovereignty and compliance. But they run their development systems offshore just to reduce the tax burden. So you get taxed on where does a service run. So that's one aspect. But as I say, most customers in our region, we're fairly lucky, so that's not a concern at all. So that's how do you pick a region? These are the biggest two, these two here, just putting things close to users so that they're not experiencing those long communications lags, and data compliance. Okay, availability zones. How does this work? Why is this important? Well, when you're running an EC2 instance, it physically sits on one of our servers somewhere in a data center. And our data centers sit in availability zones. So I will spin up, say, SAP, and let's say it's production mission critical SAP. I might have pieces of SAP running in this availability zone. So in this case, 1A, other pieces running in 2B, and this is running completely separate. If this data center or this availability zone had a problem, say a road digger tears up all of the communications pipes in, or we had a fire, heaven forbid, or a disaster, if these systems were not available, the customer can still use the systems over here. Because up here is our old friend, that load balancer. As users connect to the load balancer, it goes, well, I can direct you to here or here. If here falls over, all traffic gets routed to here. So very much high availability. The links between our availability zones are very high speed, typically single-digit millisecond latency. If that means nothing to you, don't worry, it's not in the exam. But if you are a technical person, especially architects, it's often the difference between us and other clouds in that it lets customers build applications that are synchronously replicating. That single-digit millisecond latency can be critical. I've had some customers choose AWS based purely on that. It just means that they have systems that are highly available. So let's say I have my application here and here, and this happened with one of my SAP customers. They wanted to upgrade this site, so they were going to take all of the applications down. To solve that problem, before they took this down, they spun up SAP in a third availability zone. And that meant that when these were taken down for major upgrades, they were still in a highly protected fault-tolerant configuration. They were in two physically different data centers. The load balancers were directing the traffic between the two. When this was patched, ready to come back into service, they brought this one back up and they took this one down so they could patch or do whatever they were doing for that. And again, that was using this and this, and the load balancers just directed traffic. When this came back into service, they then shut this down. So at no time could their customers or clients be impacted if one of our data centers failed, because they always had at least two up. And just to show you that, if we go back to our little EC2 instances, what you see, but you probably didn't notice, but now it makes a lot more sense, is here's the two. Oh, hang on, I'll show you the three. No, we'll go show you the three. Where were we? Three works better. You see here, we're in the Sydney region, so it's the region. You can see here I could pick from any region I'm allowed to operate in, so anywhere around the world. You'll see here, one server is in availability zone 2B, one is in 2C, and the one that we terminated was in 2A. So we're taking full advantage of AWS's infrastructure here, and we're saying, hey, I want to run my website in such a way that if the entire data center failed, its replacement spin up somewhere else. Now imagine a customer trying to do that. You know, we've had a problem in our production site. Okay, let's start paging everyone. We'll fail over. You saw that happen automatically. It took, a couple of minutes. Sometimes it goes faster than that. Sometimes it goes slower. One day I'm going to have time to work it all out. But yeah, it was up in a few minutes and I didn't get paged. No one saw my mouse move, off the screen. There was nothing behind the scenes. It was just automatic. So I've got two different data centers. I've got my applications spanning these. I can do the same with internal apps. So just don't think websites. Internal applications can do it. Databases can do it. So that if an entire data center, as we simulated here, fails, my applications keep running. My clients coming to my website still get their coffee orders. So imagine explaining that to a customer, that how do you handle data center failovers or business continuity or disaster recovery? Usually they go, oh, okay, we have to go here. We've got to open run books. How do they know? Well, they probably don't know until the help desk phones start ringing. Hey, what's happened? Well, here you saw it happen automatically and users weren't inconvenienced. They could still come to the website. So this is where we are really starting to show a customer, these are all of the things that you can do in the cloud very easily, and it's very difficult to do on-prem. Okay, so that's region. So a region consists of two or more availability zones. And the availability zones are just our groupings of data centers where we have one or more, usually more data centers in the availability zones, physically isolated, physically separated, but with very high-speed communications links between the two. Okay, next step, how do you get closer to customers? And we already said this is where Albert Einstein comes in. So just high school physics. Assume we've got a coffee shop and assume it's in the east coast of the US and assume that we're serving people all around the planet. Don't assume we're selling hot coffees all around the planet. Not even Amazon Prime can deliver hot coffee to anywhere, because the closer you are, the faster you get your delivery. Further away you are, it's going to take longer. And I don't know how you would keep coffee hot if you were trying to serve it to someone at the top of Mount Everest, which is what this user looks like they are, where they are. But we've got our coffee shop. And users that are further away going, Glenn, can you get deliveries to us faster? That'd be nice. So what you might do is, well, I've got the coffee shop here. What if I set up a coffee stand? And a coffee stand has got the most commonly asked for products for these countries. Customers can quite happily order, yeah, I'll have one of these. And if the coffee stand has got it, it ships it out to the customer much, much faster. Where a customer asks for something that the coffee stand hasn't got, coffee stand goes, oh, I haven't got any of those. Hey, coffee shop, can you ship me a box of these things? Coffee shop sends it to the coffee stand. Coffee stand places all the supplies all the orders. So that is what we would call global content delivery. How do I deliver my products, my information, my web pages all around the world? Well, I've got a global content delivery system. And this is where the edge locations come in. Let's say I have my website running in the AWS region in South America, down in Sao Paulo. And let's say I've got all my local language travel videos from South America. So hola or oi, 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 depending on which country you come from. That's about as far as I get with Spanish and Portuguese. But I've got my videos down here, local language. Plus I've got my local news. Say maybe it's the local sports results. And I'm serving the South American continent. That's working fine. Everyone's nice and close, really quick. But my video of Machu Picchu, it's a beautiful place, I'm told. I've never been to South America, but if you've ever been there and you've been to Machu Picchu, it's apparently spectacular. My travel video of there goes viral. People all around the world are going, I want to see Glenn's video. We have a user here in Hong Kong. I want to see Glenn's video. So they connect to their internet service provider who happens to have an edge location. Edge location. Have you got Glenn's video? No, I don't. No one's ever asked for it. So it has to connect to my web server out in Sao Paulo, and it starts to stream it down to my edge location, and my edge location serves the customer. Did the customer get any benefit from that? No, because the edge location did not have a copy of my video. It went and got it, but it worked out how to get it. However, a second user goes, hey, that video looks really cool. I want to watch it as well. User connects to the same edge location, and this time the edge location goes, I do have a copy of that. And it streams it straight away. This user may have waited a few hundred milliseconds for the movie to start or the video to start. This user, much, much faster because they're much, much closer. So we have, I think it's 26 regions, something like 80-something availability zones, and over 300 of these edge locations. The whole idea is it lets the edge locations stream data or send data to customers much, much faster, provided they've got it. Now, you might be thinking, well, how do I use this? You can't use edge locations. You can't use regions. You can't use availability zones because they're part of global infrastructure. But you can use the services that sit on top. And the service that sits on top of an edge location is called CloudFront. And it's our global content delivery service. So if you've heard the other systems like Akamai or Cloudflare, same thing. It's working with our edge locations to cache data here to serve frequently requested content to users locally so that they don't have to spend time going backwards and forwards to the remote locations. Now, because this is an AWS service, it means that the webmasters can interact with it and can configure it. Now, my videos aren't going to change that much. Once I publish it, that's set. So I might say, hey, edge locations, if someone asks to see the movie, then hold it in the cache for 24 hours, 48 hours, however long I want. And so it's always stored here. And I'd probably say time it out because after a while, people aren't going to watch this month's movie. They're going to watch next month's movie. So I can tell it, cache it for, say, 24 hours so that if other users ask for it over that time period, they just have to go to here. News, however, well, that's changing all the time. Sports results. South America's sports crazy. I might be updating my sports results every half an hour, every hour. I could tell CloudFront, cache my videos for 24 hours, but cache my data for sports results for only an hour because I don't want people seeing old news. I want them to see the latest. So I can interact as the webmaster with CloudFront to make sure that my users anywhere on the planet are getting the fastest possible performance in terms of their applications. So this answers the question, if you've ever gone to a website and you go, gosh, this is slow, and it's building up, it might be getting this headline, and then you see, okay, now this appears, then this appears, then this is what CloudFront is addressing. If this is commonly asked for content, it'll have it stored in the edge location, so you get much, much faster. So edge locations, they go into our telco partners, and they're used by all of that telco partners' customers. Outposts solves a different problem. Assume the coffee shop goes wild, and you're making millions of whatever your local currency is, pesos, dong, dollars, ringgit, whatever. You've got now corporate headquarters. You've got the roasting plant where you're roasting coffee, by the tons every day. And you've got lots and lots of employees. And sure enough, there's no local coffee shop because that was the last thing you thought of. So if employees want coffee, they have to walk, bicycle, drive to the coffee shop, and then they have to come back. Maybe it's 10, 15 minutes to do the round trip. And you're thinking, there must be a better way. And people, they're not going, oh, there's my lunch hour gone just to get coffee. So you talk to the coffee shop and you say, can you put a coffee stand in my premises, in my factory? That probably only has hot coffee, so it's a stand, not the coffee store. How would that apply in hybrid cloud computing? And that's where Outposts comes in. Outposts is a collection of AWS hardware and system software that can be installed in a customer's premises. So that rather than having the long latency going from, say, on-prem here to the cloud, you may have a customer who has systems in a oil rig, a jungle, the Australian outback, where communications can be very expensive or can be slightly slower than normal. It's just you haven't got the high-speed connections you get in the cities. Your applications may demand, we need to have very low latency. In that case, an Outpost system can be installed on the customer's premises. It runs a very broad subset of the services that we offer. So that's why I put a coffee stand there. It hasn't got everything that a region has or an availability zone has, but it's got, say, the compute, the storage, database, networking. It can also run VMware if you have a VMware customer, because that comes up a lot. A customer says, we're running VMware applications in our factory floor. What can we do? I can do that. For purposes of the exam, this definition often pops up as what's an outpost or what does it let you do? So it extends the AWS infrastructure back out to on-prem. Why do customers want to do this? They want to run AWS services on their premises. So they like the software, but they may have an unusual requirement to run it on a premises. They may have, say, regional offices that are all communicating with very high-speed links in the city, but coming out to a remote location, they might go, oh, communication's expensive, variable, performance and all that, and Outpost comes in. In the real world, if you come across a customer who would be a user of Outposts, talk to the AWS partner team because we have specialists in this space. Conversations with customers around Outposts get very technical very, very quickly. And there's no way we have time or the skill set to cover all the combinations on Outposts. But you might be working in a country, say Vietnam, Thailand, where we don't have a region. But customer goes, data sovereignty, Glenn, must have that. This potentially, I say potentially, could be a solution. Now, for some countries like Vietnam, like Thailand, Philippines, we have plans to build availability zones called local zones in those areas. That's a different way to solve it again, well outside the scope of this class, and they're a future. They're on the roadmap to happen. So where a customer says, I have to have data sovereignty, I must have local processing, Outpost extends the cloud back out to the customer's environment. How do you interact with services? And this is kind of interesting. Imagine you got your coffee shop and customers can come in. I'd like to order a coffee, please. Oh, I brought my own cup. Can I have a refill? Or what's my monthly balance? Or here's my frequent flyer. I've got so many clips on my card. Can I have a free coffee or something like that? That's all great. And then the customer comes in and starts speaking in Mandarin, asking the same thing, or German or French or whatever. How do I deal with this? Well, that's the same problem that our service teams have. When they build an application or a service, you've got customers with different devices, so a laptop, a tablet or a phone, running different operating systems, running different browsers, speaking different languages. How do you deal with that? So what the service teams do is they go, well, here's EC2. I'm going to publish what's called an application programming interface, API. So much like a menu. And to interact with the service, you pick, okay, I wish to create an EC2 instance. Click. And your device, the software and the hardware, makes an API request. The service checks, are you allowed to do it? Yes or no? Boom, done, provisioned. So you've got your EC2 instance, you've got your load balance, you've got it, whatever you want. So we interact with the cloud using API requests. And how do we do that? 3 ways. The first way is the console. Now, you've already seen pieces of that when we did that demo. That was part of the EC2 dashboard in the console. But basically, I start up a browser session, and my browser makes the API requests on my behalf. You may have a customer though that goes, Glenn, we're a Linux shop. We use bash scripts, so script files, or we're a Microsoft shop. We run PowerShell scripts. Great, you can use those, and your system will use the command line interpreter to make the appropriate API requests. Third way we do it is my program. I want my program to interact with the cloud. So my wife would tell you that one of the things I'm really good at is making mistakes. And so I'm writing, with your help, the end of month sales processing, and I am supposed to reset the month to date sales figures. But knowing me, I could easily change that to the year to date sales figures. And that would be a bug. Resetting the year to date sales figures back to 0 and we're only in March, that could be a disaster. So what I'd have my program do is when it got to that point, AWS backup, can you request a backup of the database, please, in case I make a mistake? So your programs, your code can interact with the cloud using software development kits. And we also have an automation system called CloudFormation. And it's like a recipe or a template system. So we get to the end of the month. Then we say, hey, CloudFormation, create me up a temporary database table, because I'm going to extract the data from the production database into the temporary one. I want a couple of EC2 instances. I want them networked together like this. I want to have this kind of security. Provision it. Click. And the CloudFormation template just builds out everything I had. And then when I'm finished with it, I go, hey, CloudFormation, shut it down. pay as you go. Shut it down now. And it knows how to pull them all down again. So we can automate a lot of this. And this is, again, another key piece of the cloud, doing this automation. This is great for one-offs. So I want to create a EC2 instance or a load balancer. This is great when I want to manage multiple devices, maybe in multiple regions. And this is where my application itself, it knows, hey, I've got to this point, take a backup, do this, do that, whatever. So multiple ways to interact with the cloud. Oops. So we did all that, but as you probably know now, we could take if we take a 5-minute break, that'll be good, because the next module goes for SDK. SDK examples go way past the scope of this class. It would take too long to do it. You can find it in the documentation. That's the easiest place to look. So I can't show you any of that. What we will do now is, because the next module goes for about 35, 40 minutes, and it's a tough one. If we take a 5-minute break now, then we can come back. Then we will be set up for most people for lunch. So let's take 5 minutes. Hopefully this says 5 minutes, not 30 like it did the other day. Yeah, 5 minutes. We'll come back. We'll do networking, and then we'll be ready for lunch. Hang on a minute. Time to fail over. Let me just check. Yeah, just bear with me a moment. This network is falling over because there's a storm on, or about to be. I will just set this up. Cool, so people can see it. Yeah, I'm just setting up in case this network completely and utterly drops out. Okay, so, sorry, yep. It's just when I keep getting messages saying that the network is having trouble, I tend to worry a little bit. Correct answer here is D. So yes, a region consists of 2 or more availability zones. Okay, when you choose a region, what are some of the factors that you should consider? A and B, A and B. Okay, A and B. Yeah, A and B. Absolutely. And I like the fact that people pick 2 because that is the exam, one of the exam tricks. How many answers does it want? A and B. Yeah, there's a few. Yeah, everyone's getting CloudFront is the global content delivery service. Now, because it's a service and it's got Amazon CloudFront, it's the piece that customers and partners can interact with, as opposed to the next piece. So, correct answer there is D. What does CloudFront do or use to do its magic? Yeah, lots of votes for A. That's correct. So the difference is customers can interact with CloudFront, but they can't interact with global infrastructure directly. And we'll talk about that when we look at the shared responsibility model this afternoon. Okay, the last question in this check, what can you do with an outpost, please? Well done, well done. So it's used to extend the infrastructure to on-prem. But as I say, if you do have a customer you think this could be a solution, absolutely reach out to the partner team because we have specialists who just work with outpost systems and they've seen all those conversations. Now, because we're doing things out of order compared to yesterday's class where we ran on Singapore time, we've already done this demo. In fact, we simulated a server failing or an availability zone failing. When I deleted that that EC2 instance, that would be as if the load balancer lost connectivity to it. So it's like we took out an entire availability zone or an entire data center, and we saw the service quickly spun up, or reasonably quickly spun up another EC2 instance to replace it. Later on, if anyone wants, we can run stress tests and all that kind of thing, but you get the idea of what's going on. The only other thing I didn't show you was how did we mix on-demand and spot pricing. And this, again, is where partners add a huge amount of value. If you know about those different pricing models, so here we have, here's our 2 instances. If I go down here, this is where we mix and match all of the pricing models that we have. And customers use this very effectively when you show them how to do it. This is the auto scaling group details. Down here, here's the purchase options. I'll make it a little bit bigger in case you're running on a small screen. Designate the first of the 2 instances, so the first of the minimum, as an on-demand instance. And then from then on, use 100% spot instances. In production, now remember this is a class environment, but in production, I'd say set my 2 minimum instances to be on demand, so they're always available, not going to be interrupted. But then if it says I need extra capacity, definitely use spot instances. If I do that, if these are going to run all the time, if this is my production website, I can then say, hey, these are going to run 24 hours a day, 7 days a week. Don't use on demand, use reserved instances or a savings plan. So these get discounted. And then only when the website goes, hey, we're under pressure, we've got lots of users connecting, hey, then it'll spin up spot instances. So I can mix and match here very, very easily. What's my pricing model? Now you're probably thinking, well, that's okay, but what did we save? If I look at spot requests, it will show me what have I been saving. So that's the one we shut down. Oh, shut down. You say this is the one we started up before. Saving summary. Here it shows you the difference between the spot price and the on-demand price for my little website. So I'm saving 70%. And that's not too bad. These are tiny instances running Linux. It says here was the on-demand price and here was the spot price. So that's over, 38 CPU hours. So this shows you the kind of price tuning that you can help a customer to achieve. And again, this is a partner value add. I don't want to have anyone leave this class and get challenged by a customer. This stuff looks easy. Why do I need you? You just saw a really easy way to help a customer go, we'll give you the best possible price to run that minimum. So you can run that on demand, or you could say reserved instances or cost compute savings plan. And then for those occasions where you do need extra compute capacity, run it as spot, because they're the same code, same hardware, it's just how we price it. So that simple little trick there in that auto scaling group configuration is one way to do that. And partners do that a lot. If you're used to running on-prem, you wouldn't even think how to do that. You wouldn't even challenge it. You know, you're used to running 24 hours a day, 7 days a week. And you come along and go, hey, we've got all these flexibility, all these different modules. We could do that. So that's a very common technique, mixing and matching on demand with savings, on demand with. Now you might be thinking, well, what happens if I was using that? There are techniques and strategies we have to adapt for that. What I didn't show you in that auto scaling group is it can use from a range of instance types so that if it can't find the cheapest one, it will go for the next one up. It still works out cheaper than on demand, but you know, the server's got a bit more extra capacity. So it's very, very flexible. Later on, we'll look when we do storage, some other cost techniques that you can implement. But let's get on and do networking because I'm still getting these little notifications that my network is all over the place. So speaking of networking, we're going to do the basics. Now, don't worry about the details. I'll show you what you need to know for the exam, but we'll also do a quick little demo if you get time. The plan is to finish this in about 25 minutes or thereabouts in case anyone has to dive off for lunch at a set time. Networking. Why do we care? Well, in a coffee shop, we probably want our customers to talk with the cashier, to place their orders with the cashier. And it's the cashier that gives the orders to the barista. We don't want really having customers trying to place the orders with the barista. Now, they're going to go, look, I'm busy making coffees. I haven't got the cash register to talk to the cashier person. So we really want to stop that happening. And in some coffee shops, they may have big signs up, place orders here, or the baristas have their coffee machines in front of them, so you can't really talk to them. You know, they've got the steam coming out, the machine is physically big, so they're sitting behind that. So it makes it hard for the customers to talk to them because this is the workflow we want, customer to cashier and cashiers talking to baristas. It's the same in the cloud, except here, this would be our web servers, this would be our databases. I want my customers only to talk to web servers, and I only want the web servers to talk to the databases. I don't want customers going anywhere near my databases. So with that in mind, how do we start? The very first piece of networking that you get when you set up an AWS account is a virtual private cloud. And it's a network. It's your own private piece of AWS heaven where you have your own network with your own network addresses, and you can launch whatever resources you like within that cloud. And the thing is, it's secure. Only you can do it, no one else. So it's your virtual private cloud. You have one in every region. It's your default one, so that if you're in the Sydney region, you have your Sydney VPC. If you switch to Singapore, you have a different VPC. But you've got your own networking set. And then you can say, well, I want to have my web servers sitting in a public area, but I want my databases to be well protected. What you do then is you take your virtual private cloud network and you divide it into sub-networks. If you've ever used your home networking, say you've got fixed broadband and you've seen a router that's got numbers like 192.168. something, networking uses numbers, much like the phone system. If you've ever tried to call someone via the phone, like your hand phone or your mobile phone, you have to know the number. You can yell at Siri all you like, hey Siri, call Glenn. But unless Siri has an entry in your address book or your contacts list, Siri goes, well, what's the number? Networking is the same. Networking relies on network numbers. And we'll see later how you change a domain name like Amazon.com into a network number. But I can take these network numbers and I can group them. I can put them into groups. Say for the public network, I might subnet. I might put in all my web servers in here. I might have a private subnet for the database servers. I might have another one for sales applications, another one for finance applications, and they're all separate. So I've got my web instances here, my databases down here, and as long as I allow them to talk, then they can talk. So I've got to set up those permissions. And how do I do that? Well, here's my client system. And I have my client, this client system is trying to make a request. Connect me to Glenn's coffee shop. The client system sends a request over the internet, goes to the Amazon AWS cloud. AWS cloud goes, hey, this is for Glenn's web server. It gives it to my virtual private cloud. The way it gives it is it has a internet gateway. Now, a gateway is a networking term that connects two or more networks together. So this is connecting my virtual private cloud network to the internet network. And that's all it's doing. It's just a networking piece that says, I can take network traffic from this network and send it to this network. Internet gateway will send that request onto the web servers in my public subnet. That's straightforward. But what about if I've got my internal private only applications, like my databases, like my email systems, document repositories, team folders? What do I do there? Well, I have a different type of connection. I can have my corporate data center that I'm migrating my applications to, and it wants to connect to the private subnet. Or I might have users sitting at a coffee shop or working from home. What we have here to get to the private subnets is a virtual private gateway. So gateway links two networks together. Here we're linking these kinds of networks to the private subnets. Now, you may have on your corporate devices VPN or virtual private network software that your IT teams have said, you have to start that up before you connect to the internal systems. Well, that would connect to the equivalent of a virtual private gateway. Or you've got remote sites like regional offices where lots of staff are, or data centers, and you want to connect them into the cloud. You could say, well, I'll put some VPN software here, and over the internet, we'll connect to the virtual private gateway. However, your customer might go, internet, that's very variable. It's shared response. I don't get guaranteed performance. You know, at the end of my street, there's a little primary school, and at around 3 o'clock in the afternoon, when all the kids come out of school, some of them go home and do homework, but I think most of them must go and play computer games or stream cartoons. You know, so the internet performance gets a little bit variable. If I wanted to solve that, what I could do is to say, look, I don't want to use the internet. I want to use a dedicated communications link called Direct Connect. And that's where one of our communications technology partners installs some hardware, so a router out on the customer's premises, a router in one of our availability zones that connects to the virtual private gateway, and they provision up a communications link. Depending on what's available in your country, it can be up to 100 gigabits per second. And customers can have multiples of those. This link is dedicated to them, and it means that they get pretty much guaranteed performance connecting between on-premises environments and the cloud. So in terms of what's what, if I wanted to take a database that's got credit card details or personally identifiable information, I'd put that database into the private subnet because I want to control who's got access to it and I don't want it accessible via the internet. Whereas if I want to create a virtual private network connection between the VPC, so between my cloud and the internal corporate network, I need a virtual private gateway. So whenever there's questions about connecting two or more networks together, whether it's the internet connecting to the public subnet or users connecting to from on-prem to the private thing, gateway is going to be a keyword. Web servers can go in a public subnet, and that means that the internet gateway can just send traffic to them. And it's direct connect that is the dedicated connection between on-prem and VPC. So that's how we do the connectivity. But you're probably thinking, but Glenn, I need more security than that. You know, I want to be able to block users, internet addresses, countries from accessing my data. And that's where network access control lists and security groups come in. So these are almost, think of these as firewalls. So if you've ever heard the term firewall, it's what traffic is allowed to come in and what traffic's allowed to go out. That's where these two fit in. So to expand on what we've learned so far, I've got my client system, it sends in a data packet. Now, one thing to know about a data packet is it has two network addresses. Who did it come from? Who is it going to? Every data packet has the same thing. Who sent it? Who's to get it? The packet comes in, it gets to the internet gateway, and it goes, this is heading to the web servers. Before it gets to the web servers, the packet gets inspected by a network access control list. And it's basically looking at who sent it and are they allowed to talk to our systems. You may have an application that has sensitive information. You might go, look, we know that there are the dark web, block the dark web access. So you could create entries into the network access control list that says, if you have this kind of internet network address and you're sending to me, you're dropped straight away. It goes no further. It stops here. The packet, if it's allowed through, then goes to the public subnet, and here it encounters a security group. The security group acts as a firewall for the individual EC2 instances, and we'll expand on this a little bit in a moment because there's often an exam question about it. We look at network access control lists. It's a virtual firewall for an entire subnet. So the public subnet, the database subnet, the sales subnet, that you can set up a network access control list if you need one. By default, there is none, so all network traffic can flow into the subnet and flow out of the subnet. And it's only when you put entries into that access control list that it goes, okay, you're not allowed in, you are allowed in. So that's where network access control lists come in. It's an old way to do network control. If you talk to old networking people, they'll say network access control lists, or sometimes they abbreviate it to NACLs, N-A-C-L-S. If you ever hear that term, they're talking about the firewalls for an entire sub-network. Network access control lists perform what's called stateless packet filtering. So imagine you're at the airport and you're going to fly overseas for your first holiday in years. And you turn up at the passport control and you're either going to leave the country or arrive in a brand new country, and you give them your passport. And the passport officer gives you the bad news. You can't fly. You're on the no-fly list. Or worse, your passport's out of date. And then you go, but if you look at my passport, I've always been allowed to fly. Passport control goes, don't care what you've done before. You're not allowed to fly. And that's called stateless packet filtering. You could have talked to my EC2 instance well before, as often as you liked, but if I've added you to the network access control list, you can no longer talk to my server. And similarly, my server, if I've added it onto the network access control list, it may not be able to talk to you. So you can argue, but I've talked to it before. Same way with passport control. Stateless packet filtering says, I do not care what's happened before. You are blocked right here, right now. And that's different to the next system that we're going to talk about. So network access control lists. By default, they allow all inbound and outbound traffic from your VPC. They use stateless packet filtering. So they do this, don't care what's happened before. And they're firewalls for an entire subnet. And that used to be great way back when I was first in IT. But we've moved on since then, and this is where security groups come in. So security groups are firewalls for individual EC2 instances. So they're protecting the web servers, for instance. And you could say things such as, you can only talk browser traffic to me. Don't try to send me email. The security group would block it. Don't try to log in as an administrator. I'll block it. So security groups are very fine-grained controls, very fine-grained firewalls for the EC2 instance itself. By default, it blocks all inbound traffic. Nothing can talk to my EC2 instance, but it can talk out. So think about, you've just provisioned up a brand new EC2 instance. The first thing you want to do is patch it. And that's where this packet filtering piece comes in. This uses stateful packet filtering. This remembers, hey, Glenn's server sent a request to Microsoft. Have you got any patches for me? Now remember, all inbound is blocked, outbound is allowed. What stateful packet filtering is much like going out of a security building. You tell the security guard, I'll be back soon. And you turn up at the security door and the security guard goes, oh, I recognize you. You told me that you were going out. You're allowed in. Security groups act the same way. If my server, which is allowed to send packets out, talks to your server is allowed to respond to me, even though inbound traffic by default is not allowed in. So as long as my server talks to your server first, you can talk back to me. However, if your server tried to talk to my server first, not going to happen. The security group blocks all inbound traffic. So stateful packet filtering is a little different. It's a lot more flexible. So how does it all work? Basically, when a packet comes in, it gets to the internet gateway, gets inspected by the network access control list. It then gets inspected by the security group, it gets to my web server, then it repeats. Security group inspects the outbound traffic, and by default, it can send. Then gets inspected by the network access control list, hits here and gets the reply. So there's often a question along these lines, and this is one of the tougher questions in the exam. And you don't have to get all of the exam right. So if you do forget this, I wouldn't get too fast unless you get a lot more wrong. But what's the differences between the two? Network access control lists work at the subnet level, and they do that stateless packet filtering. So think passport control. You could turn up with an old passport, it doesn't care. It goes, you may have been here a million times, but you can't come in now. Whereas this one, it's the firewalls for an instance. Now, how does this work? Some of you, if your brain is snapping a little bit, don't get too worried. But if you're a technical person, you're probably going, show me more, show me more, show me more. Let's go back to my EC2 instances, the little web servers. Now, often this demo works better for you than it does for me. I think it's Firefox. I have to think about switching. I've got my, hang on, I'll make it smaller again just so we can see things, what's going on. I've got my two EC2 instances, and we've got the load balancer. So load balancer, is it working? Yep, load balancer is working. I got a second copy there, that wouldn't help. Okay, now if I look at these EC2 instances, like this one, you'll see that it has a public internet address because it's in a public subnet. What I'm going to do is I'm just going to copy that address. I'll put it in the chat. If anyone wants to play along, go for it. There's its network address. If I type it in up here, paste and go, I can't connect to it, even though it's a public network address. Okay, so hopefully it should be timing out for you. Why can't it get there? If we look at the security for this EC2 instance, here's the security group that's protecting it. So security groups, firewalls for instances. This is its security group. So it's the web server one. What does it say? So all a security group is a set of firewall rules. See down here, here's the inbound rule. So network traffic coming from the internet, so me in my browser trying to connect to it, is it allowed? All the rule says here is any browser traffic, so anything HTTP, that's normal browser traffic, can come in provided it's coming from this security group. Now, this security group is the actual load balancer. Remember we had our diagram where we had the cashiers and the baristas, and we said we wanted to control who can talk to the databases. This is doing exactly the same thing. Only the load balancers can talk to the EC2 instance. Now you might be thinking, okay, I'll add a rule just to prove that point. Add all HTTP traffic. I will let it come from anywhere in the internet. Okay, so before I click that, this timed out. Yeah. And if anyone else tried it at home, you would have seen the same thing. Save this rule. So this says anywhere on the internet can now talk directly to this server when I go save rules. Now, it never really works for me. It usually works for everyone else in my class. Can I get a direct response? Oh, okay, it worked this time. You get a response from 8.200, which is, where is it? 8.200 was this little server. This means you're talking directly to it. And if anyone's doing, if we have any network people on the class, they're usually doing network diagnostics. You go, yeah, we're talking directly to the server. We bypassed the load balancer. So if anyone's done that, just let us know in the chat. You would have seen that. If you're not playing along, that's okay. This is just to prove how security groups work. Yeah, it works. Yeah, cool. Thanks for that. So you've bypassed the load balancer. You're now talking directly to the EC2 instance. I probably don't want that. Security says, look, I just want everyone to talk to the load balancers. Remember, the load balancer is my single point of contact, and it then talks to the security groups. So just to prove that there was no magic whatsoever, if I go back to, I'll show you how else I set it up. Here's my security groups. And this is where partners add a whole lot of value, If you know the tricks that we're doing now, and you're talking to a customer about planning a migration, this is one of the things that we often do before the first EC2 instance moves to the cloud, is set up the networking requirements. What are the firewall rules? What are the network restrictions? I go back to this security group. You'll see here, I see that CCF. That is the security group protecting the load balancers. So if I go back here, there's that CCF. So this says any traffic coming from the load balancers is allowed. We'll go back to inbound. I'm going to remove or delete this link. This is the link that says, and anyone from the internet can connect to me. Deleted, save it. And now this always works for me because it's cached by my browser. Let me just try it. But for you, it probably doesn't work anymore. Let's see if I can get this to work. Paste and go, because see my browser caches it. It takes a little while, but for many people who are doing all this, you would now no longer be able to get to that little server. This drives me nuts. Oh, I know what I do. I start up another browser, but yeah, it timed out. Yeah, thanks for that. Yeah, it times out. So that's all security groups are doing. Yeah, let me try that. If this works, you win a virtual t-shirt. I thought I did that. Yay, whoever put that little suggestion in there. Someone suggested use Control and R on Firefox. I have never, ever found how to do that. I make a note. You win a virtual t-shirt, a virtual cap, and a virtual sweatshirt. The only reason I say that is trainers have no prizes whatsoever to give away. Account teams do, like caps and t-shirts and those little Alexa Echo speakers. We have nothing except virtual things. Control and R. Well, I learned something today. Yeah, I'm a happy boy. Okay, so that's all security groups are doing. Why is that important? So think back to the auto scaling group. Remember when we went back to here and we terminated a server and its replacement turned up? That replacement automatically inherited the security groups, which is basically a major automation piece. Imagine provisioning a brand new server in a computer room and the server team spins it up because you're under pressure. Server's failed. Quick, spin up another server. Panic, panic, panic. Put it on the internet. Boom, done. Network team goes, hey, where are the firewall rules? This did it automatically. So I can tell this system, I always want to have 2 servers or 3 or 4 or 5. I always want them protected. Protect them with, these are the firewall rules. So this automation piece, this is where partners add huge amounts of value. When that server spun up in a few minutes as opposed to several weeks, The network team usually has to get involved. Well, here it happened automatically. So knowing how to set this up, you are now showing to your customer, you are thinking about the life cycle of applications. The replacement servers automatically have the firewall rules in place. So super cool, super cool. I find this as an old IT manager, the amount of problems that I just made go away by using this in the cloud compared to on-prem is a lot. Okay, so that was just to show the way security groups work and how you can chop and change. So moving things around, and you can work with your customer when planning a migration. What security groups and what firewall rules do you need? Then you can make sure that as a service starts, it's automatically protected. Really cool. I think it's really cool. Okay, next part. So that was that. How do you interact with the cloud? Now, a long time ago, I was working at Intel as a contractor in their server teams. Their client teams. And we used to provision up the client systems for employees. And there was a backlog. And one of the salespeople came over and said, "Why is it taking so long?" He said, "Well, we've got to install the software. We have to do all this, do all that. And then we have to get it ready for the network." He says, "Wow, yeah." He says, "Copying the internet onto this laptop could take a while." And we had to wait till he left before we burst out laughing. He thought that we were copying all of the domain names and all the network addresses onto his laptop. It doesn't work like that. The way the internet works, and I don't know if you've ever thought about it, but if you type in Amazon.com on your PC, how does it find the server that it needs to talk to? And the way it does it is the internet has a system called domain name service. So Amazon.com is a domain. Facebook.com, it's a domain name. But as we've seen today, internet and networking needs network addresses. So you could yell at your browser, "Hey, connect me to Amazon.com," but it can't do it until it knows the network address. It's like yelling at your phone, "Hey, Siri, call Glenn." And it goes, "Yeah, great. What's Glenn's phone number?" So you go, "I want to connect to Glenn's coffee shop." Your PC looks locally. Do I know what the address is? No. It'll connect to your internet service provider. And your internet service provider will have a domain name system server. And it's going to look up, "Oh, okay, Amazon.com, what's network address?" We call that resolving. You resolve a domain name into a network address. If it knows, it tells you. If it doesn't know, it asks the internet, "Hey, does anyone know what the network address of the Glenn's coffee shop is?" And somewhere, probably in my network, my domain name server puts up its hand. "Yeah, here's the network address that you want. This one." Sends it back to the client customer PC and they connect to that number. So much like completing a phone call. That's how the internet really works. That's how your devices find where the resources they want to connect to. We have a domain name service and it's called Route 53. And it does two things that sometimes get tested. It lets users ask, "I want to connect to internet or network applications." It doesn't have to be on the internet. It goes, "Great, connect via this address. Here's the address that you want." So basically, it's like directory services. You call directory services with your phone. "Hey, what's Glenn's phone number?" And it responds. Route 53 works with cloud-based resources and other systems, say other cloud vendors or on-prem. Basically, if you ask it for a name, it goes, "Here's the network address." And it doesn't have to be within the AWS cloud. So it's great for customers who are migrating from on-prem into the cloud, that your network administrators just go, "Okay, here's the SAP system. It's currently sitting on-prem." So when users say, "Connect me to a production SAP," it says, "Here's the network address of the SAP system." And it directs them automatically to on-prem. Then you move it over the weekend. Well, someone jumps in here and they change the record. So a DNS record is just, "If you ask me for this name, I will tell you this network address." So you jump in here, you say, "Oh, okay, we've moved SAP to the cloud. Here's its new network address." So the administrators jump in here, say, "If anyone asks for SAP, here's the new network address. User now connects to it. It's in the cloud." So end users don't have to change how anything works while you're doing migrations. Now let's add Route 53 and CloudFront together with the edge locations. because this starts to really unpack the power of the networking. User sits out here, connect me to Glenn's coffee shop. What's the network address? Okay, someone asked a really good question. Someone else can probably ask why Route 53. We'll just pause. That's a really interesting question. Can anyone tell me why it's Route 53? And if not, think about the service that we're talking about. This is probably for networking technical people. As soon as you say, oh yeah, it's that. And usually there's someone on the class that gets it, usually, but not always. So yeah, it's the port number for the DNS service, correct. So you get a wonderful virtual cap, any size and color that you want. I'll explain what a port is in a moment, just because it's come up. But yeah, correct, that's the right answer. 53 it's a networking thing. I'll explain in a minute. So I'm sitting here with my PC. I want to connect to glenscoffeeshop.com. Boom. It asks the network, and my coffee shop is running Route 53. Now, here's where it gets really subtle. Remember, a request has who did it come from, who is it going to? Route 53 says, who did it come from? It goes, this user is probably in Australia. It uses various techniques to work out from the source network address, where is this user located? It goes, yep, probably from Australia. Your nearest, so here's the number that you want. Here's the network address. But it doesn't send back the network address of the web server. It sends back the network address of the Australian CloudFront server. So very easy to do. So what happens? Customer connects to the Australian CloudFront server, and then CloudFront does its magic. Whatever it has locally serves back to the customer. Whatever it doesn't have, it knows how to connect to the website. And the website, here's its number here. The user does not see the actual website, it's talking to CloudFront. Now assume this user goes to the US. Route 53 does the same trick. This packet is coming from a US user. Here's your nearest CloudFront server. So this is how edge locations and the DNS systems work. That Route 53 can work out where is the user, here's your nearest edge location with CloudFront running on it. There are other strategies it has, a lot more tricks up its sleeve. But that's the key one. So that's what DNS is doing. User asks, where's the web server? It just says, here's all you need to know. Let's take it one further step. Client asks, Route 53, connect me to Glenn's web server. It responds, here's the address of your nearest CloudFront. Now, CloudFront doesn't talk directly to the server. It talks to the load balancer that has two scaling groups in two different availability zones. So that as things get super busy and these scale out, this hides all that detail. As one of these falls over or is down for upgrades, it directs traffic here. The CloudFront services all around the world sitting on top of the edge locations just go, I'll just talk to the load balancer. So this is how you can build very highly available systems out using all of these pieces. Very simple to do. Imagine trying to tell a customer, look, this is what we can build. Now, here's another little aspect that keep this one up your sleeve. Let's say you're the web manager and you're going to build a brand new service. So what you say to your developers, we'll create another load balancer down here. Now, there's nothing here. I'm just moving the mouse just so it's not here. We'll create a brand new load balancer. We'll have two new scaling groups. And developers, you build for that. So they're building crazily down here, building a brand new web server. And they go, we're ready for functional testing. Can we have a little bit of network traffic, please? You can tell Route 53, hey, Route 53, for every 20 requests that you get where you send the users to here, take one of them and send them down to this site down here. And so we take 20%, 1 in 20, so 5% of network traffic, and we ask Route 53, send reply with the address of this load balancer down here. These users have no idea what's going on. They don't need to. They just go, connect me to Glenn's coffee shop. But 1 in 20 will end up down with this brand new service. And the developers watch it like crazy. Hey, is this working? Now, are there any bugs? Is the user seeing what we want them to see? And if it's not, it's a Route 53. Stop doing that. Send everyone back to the old site. But if it does work, What they can say is, hey, we've passed functional tests. Now we're ready to stress test the system. Route 53 send 50% of the traffic to the new website. So half the users go to the old site, half the new users go to the new site. And then when they're happy that it's all working, they go, hey, Route 53, don't send anyone to the old site, send everyone to the new website. Now, this happens more often than you might think. We have some customers who do this function daily because they're making small, frequent changes to their apps. They want to test it, then they want to put it in production. Some of our customers make up to 8 changes per day. Small changes they want to test because they're operating globally. And this is how Route 53 and CloudFront lets you do that. So it's a great way to show customers, how do you develop, how do you build, how do you release software? So this speeds up the customer's software release schedules as well. So it's a very simple technique. It doesn't compromise anything. So if something fails, roll it back. You'd be surprised how often that happens as well in the field. Not everyone gets everything right. So that's how that works. So that's the key networking piece. Now, we said before, what was the significance of 53? Think of a switchboard where you phone Amazon.com and you phone up the phone number and you want to speak to me. Well, you don't know my desk phone number and you don't know anyone else's desk number in Amazon.com, so you ring the switchboard. The switchboard goes, yeah, I can put you through to Glenn. So we start talking. The way that works is you connect to the switchboard knows my extension, my phone extension internally. Now, you don't need to know it, but you might know it. I might tell you, next time, don't ring the switchboard, just ring me directly. That's what these ports are. So when someone said it was the port for DNS services, what it means is it's like calling the switchboard. Your client here connects to Route 53. Now, this server could be running everything. It could have DNS, it could have the web service as well. How, when you connect to this or that, how does it connect to the service on that server? And that's all a port is. You've got your network address, so 192.168.whatever, and then you can optionally say, and I want to connect to this port. So port 80, for instance, for browser traffic, or port 443. It's just like how a switchboard works, putting you through to an extension. It's how does the server know which service running on that server do you want to connect to? But that's outside the scope of this. Oh, we're running just right on time. So a quick knowledge check. What do I use to establish a direct connect? I gave the answer right, didn't I? A dedicated connection between a company's data center. If anyone gets this wrong after I just gave you the answer, I'll be disappointed. Yep. Direct connect. So it's the connection between not AWS and AWS. It's very, very common in our customer space, especially to get into the applications, say the SharePoint systems and corporate systems and SAP systems. Direct connect. Okay, one of the hardest questions you'll get today. So this is comparing security groups versus network access control lists. Ooh, lots of right answers. I'm happy about that. Yeah, the correct answer here is B. Security groups are stateful, so that if I talk to you, you're allowed to talk to me, but you can't talk to me first. That's what that's about. That's what stateful is. And deny all inbound traffic. So by default, when a new EC2 instance comes up, no one can talk to it. So it gives the admins a chance to get all the patches and things like that in place. Well done if you got that. What connects the virtual private cloud network to the internet network? Yep, gateways connect networks together. So we have the internet gateway, we have the private virtual gateway, we have transit gateways, lots, but gateways connect networks together. And as long as you remember that a VPC is a network, sometimes that pops up in the exam, that it just implies that you know a VPC, a virtual private cloud, is a virtual private cloud network. So well done. Which is the service that looks after domain names? Yep, Route 53. And we dived into lots of detail how to use that. What is the process of DNS resolution or resolving? Yeah, it's just basically looking up Amazon.com, what's the network address? So it's translating the domain name into the network address. Okay, so we have now the toughest question we're going to do today. Because we're running on Sydney time, it's probably time for lunch. Now I have two questions to ask. First off, if it's not lunchtime where you are, can you just put what time it is where you are, please? Because sometimes we can do two short lunch breaks as opposed to one longer lunch break. So first off, if it's not, say, either 1:45 or 12:15, what time is it where you are? What? 22? Holy dooly. There's no pressure on me. 2:45, so that must be New Zealand time. Oh, okay. Oh, gosh, lots of time zones. Okay. Given that we've got 7:12, but we've been going for, oh gosh. Okay, now some of you are getting the idea of how challenging it is to organise lunch. Okay. What we can do now is we can either take a 30-minute break or a 45-minute break. If you need 45 minutes, can you just send a message back to me? Because I know that some people have to look after not just themselves, but they may have to go out and get lunch, or more importantly, they may be working from home and have small people to feed. People have got small people or that 45. Okay, we'll take a 45-minute lunch break now. Yeah, that's not a problem. I mean, you've probably got the impression that we don't stand on formality in my classes. We'll do that, but because there's other people here where it's a little earlier, we might pad one of the afternoon breaks out a little bit more. So we'll take 45 minutes now. No, we won't take 10, that's for sure. That's not long enough. We'll take 45 minutes. So if everyone can be back in 45 minutes time, this is probably the broadest time zone ranges I've ever seen. Okay, we'll do that. When we come back, we'll do storage and databases, and then we'll see how we're tracking for time. We are on schedule, but we're not panicking yet. We'll see what we can do. Okay, so someone asked a question. So, this is at night time, so we can go through some of your questions. So if anyone else is going to ask super technical questions beyond the scope of the class, now is the time to ask. Otherwise, go and grab some lunch. Okay, can you set default rules for new security groups in a VPC? Sure can. Let me show you. Security groups. Here's all the security groups I've got, and usually people will change the default. So by default, it said nothing inbound, all outbound. I changed the default here, nothing inbound or outbound. What I'm assuming here is that if you haven't set a security group, then you've made a mistake. And so if you haven't set a security group, you pick up the default security group. And this says nothing talks to anything. Now, the next question that you probably have is, so how does the server administrator connect to the server to set it up? So if you were thinking that, then let's go back to here. Let's pick these guys. Let's pick one of these. And again, if this is only for the person that really asked that technical question, or anyone else that's just not lunchtime or meal time or whatever. But this is where geeky propellers will be spinning. So here's my servers. Here's the security group that we have. Where is it? Only browser traffic coming in from the load balancer can get to this. However, if I dive into this will make sense this afternoon more when we do security. If I go back to the servers and I go look at the servers, look at the security around it. Well, I'll pick one. That would help. Where is it? Where is it? Where is it? Where is it? Must be in security. I know what I want to show. Yeah, here it is. See this IAM role? We will do this when we do the security module after lunch. But this says who is allowed to talk to this server. So what are the permissions? So IAM is a security service. You see it's set up for SSM, Systems Manager. That's a service that we use well outside the scope of this class. So if anyone thinks this is well outside this, we cover it in DevOps, development operations, but not part of Cloud Practitioner. So this is really outside the realm, but technical people are often on this class. This role is assigned to this server, and this lets the Systems Manager service connect to this server. One of the upshots is I can go connect as a systems administrator. So I'm going to be authenticated. I can run Sessions Manager. And this is a way to avoid setting up, say, Bastion hosts or Bastion servers. So if you're used to setting up a server somewhere and using RDP or SSH to connect to it, I'm in, provided I'm authenticated. So there's my server there. So this is a great way to lock down access to the servers. Now, I could, if I wanted to use SSH, I could go back to here. And this is a very common setup in some of the labs that we do. So just so I don't confuse people, I could do this. I could say, where are my servers? Here's my production web servers. So I pick that security group. I could add a rule and I could say, yes, I want to allow SSH traffic. SSH. And I could do that if I wanted to. Now, that's not best practice because that opens up a server administrator port to the internet. What I could probably do is put a custom address, or I could put my IP address. So usually you put in an address there that says you have to be on, say, a virtual private network to access this server, so you can restrict it. But using Systems Manager, I don't even have to have this port open. So I can just go cancel that. But I can still get access to the server. So can I set default rules for new security groups? No, by default, the default one has no inbound, all outbound, but I can change the default groups. I can change whatever I want. So that was what I did there. Got it? Cool. Because yeah, a lot of this is all about security. In fact, and we'll see why when we come to the security services later, you can see why do I not want people to get to my web servers? Why do I want them just to go to the load balancer? There's another security service we talk about soon called Web Application Firewall that really starts protecting systems. So hopefully that answers that. If anyone else is not taking lunch now, feel free to ask for anything that goes beyond Cloud Practitioner, because I don't want, currently we had 60-something people on from all different roles, and I don't want to really bamboozle anyone, but I'm happy to take any kind of tech questions during the lunch break, because I'm assuming that if you're not interested in the tech questions, you're having a lunch. But if you are interested in tech questions, ask away. Do I have implications for implementing Kerberos? You can do, no, I don't, but your local solutions architects will. Because our training classes typically focus on the AWS services. So Kerberos is an authentication service. There are ways to do it. Let me check. Let us check. Let us browse. This is again off reservation. Would you ask what Kerberos? Hang on, no, wait a minute. I always have to remember how to spell it. You can spell it better than I can. Kerberos, yeah. There's so many resources. Let me see. No, nothing found there. Okay. AWS, Kerberos. There are so many reference points for stuff. Oh, okay, here's one here. That's for Elastic MapReduce, Kerberos, options, Kerberos, on-prem, database. When in doubt, search the blogs. So I just know where to find stuff. Now this is only about a year old, so this is with using Kerberos with databases. Applications. Let me just check which class do we give that one in. There are so many places to look. Hang on a tick. Just think classes. What classes do we do that in? Probably technical. Solutions library. And not all these references are available to customers either. Some of them are partner only. So this is why I sort of struggle how to find things. Just bear with me. Resource libraries, Architecture Center. Oh, there could well be anything in here. Security and compliance, data compliance. Security. Yeah, you can look in the Architecture Center. If I go into, where else was there? Solution Center. Yeah, I just tend to use a search engine and you find stuff. Yeah, it's usually in big data. Oh, if it's in big data then, the EMR ones, because EMR is Elastic MapReduce, so Hadoop. So if you're doing it there, some of the ones that we found before, that's Kerberos there, it's RDS. Yeah, that could work. But your partner team will have access to solutions architects. You may already have a solutions architect assigned. Otherwise, just ask for one, and they'll find someone who knows this. And as I say, there's the documentation there. So that's in the Elastic MapReduce manual. It's got any restrictions, like it doesn't support directory service directly, all that. Yeah, that should help. What else do we do in big data? Redshift. I wonder if we do Kerberos and Redshift. Oh, yeah. So Redshift is our data warehouse. So how to do federated, all this stuff. Yep. Okay, so it's been out for a little while, but there you go. You can use it with all this stuff. So, yeah, sometimes there's too many resources. So your favorite search engine of choice can often help there. But as I say, reach out to the partner team, because if you're looking to get into that space, sometimes we'll have labs available. I don't teach Kerberos or big data systems yet, so I haven't come across it. But we may have labs, which makes me think. Talking of that, let me just check our standard labs. It would be in security. I wonder if we have anything in here with Kerberos. Blah, 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 blah. CloudWatch, EC2. Nothing. I don't think we have anything in the standard lab set, but how do you get access to the labs? Okay, these, easy. Copy, paste. That's it. That will have the steps to go through all of these. Like if you wanted to build whatever this is, there's often CloudFormation templates and all that. Otherwise, if you're looking to run sessions with customers or groups of customers, the partner team can set up what we call games days and immersion days. So they may have labs that they can make available for, say, a day's session. I mean, the hot topic at the moment is this one. Where is it? Deep races. AWS deep racer. This thing. There's a lot of these being used all around the region to help customers and data scientists come up to speed with machine learning in AWS. And so these deep races are actual like a little car, but you have to program it using machine learning. Well, that's an example of some of the immersion days and games days that we have, where an AWS team can set all these up for you. So as a partner, you might decide to run a webinar or a session for your customers. Your partner team can get resources for you to do that, to support your events. I should go back to the timer clock too, in case anyone's tracking where we're up to in terms of lunch break. But yeah, so they're the kind of resources at your disposal. So talk to the partner contacts and they can get you whatever you need. Any other questions? Oh, no. Usually with these classes, I have a big breakfast because we take lunch. So thank you for that. But yeah, if you have any other questions, I am going to grab a drink because my throat's a bit dry. But I'll be back in a few minutes. If you have any other questions at all that are outside the class, the content that I know we're not going to cover today, feel free to ask. Because this afternoon, we've done most of the technical pieces. We're going to explore other areas later. You'll still see some demos, but yeah, any other technical questions, now is the best time to ask. Or just talk to your partner team. Let me get a drink though first. And that was lunch. Now, over the lunch break, there were some technical questions that came in that are well beyond Cloud Practitioner, we talked about. If anyone is technical and you want to start exploring some of the things that you've seen in the demos today, there is another class that we run called Well Architected Best Practices. It's a long day. It's 5.5 hours worth of labs, but you get to build a lot of the pieces that you've seen today. So if that's of interest, I believe that it's available at no cost, i.e. free to partners. It runs in all the different time zones. So if it's coming up to midnight, you could probably find a better time zone to work in, because it is jam-packed full of hands-on. So you get to play with a lot of the techniques plus others that would help you in the field if you are in a technical, especially a managed services role. But well outside the scope of this class. That's why I won't spend any more time on it. We'll talk about well architected right at the very end, because it is a process as well as a class and a set of tools, but we'll only touch on it today. But just be aware that if you're going, oh, how do I do this? How do I do that? That could be the class for you. Otherwise, let's talk about storage and databases. So again, we're going to build on what we've learnt, because you've seen a lot of the key concepts about cloud and how it's different to on-prem and how things become simpler. Now we're going to, what was the name of the class? Well Architected Best Practices. We ran the first one here in Asia Pacific region last week and got lots and lots and lots of feedback on how to improve it, because again, the big challenge we have in running classes in the Asia Pacific region is the time zones. I mean, New Zealand's going to sleep when India's pretty much coming online kind of thing. So trying to work out lunches and things like that, it's a bit of a challenge, but we got there. But lots and lots of labs. Anyway, storage and databases builds on the concepts. So not so much the technology, but why is the cloud beneficial to customers? We're going to cover all these. We're going to look at storage first off. So where does data live other than databases? 3 types of storage. Block storage. So very much the storage type that you have in your laptop. I'm going to assume everyone's using a laptop from now on, just otherwise it gets too convoluted to say. So the same storage that you have in your laptop, you have a fixed capacity disk in there, mechanical or solid state. It could have a terabyte, might have a half a terabyte, something like that. Used also for our EC2 server instances. We look at object storage. Now this is a lot like iCloud, if you've got Apple devices, or Dropbox, or Google Drive, or Microsoft OneDrive. Storing objects. We'll expand on all of these, and then we get file storage. So I've got a data that I want to share amongst multiple servers, multiple users. How do I achieve all of these? Because knowing the different types of services lets partners add a huge amount of value compared to on-prem, and I'll explain how and why that works. So let's go to block storage first. So with block storage, take the disk in your laptop. Let's say it's a terabyte, just to make it easy. In block store, the operating system takes that 1 terabyte and it divides it into a number of blocks, each of the same size, roughly around 2K. And it does that because if you're writing data, let's say you've got a database of all your contacts that you've ever met, and you go, oh, I was on Glenn's class today, so I put in Glenn, Glen, click, and it adds it to the database. Then you go, oh, hang on, no, wait. It's Glenn with 2 N's, so I have to change it. Now, if you had to rewrite the entire database every time you made a change, that would slow your device down. And remember, servers are usually getting lots of reads and write requests per second. So that's why they use block store. Rather than rewrite the entire database, they just go, okay, which block has got Glenn's name in it, change it to add the extra N, write just the block back. So block store is used by the EC2 instances. And there's 2 types of block store. Instant store and then elastic block store. Now, when I explain instant store, I want to say I did not go to the pub for lunch, because it's going to sound crazy when I first describe it. With instant store, I start up my EC2 instance, and if it's got an instant store attached to it, the instant store is available for the server to start reading and writing to. And so EC2 instance is running and my application is doing whatever things it does. And then I go, okay, finished with it, stop it. As soon as the instance stops, the data is deleted, which is why I said I didn't go to the pub. What would you do with that? What's the use case there? If the data is deleted, What possible application? Well, this is where you're going to run, say, a fleet of scientific servers. And let's say, for instance, I have a telescope, all this data streaming in from a telescope, an astrophysics type telescope. And they have lots of data, terabytes of data that has to be reprocessed. And I might go, well, we heard about spot instances before. I can get computing at a fraction of the cost as long as it can be interrupted. I might go, Glenn, can I have 1,000 servers? Because what I'm going to do is I'm going to spin up 1,000 EC2 instances. In the first instance, instance number 1, it's going to process this top left-hand corner of the photo. And what it's going to do is I've got all the satellite raw photos, telescope raw data sitting on a data store somewhere. EC2 instance, you connect to the data store, you download just the piece to process this top corner, and when you're finished, write the results back to another data store, like finished photo storage system. Second EC2 instance, you're doing the block in the photo, the one next to it. Third one, you're doing next to it and all that kind of thing. So you've orchestrated how all these servers are going to produce just one piece of the photo. The raw data is stored somewhere else, gets processed on the EC2 instances, and then they rewrite the results back to another place. So there's nothing stored in the EC2 instance that we need. And this is a great use case for instance store. Instance stores can be very, very fast. Basically, from a technical viewpoint, they are using the disks attached directly to the EC2 instance hardware, which is why if you terminate the EC2 instance, the data disappears, because if you restarted that instance, it doesn't always start back on the same piece of AWS hardware that it started on. So that's why the instance stores disappear. That's how they get their extremely high performance. So this is where we use instance stores for those kinds of applications where the EC2 instance has no need to protect or preserve its data. It's temporary. And you're probably thinking, that's useless for my customer's application, in which case we have EBS volumes, Elastic Block Store. And this does preserve the data. I start up my EC2 instance and it's got an EBS volume attached, and I can start it and stop it and the data is preserved. And this is where we would use, say, servers running home drives, databases, whatever we want. We keep the data for as long as you like, and you can say, I want to delete this, a year's time, whenever. The EBS volumes can be detached from your EC2 instance and attached to another one, as long as they're in the same availability zone. EBS volumes only exist at the availability zone level. You can also make snapshots. Snapshots are useful in, say, test environments. So let's say I'm going to have my application and I've got a brand new version of my program and I want to test it. So I get my test data ready. The very first thing I do is I say, take a snapshot, because my program is going to change that data. And I run my program and it makes a change and it's got bugs galore, because remember, that's what I'm good at. And I go, oh, bother. So I go and rewrite or fix my program and I come back and I can say, restore the data to as it was using the snapshot, as it was before I ran my program, so that I'm always testing with the same set of data. So we can use snapshots for that. We can use it for backups. We can do a lot of things with snapshots. So operationally, very much more capable than the instance stores. But if I need blinding performance and I don't need to keep the data on the disk, instance stores can be faster. There is another thing that you can do with instance stores that we don't cover in the standard deck, but I want to show you because I have seen a partner use this to extreme effectiveness to basically rescue a customer's project. I'll show you it to you in real life. I won't show you the actual customer. Here we have EC2. Here we have two instances. So you've seen these little guys, you probably know them on a first name basis, and some of you will probably send them Christmas cards. You know them so well. Let's pick one of them. Here is this server. Here is the storage that's attached to this server. And here is its EBS volume down here, this one. So if we open it up, you can see here's an EBS volume. It's this type of disk. Don't worry about that. It's this size, so it's 8 gigabytes of storage. So much like it's a fixed size. You specify how much do I want. That's what I've got. And it can go this fast. It can do 3,000 IOs per second. That's quick. That's really quick. You see here it lives in this availability zone. So EBS volumes only live within one availability zone. And that's going to be different when we talk about the elastic file system ones. They span a region, EBS, only one availability zone. What I'm about to show you is something that's rescued a major customer project in Australia. It was a government agency and they had SAP. They had two partners engaged. One developed and released and maintained the SAP software. The other partner managed the AWS services. So two partners, and new project coming up. They had the major update for SAP, and being a government department, they said it goes live on this date. Long story short, they had plenty of time to do the functional testing, fix out all that, and then the go live came around and they had not done the load testing. And you guessed it, 9 a.m. the system goes live, and by midday the help desk was swamped. This is terrible. It's really slow. Give us the old system, the usual things. It's just the way things happen where you can't move a fixed deadline. So the customer at lunchtime is getting all the partners into a room. What's wrong? What's wrong? And the development team is going, look, we're really, we didn't get time for the load tests. The platform team was monitoring what the systems were doing. Now, we'll talk about this later when we come to CloudWatch, but basically, every EC2 instance, we can see all the metrics. CPU, memory, and you can optionally tell it, show me all of the network connections, show me all of the storage connections, show me all of the, what's going on. And this partner had done that because they were a really good partner. And they said, yeah, the disks are too slow. You're really hammering the disk drives with these upgrades that you put in, extra indexes and all that kind of stuff. They said the disks are proving to be the bottleneck. Oh, what are we going to do? What are we going to do? Now, imagine if you're on-premises. How do you upgrade an SAP server? Well, that would just, could you do it while it was running? The partner just goes, well, we need faster disks. So they looked at the servers, the instances. They said, oh, here's the EBS volume here. Why don't we modify it? So they said, it's this capacity. Oh, okay, I can give it more capacity if I want. And just as importantly, I can change the performance. I can make it go twice as fast. So instead of 3,000 IOs per second, which is a lot, I'll give it 6,000, modify. And it's going to say, yeah, you're going to modify this. You may have to fiddle around with the operating system, but they've modified it in flight. The server is in use, but it's modifying it. So if you go to, which one is this? This one is, I forget which one it's attached to, but the website. Here's our website. And you can see the numbers are still ticking over. Those two little web servers are still in production. And yet, it'll modify, then it goes optimizing, then it goes in use. We just literally upgraded the capacity and the performance of that EBS volume in flight. We don't talk about this at Cloud Practitioner in the general classes, but I want to show it to you because often you may be in a situation, and we've talked about EBS volumes, and this is the power of these things. Now, this is something you absolutely could not do on-prem. Upgrade the performance of a disk on a server while it's running. Are you crazy? Yeah, we've just done it here. The customer also needed to upgrade the servers. They were running out of memory. Now, to upgrade the memory of a server, it just needs to shut it down, change the instance type. So remember we did instance types. We said general purpose, compute optimized. They just went from a one size to the next size up, basically like a shirt size. And then they go restart. And they had the server upgraded in terms of the hardware. So the extra memory, extra processors, the software operating system licenses were upgraded within a few minutes. They did that at that night. Users came in the next day and they go, oh, wow, this is really cool. We like this. What did you do? And everyone just had to step back and smile kind of thing. This is the kind of flexibility. Is that IOPs max or sustained perf? You're asking a question way past this, but it's typically max in this case. Just so you know, the EBS volumes are network attached. So they're doing it like that. So the network attached, it varies. The performance goes up as the servers get bigger and bigger and bigger. Yep. If we get to the next break, I'll see if I can dig up real quickly where to look. But basically, small instances, they can go so fast. Bigger instances, their IOs per second could go up and up and up. They get better sustained performance. So in this case, it's the max. But as we get bigger, I'll show you at the break. So this is all these tips and techniques that you're learning today that you can, if you're doing managed services, for instance, keep in mind if you do get stuck like that because the customer goes, hey, we had a deadline, and then they go, hey, it's your fault. Well, you can make these changes to the hardware very, very quickly. So that's why people like EBS volumes a lot, because of that flexibility in operations. We did the demo. We've already taken a lunch break. See, what's the differences between the two? Instances are great for temporary data in instance stores. So that's where, the physics type applications or self-driving vehicles, where you want to run simulations or tests or fluid dynamics, the data is stored somewhere else. You just pull it down, process it locally, and then write it somewhere else. EBS volumes, they are your typical server storage systems. So that's block store. So it's reading and writing little blocks at a time rather than the entire database. Object store is where you have an object. Say you've taken a photo with your smartphone. Well, the data of the photo is the data piece. Metadata is data that describes data. So this could be if you've taken a phone with an Apple phone, it would have, say, the coordinates. Where were you at the time? You could put in who you were with. You could describe the photo. And then you've got a key. How do I retrieve, what's the file name or something meaningful, so that when you store the entire photo or object to an object storage system like iCloud or Dropbox, you can go, hey, get me my photo back. The downside of object is if you wanted to make a change to an object, let's say you took a photo of me and you go, oh gosh, there's a speck of dust or worse on Glenn's photo, download it, use your favorite photo editing tool. When you finish, you go, okay, that looks good, save it. It has to write the entire object back to the object store. Unlike the block store, which just says, hey, you just changed this little piece, I'll just write that. So object store solves a different problem. I want to store objects such as documents, zip files, video, audio, backup files, because I process them as an entire object rather than just changing pieces at a time. So that's object store. So think, iCloud or whatever your favorite offsite cloud-based storage system is, that's object store. Our object store is called Simple Storage Service. You probably know it as S3. When you say, I want to have some S3 storage, what you do is you go to the S3 console and you go create a bucket. So rather than having a disk or a volume, you create an S3 bucket. And it starts off at 0 gigabits or 0 gigabytes, of storage, so it costs you nothing. And then as you upload objects to it, the bill starts. So we charge on the basis of how big the object is and how many times you read it and write it. It's fractions of a cent, but you'll see when we come to the variations within S3, those things matter. You can set permissions on the objects. So here's a thought. Let's say we're going to do the class photos. And I say, okay, everyone, don't send it to my website. Here is an S3 bucket. Can you all upload a photo to the S3 bucket? And you go, great, I've got my photo. Well, I would have to give you write access to the bucket. In fact, the technical term is put object. You have to be able to put your object into the bucket. So I give you all put access. Should I give you read access? And you're probably thinking, well, yeah, Glenn, I want to check my photo. Great. So I give everyone put object access to the bucket, and I give you all get object, which is effectively read. And you go, wow, I can see my photo. Oh, and I can see other people's photos. And if I can see them, I can maybe download them. So I do, and I start to channel my inner primary school, kindergarten class technology. I go, wow, I could put glasses and I could put mustache and I could put funny hats and I can do all this on other people's photos. And then because I've got put object access, I can upload them as well and overwrite what they put. So the class photo would be a disaster. So by setting permissions, you can see that the onus is on the application user to get things right. And just if you're worried about, well, how does this work? What you could do is you could say, okay, I have a bucket. Everyone can have put object access, so write access to my bucket. That's what you got. And so you put your objects in there, and then I've probably got a Lambda function that virus scans them, produces a thumbnail. Then it moves those objects into another bucket that the website uses. So you've got write or put object access, but you can't read them. But then when they get moved to the website bucket, you do have read access. So you can see the finished results of the class photos, but you can't update that bucket. So you can't start, I'm going to mess with Glenn's website. Not going to happen. So setting permissions is an important piece, and we have a tool that checks, have you assigned possibly incorrect permissions to an S3 bucket, that because you can store all kinds of objects like backups in there. Imagine if you backed up a database and you had its backup sitting in an S3 bucket that was publicly accessible. Suddenly your corporate data might disappear. We have different classes of S3. So by default, people use S3 standard. It's designed for very frequently accessed data, typically very frequently read data. When you get the email with here's the link to the class slides, from probably tomorrow at this rate, that is a link to an S3 bucket that has a zip file with the documentation from this class. So the PDF of all the standard slides plus extra documents in there to help you if you're going to do the exam. So that's an example of an object. Under the covers, S3 replicates data to a minimum of 3 availability zones, which makes it highly, highly durable. If you have 1 million photos, for instance, and you upload those 1 million photos to an S3 bucket, and then you went on the big boss's space rocket thing, and you went off into space, and with more of Einstein, if you came back in, say, 10,000 years' time, so you go, I wonder how my 1 million photos are going. By design, only one of those objects may need to be restored from backup. S3 is designed with 11 nines of durability, which makes it a highly reliable storage system. That's S3. As I say, we charge on the basis of how much data you're storing and how often you read it and write it. Now, some of our customers have millions of objects in S3, and not all of them are read and written to all the time. And so they said, hey, Glenn, I've got 1 million objects, but only some of them are really active. What can we do? Well, we have an infrequent access version of S3 standard. It's the same thing, but the pricing schedule changes. It's cheaper to store the data, but it's more expensive to access it. So let's say you had an application that was doing the end of month sales reports. You might drop those reports, those PDFs, into an S3 bucket. And everyone can then go, oh, here's this month's reports. You may then have previous months moved into S3 infrequent access, so cheaper to store, and occasionally someone might go, oh, what did we do the month before? Well, it's going to cost you a little bit extra just to retrieve that data. But either way, it's very, very useful to have these two working together to reduce storage costs a lot. These two often pop up in exam questions, standard and IA, infrequent access. That's all you have to remember with IA, infrequent access. This one I haven't seen in an exam, but it is available. Rather than duplicate the data to 3 availability zones, it only duplicates it to 1. So that if the availability zone was unavailable for some reason, you couldn't get access to that data. You could with the others, but not with one zone. You'd have to wait till services were resumed, normal service resumed, before you can get access to it. The use case is a bit odd. It's where you're storing data that if you lost it, you could easily retrieve it from, say, here and here. Now, the common use case is, let's say you're running a video service, and you've got the standard movie, or you've got the original movie that came out from the movie studios, you store it here, and then you take that movie and you reformat it for all the different devices like smartphones, tablets, PCs, and then home theatre systems. So all different types of how big the picture is, different sound qualities and all that, maybe subtitles, whatever. You would take your application that can do what's called transcoding to produce all those different formats, and you could store those different formats down here. So that if you couldn't get this, you could always go back to the originals here and run your transcoding application again. But as I say, I've never come across a customer using one zone IA, but you may. Or if you think you have, talk to the partner team just to run past them. How would I use this? These are the two common ones, but what if you do have millions or billions of objects like some of our customers do? How do you know which do you want, standard or infrequent access? And that's where intelligent tiering comes in. So it's a small monthly monitoring cost, but it just looks to see how often is each object being accessed. And if it's not, it will move objects in standard to infrequent access. So it automatically tries to save customers money. And if an infrequent access object starts to becoming frequently accessed, it moves it back to standard. So where customers have lots of objects that they want to automatically have moved to the appropriate storage, intelligent tiering can do that. It's not a class by itself, it's a monitoring service. Now, so far, all of the objects we've talked about, as soon as you say, I want to get that object, as long as you can get it straight away. The first of the word pairs that we're going to do this afternoon is Glacier. Whenever you see Glacier, Glacier and archiving go together. So Glacier is like that shoebox that you have at the back of a cupboard where you put all your receipts in. You hope you never have to go there, and you have to keep your receipts for, tax purposes or whatever. You have to keep it for a few years. This is what Glacier is. Glacier is the equivalent of that, where you can store data long term, much more cost effective than, say, S3, but it's not instantly available. It can take a few minutes, up to hours, to retrieve data stored in Glacier. So it's used for compliance. People keep their backups and they're told, you've got to keep the current month for so many days, then previous months, then every year you've got to take those backups. That's where Glacier fits in. Anything to do with compliance or archiving, the questions are usually revolving around Glacier, but you cannot retrieve them instantaneously. There's a pause. Which brings us to this quick knowledge check question. Well done. So infrequent access, but must be immediately available. Immediately available rules out B and D. Glacier is not immediately available. So it's either A or it's C. A is the monitoring service. It's not the storage class. So the storage class you would use here would be C, this one. So that's object store. So we've done block store, we've done object store, so S3. Does intelligent tiering cost more? Okay. Good time. This is the first of how much do things cost question. I'll show you where to find the cost of anything. Cost of anything, if I open a new page, if I go to aws.amazon.com, I never bothered to remember these. The costs change all the time. And how do we do the cost? I don't know. All I do is if I go to products, in my wonderful internet. Yep, here I get in storage, storage, I can go to S3. Nearly every service will have a pricing tab. Actually, remember, yeah, exactly. Yep, they sit in here. So here's where you do the pricing pieces. So in terms of, what did we say? Management and analytics is the cost for insights. So I can do insights, I can do storage lens, batch ops. Where is infrequent access? So you see the different infrequent access costs here. So this would compare it for you. What it's costing. Sometimes there's a little asterisk. You have to dig down into it. Yeah, that'll tell you there what it's going to cost. And that's for anything. Yeah, because I don't want to try to remember the costs either. This is where, how do you find them? Cool. Okay, we did block, we've done object, file store. Now, file store is a different beast. This is where I've got a team of, say, scientists talking to lab equipment, collecting data. I want to have a common area that they can all share. An EBS volume is attached to an EC2 instance, so it's not shared. The EC2 instance itself can do sharing, but the storage itself is assigned or attached to one object, and it's only within that availability zone. I might have teams across, an entire region trying to transact data. Or I've got SAP, reading and writing, all different applications are hammering away. How do I solve that problem? This is where Elastic File System comes in. So it starts off much like an S3 bucket. You say, I want to create an EFS volume. Now, for the technical people, this is like network attached storage or NAS or NFS. It's only available for Linux, not Windows. Windows doesn't support that kind of operation. It does things differently. And yes, we have file services for that, but it's outside the scope of Cloud Practitioner. So EFS, very scalable. it costs more as I upload more data, but as I delete data, the costs come down. So again, cost per gigabyte. But it lets thousands of instances connect to it. And it also spans a region. So the data is available across multiple availability zones, unlike EBS, which is limited to one availability zone. So it's very high performance, very connectable, very performant, which means it's expensive. How expensive? This slide was produced by me working with a partner. We, as a TAM, every month, technical account managers typically produce a monthly business review report for a customer, which says, here's what your AWS bill looks like, and here's potential areas to optimize. And with this specific customer, I thought, wow, they're spending a fortune on EFS. What's that about? And so I talked to the partner who was running their platforms, and they said, yeah, that is a lot. And this customer had 200 terabytes of SAP of data on an EFS volume. And so we asked the customer, what are you storing on the EFS volumes? Because it's costing double this. What was it? $72,000 US per month. And this was a few years ago. The costs have probably changed, but we said, okay, what's this about? And they said, well, Glenn, this is where SAP sits. We go, yep, that's where HANA is. The high-performance database is perfect fit across multiple availability zones, high availability, good fit. But 200 terabytes? And they said, well, Glenn, the database is 100 terabytes. And we said, yep. And the backups are another 100. And we went, whoa, what? So as soon as they said backups, this is where you start to think, is the customer using the right service for the application? And backups, EFS is high performance, things reading and writing all the time. And backups is, look, I probably run it once, I may or may not even read it, but I've got to have it around for a while. So we looked at the backups and we said, how many have you got? We did some analysis and we said, look, there's about 100 terabytes of backup data that we could move somewhere else. And we produced this chart. Basically, we went into the pricing calculator, pulled the data out, put it into Excel to produce this chart. We said, EFS, HANA, perfect fit here. But if we took the backups and just moved them down to these high-performance EBS volumes, that's a fraction of the cost. It's what? Down to $14,000 rather than $32,000. But that's overkill. That's not for backups. That's for, SQL Server and Oracle. Even if we moved it down to the general purpose EBS volumes, you save again probably another $1,000 or so, but that's overkill. S3, perfect fit for backups. And you can see here, for 100 terabytes, it was going to cost, $3,000, let's say. Big difference to $32,000. Then we said if you took previous months, so things that you're not really using, but you need to keep for compliance and archiving, move them down to Glacier. And you can see here the costs are really crushing down. And then we have Deep Glacier. This is, for previous years' worth of backups. So this is how the different use cases for storage fit. Then you're probably thinking, well, Glenn, this is obvious. How did the customer get into this mess? In an on-premises world, typically a customer buys a brand new storage array, say an EMC PowerMax or heaven forbid a Clarion, the old school, or a NetApp filer. They plug it into the network and they start using it. And people just store stuff. I mean, one of my customers was doing an SAP project and their costs were going up. And I looked and I go, you've got 100,000 snapshots. Why do you need that? They go, well, we're so busy. We just have to get the project out. We haven't got time to tidy up. But this is what people do. It's much like having teenagers where they just throw all this stuff on the floor. And it's only when mum or dad come in and go, can you tidy this mess up? Same thing happens in on-prem. People just keep storing data until the storage administrators go, hey, this brand new array is almost full. Everyone has to tidy up their mess. Now, that's great because, an array on-prem only has certain capacity and people go, hey, it's almost full. When it comes to the cloud, we have a lot more storage. And that's what happened here. This customer just kept piling stuff in and in and in. And our services are quite happy to do all that. It was only when finance, or I showed finance, hey, you're spending a lot of money here. They go, oh gosh. Now, all that happened then was the partner went, we can move these backups down to here, then down to here automatically. Would you like us to do it? And you can imagine what the customer said. This happens a lot. This is old on-prem practices running in the cloud and going, hey, it's not saving us any money. So partners add a lot of value here just by monitoring these costs and saying, hey, you're storing the wrong things on the wrong storage type. Here's different classes. So again, this is storage. If compute is number one on a customer's AWS invoice, storage is usually number 2 or number 3. And the other 2 or 3 is databases that we're going to come to now. So that's storage, where you can add a lot of value just by reviewing how is the customer using the storage services. Is the data on the right storage type? When we talk about databases, there are 2 types. Relational. So I have some data in rows. So here's my products from my coffee shop. And I have all these different columns. So I've got product names, size and price. And I put all my products in here. And I may want to find reports or relationships amongst the data that I'm storing. Show me all of my high expensive products. So show me all the products whose price is more than $5. And it would pop out these. So every row has every column, much like, say, an Excel spreadsheet where you have a table set up. On the other hand, you may have a non-relational database and you don't have rows and columns. What you do is you have a key, and the key has value pairs. So you might know for this customer, so this is our frequent purchaser or frequent customer system in the coffee shop. You might know that if John comes in, here's his address, so we can send him a mailer, and we know what his favourite drink is. So when he comes through the door, hey, John, do you want the usual? Yep, no problem. Medium latte. But you couldn't do the same for Mary because we don't know what her favourite drink is, but we do know when her birthday is. So if it was July 5th, oh, Mary, happy birthday, congratulations, would you like a free pastry or something? But you couldn't do that with John. What we're doing here is we want to store data that we want to retrieve extremely quickly, but we do not expect to find out, say, show me all of my customers who were born on July 5th, because it would find Mary, but who knows when John was born? It couldn't answer, so we'd miss things. So we don't find relations here, so that's why we call it non-relational. Here we do find relationships amongst the data. If I look at relational databases, we'll use a technique called structured query language, or SQL, to retrieve that data. So select all products, so select all from the product table where price greater than $5. That is structured query language that would have run a report. Databases such as Oracle, Microsoft SQL Server, they're relational. Now, if we've got millions of customers worldwide, you can probably bet that our customers have millions of Oracle and millions of SQL Server databases somewhere. And so our teams just went, well, why don't we do a lot of that really basic management pieces for a database? So such as setting up the appropriate operating system and patching it, setting up SQL Server or setting up Oracle and patching it, and running the backups for the customer when the customer says, I want a backup. And so what we did was we said, we'll release a managed database service called Relational Database Service, and it lets customers run applications using SQL Server or Oracle without them worrying about the hardware underneath, the system software, or the licenses. So we take care of a lot of that, undifferentiated heavy lifting that you have to do just because you're running a database. It's a very common technique when you're talking to customers who are moving from on-prem to the cloud. If you looked at the 100 servers and you go, 10 of those servers are running database. AWS has a managed service. Do you want us to use that? And you can almost hear the database administrators start to sing and dance. Yes, because we don't have to patch stuff every month. And yes, we don't have to worry about the backups. And they can focus on doing what database administrators like to do, such as, optimizing reports and queries and all that databasey stuff, where patching systems is just such a boring thing, and making sure backups happen, that's boring. So we'll take care of that. And that's where relational database service comes in. Starting at the bottom, if your customer says, I've got Microsoft SQL Server, Oracle, no problem. We have database engines in relational database service to handle that. We have these very common, very popular open source databases. Plus, we have our own database engine called Aurora. Aurora is an enterprise class relational database. It can often be used in place of Microsoft SQL Server and Oracle. I say often, not always. If a customer is using, say, the enterprise editions of those databases, we have a tool that will assess how many of those features is the customer using, and can they be mapped into Aurora? For many customers, yes, they can, straightforward. But some customers, not always. So we do have a tool we'll talk about in a minute that will help you assess, can a customer take their existing systems and move them to Aurora, because it's very much more cost effective and it's a cloud native database. It knows how to replicate data across availability zones. Remember, we looked at those two little coffee shop web servers and we said how cool it is to have them in two different availability zones in case one fails. We can do the same thing with our databases in RDS. It's just to check the box. Do you want it in more than one availability zone? Tick, and the RDS system will run them that way. Non-relational is totally different. Non-relational, think about an online game like Fortnite. Now, they're an AWS customer. You log into your online game, so you type in, say, your username and password. And then if you're brand new to the game, you'll have no treasures, no weapons, no costumes, no prizes, no anything. And so your entry here would be Glenn's key, his username here, and here's all my lack of stuff. Imagine trying to do all this as you learnt, as you played the game and you won more prizes and weapons and costumes and things. This would get longer and longer and longer. If you did this in a relational database, you would have a row, and every row, every player has to have every possible column. And for many customers, those columns start off blank. You've won nothing, you've got nothing, and they'd have to fill them up over time. Non-relational solves that problem. It goes, hey, if you log in, I'll get you your data, your inventory, your prizes, whatever, so fast. Because I don't expect to find relationships between player 1, player 2, player 3, player 4. You could all be at different stages in the game. Who cares? So what we do with non-relational is we have a key, and then we have these value pairs. So I know this player's name, I know his address, I know his favorite drink, I know this player's birthday, this West, things like that. So we have key value pairs. That's often a common term that goes together with non-relational. So whenever you hear non-relational, you'll see key value pairs. When it comes to relational, you'll see structured query language is a very common word pair. We have a non-relational database called Dynamo. Now, the easiest way, we haven't worked out a better way to do it. Dynamo, mo sounds like no. No is almost non-relational. So Dynamo, no relation, non-relation. Dynamo is a serverless key value database. With RDS, you have to say, I want these instance sizes provisioned with the database software. And if you outgrow them, you can just say stop them and upgrade them. Here, Dynamo grows automatically. It will scale itself to adjust for capacity changes. It's designed to handle over 10 trillion requests per day, which is a lot, but some of our gaming customers, they push this to its limit. If you've got, say, Fortnite, millions of users online at any one time, and they're winning prizes or losing treasures or selling them, Dynamo is a great fit for that type of interaction. Usually your solutions architects would tell you, hey, Glenn, we need a non-relational or a relational database. Just remember the names there. So Aurora is relational. Dynamo is non-relational. Database migration service does what it says, helps you to migrate databases from a customer's on-premises and other clouds while the databases are running. So don't think, we need to schedule some downtime, we've got to copy tapes or files or whatever. No. Database migration service helps databases be moved to the cloud, and you can convert them. You can go from, say, Microsoft SQL Server on-prem or in Azure, for instance. You can say migrate it to a relational database service running SQL Server in the cloud. So moving from customer maintaining their operating system database software and in database to fully managed database in the cloud. And this is the tool that helps. And part of it also helps to assess, could I move it to Aurora to save customers further money? So some of the questions that sometimes pop up in the exam, if you remember that RDS is relational database service and Dynamo is no relational, then storing data in a relational database, that has to be RDS. Whereas running a serverless database, that's Dynamo. Although for the technical people, there is a serverless version of Aurora in beta, in preview. So just for completeness, for the exam, if there's ever a question about serverless, it's Dynamo. But I don't want anyone to leave the class and say, hey, that crazy old trainer didn't tell us that Aurora could go serverless. It's on its way, but not yet. Key value pair. Well, that's a non-relational database, so that has to be Dynamo. Whereas structured query language, SQL, easiest way is to think Microsoft SQL Server. That's where SQL comes from. That's relational. 10 trillion requests per day, Dynamo, and Aurora is relational. One other database that you need to be aware of is this one, Redshift. It's a data warehouse. This is commonly my first cloud project for customers who are migrating to the cloud. Many small, medium customers really would love to have a data warehouse. And all that means is they've got their production system, so that could be running on Oracle. They've got their sales system, could be running on a SQL Server. And they're thinking, wow, are there any insights in here? Are we making the right products for the right sales? Are we making them in time? Well, a data warehouse can help solve that problem. And so often when we're migrating customers to the cloud, if they need a data warehouse, that can be an important factor in working out what systems do we move first. So Redshift, very, very useful data warehouse, very common for most of our customers who are into that data analytics and machine learning data science roles. The other databases here, don't worry about them. Be aware that if you're in the field, we have lots of other databases and they do all these things, but I haven't seen exam questions on these at all. So I wouldn't even bother to remember the names just yet. I would remember absolutely this one because there's often a question about data warehouse, but typically not about these ones, but they are there. So a quick knowledge check before we take a break. No clues. Correct. Whenever you see archive and it said select two, so I'm pleased that almost, sorry, as soon as I was going to say, everyone's put two answers, really cool, and then someone put one, but I know what you mean. As soon as you put two in there and you see archived, you know it's going to be Glacier. Okay, the only other tough question that you can sometimes hit is this one, the difference between EBS and EFS volumes. Yep, EBS volumes only exist in a single availability zone. So they touch to the to the EC2 instances in the availability zone that they're created in. EFS can span all of the availability zones within a region. So they're the two use cases there. EFS volumes can also be accessed by on-prem systems. So if you have, say, a laboratory producing medical data, you can have that data shipped straight up to an EFS volume, and then data scientists can run machine learning pieces and all those kind of projects directly on the same data. So EFS is very, very powerful in that respect, but as you saw, it does cost a lot more than an EBS volume. Okay, you want to use a object store. Which one is the object store, please? Okay, now here's another strategy. If we didn't talk about it today and we didn't talk about this, you could rule it out in the exam. You'd have to be really unlucky for them to ask you what this is a database, but who cares? We didn't talk about it today, this one's out. Then we said we have three types of storage, file, block, and object. Well, it's asking for object, so it can't be file, can't be block. By default, if you didn't remember that S3 was the object store, you'd be left with this one anyway. So the correct answer there is that. What is DynamoDB, please? Oh, all the answers today, they're all coming from different people really early on. This is really cool. I like this. Yeah, it's a serverless key value database. So Dynamo, no relation. A non-relational is always key value pair. So it's that one. Okay, which is the data warehouse, please? Yep. All the others are databases, but it's Redshift is the one that you need to know about for the exam. So that was storage and databases. So again, you're seeing that can we make customers' life easier? And this time we talked to the storage and the database administrators, and we saw exactly how we can help them to be far more efficient in the cloud. Let's take a short break. What time is it? 2 o'clock, 12 o'clock? So I think for most people that didn't have lunch or didn't take lunch before, it should be around 11 o'clock unless it's a really outrageous time. We'll take a short break. Then we're going to come back and look at security because this can be a bit of a sales objection for a customer. And I want to make sure you've got all of the knowledge at your fingertips. So we'll take a 5-minute break, my voice arrest, then we come back, we'll do security. Done. Okay, security. This, as I say, this is an important module, but we're not diving into the depths of security, but customers can have concerns about it. You know, I have my nice, safe, secure little computer room, and you want me to move to the public cloud. And so we're going to look to see how we can help a customer be even more secure in the cloud than they can be on-prem. So we're going to talk about all these different functions, but first off, we'll start with a shared responsibility model. And all that says is, when your customer is working in the cloud, what are they responsible for? And what's AWS responsible for? So you've got all the infrastructures like the regions, availability zones, and edge locations that we talked about. And we said AWS looks after that. The customer can't configure anything to do with that. They use the services like CloudFront that sits on top of it. We're responsible for the security of the services themselves. So all of the software involved with, say, EC2, S3, EBS, RDS, we're going to look after all that. And then when the customer starts to add their data and their applications into the cloud, it's their responsibility to look after those components, such as which operating systems do they choose? Who can get access to it? What are the user IDs? What's the firewall configuration? So typically anything that talks about configuration of a service is a customer responsibility. And we saw that before when we had the EC2 instances, and I changed that security group. And I said, hey, look, now you can get direct access to the EC2 instances, and some people did. And then we said, now we change it back and you couldn't. So it's up to me to set as a user to say who can do what with my data and my applications. So we'll often talk about the customer is responsible for security in the cloud. So which operating systems do they run and when do they patch them? Setting up firewall rules such as the network access control lists or the security groups and applications, creating user accounts. That's a user responsibility. Now, because this is a partner class between you and me, okay? If you are working with a customer and they make a mistake in this space, let's say that they have a database backup and they put it into an S3 bucket that is publicly accessible, or they have a security group that's set up wrong. If a customer ever thinks, uh-oh, I've had a security breach, and you think it falls into this area, get the customer to log a support case with AWS support as the highest priority that they can, and our teams can help. Even though it says it's a customer responsibility, we have processes in place to help customers. And I've been involved, unfortunately, from the customer's viewpoint, when this has happened. And I only say unfortunately because we managed to save a few potentially nasty security situations because time is of the essence. If your customer thinks they've had a problem, they probably have, log the case straight away and we can kick off our processes. And we do not mind if it's a false alarm. I mean, I'd rather be safe than sorry. I don't want to read about a customer had a security breach and their database ended up in the public. I have had a customer that went close to doing that, and we caught it really fast, and I'll show you the tool that we use to catch it really fast in a moment. But yeah, if you have a customer that, even though it says it's their responsibility to set up encryption and configuration and security, if they get it wrong, we absolutely will help. But that's customers set up all these aspects of the systems. So it's the security of their data, their applications in the AWS cloud. AWS is responsible for the security of the cloud itself. So for instance, physical security of the data centers, never ask, can I have a tour of a data center? Because we can't do it. I can't get into a data center. I certainly can't bring visitors, friends, and family along. You've got to have a very, very good reason to get into our data centers, and it's typically you're part of the service team that does that. So we look after that. We look after the physical hardware, so the network infrastructure, the server hardware, the disks, everything. We look after all that, so it's our responsibility. Why do we talk about these two? Because when we look at compliance, we'll often see that a customer who says, Glenn, talk to me about HIPAA, talk to me about SOC, talk to me about PCI, they'll ask questions that typically fit into this category. Is it AWS's responsibility or is it the customer's responsibility? And that is something that we work on with those workbooks, and you'll see where to find the workbook soon. But yeah, it's typically, is it a customer responsibility or an AWS responsibility? Let me see. does the support cost as well? We'll look at that in pricing module. What does support cost? Can I provide the location of the AWS data centers in Sydney? I don't know. I know that people have a supposedly published list. If you search with your favorite search engine, you might be able to find lists as of a while ago, but I wouldn't know where they are. I know they're about 20. I know their rough geographic location. And that's all I know. I know that technically there's some near the airport at Sydney, some are way out west, out near Eastern Creek, but that's it. I couldn't drive there. If you held a gun to my head, I could not drive you to an AWS data center because I don't know where they are. Do these responsibilities fall to the customer when they use Outposts? Again, they're the kind of questions that pop up. So the customer is responsible for, say, the aircon and the environment because it's our hardware sitting in it. So in terms of the physical access, I would assume that's a good question. You win a virtual pair of socks. They're limited edition. We haven't given many of those away this year at all. But yeah, that would be the customer's responsibility for the security of the Outpost environment. Yep, good question. But that's why I mean these kind of questions go to the heart of, like, what happens if a disk drive in a server that's an Outpost system fails? What's the process that we go through? It varies from country to country, I think. I can imagine how we do it, but some countries, especially some locations, getting parts out there, whether we have a spare parts bank out on site, which we used to do when I was an on-prem kind of guy. Yeah, that's why I say if you're interested in Outposts, chat to the partner team to see what services and functionality is available in your region, your area. Does Outpost have redundancy? It has redundancy. There is a configuration that you can have the absolute minimum, but you would never, ever use it for production. Never. So I would imagine most of the production systems that go out there do have the redundant components in there. Yeah, but again, if you're thinking along these lines, the partner team can show you the actual designs, they can step you through it, but it's well outside the scope of Cloud Practitioner. So in terms of who does what, so configuring the security groups, we saw that before. It's a customer. That was me acting as a customer setting up my website. Whereas maintaining the network infrastructure, so the switches and all that, AWS. Now, just on that point, one of the most stressful things I could do to you in a computer room is to give you a patch cable. Say, hey, can you connect that server over to the switch, please? So when you bounce with this cable and you go to the back of the service and you go, wow, there's a few spare ports in here. And then you plug the cable in, then you look at the switch and you go, wow. So you hopefully plug it in. Suddenly you've connected a production database into the internet. And that happens a lot. Typically when you read about those big data breaches, someone has accidentally done that. And I've worked in teams where that has happened. You know, they give the cable to the junior person of the team. They make a mistake because it's kind of overwhelming if you stand in a data center. And that does happen. You can't do that in the cloud. You saw me create those security groups before, and in fact, you saw them automatically assigned. So that's yet another example of how the cloud makes things operationally more reliable, more secure than a traditional data center. Implementing the physical security controls, that's AWS. Whereas patching the EC2 instances, that's a customer responsibility. Yes, we have tools to help do the patching, but it's up to the customer to work out which patches do they want applied, when do they apply them, because different customers patch their applications to different patch cycles. We have some customers that run medical equipment, for instance, and we don't push patches out every time we have an update to our software because it may have a negative impact on their applications. So that's why it's a customer responsibility, but they can use our tools. Maintaining the servers, that's us. That's a big issue. We're setting the permissions on S3 objects. So we talked about that class photo example. That's a customer. How do we control who gets what? How do we identify who a user is, and how do we set what they can do? And that's where identity and access management come in. Basically, I am Glenn. What am I allowed to do in the cloud? So back to the coffee shop. A new cashier starts at the shop, and he or she, we give them access to the cash register or the FPOS terminal, but not necessarily to the back office systems that do payroll and inventory. So person starts and we give them just the permissions that are appropriate to their role in the organization. IAM controls access to AWS services and resources. Now, there's sometimes a trick question that pops up in the exam. Well, not a trick. It'll just be an answer that looks right but it's wrong. IAM manages access to AWS services and resources. Sometimes the question will have a similar answer that says gives access to AWS and on-premises services and resources. IAM does not work with on-premises directly. It can talk to on-premises authentication systems like Active Directory, LDAP, Okta, all those. But IAM by itself will only manage cloud-based services and resources. And it uses these features that we'll talk about. But yeah, just be aware that that question sometimes can mislead you. If it says on-prem, IAM, only cloud-based services. When you first create your AWS account, the very first user ID is called the account root user. You go to the AWS portal, you can say, here's my email address, here's my account password, there's your account created. Plus, I think you've got to put in your credit card details. It creates your account. And that is an all-powerful set of credentials because that lets you do everything, create EC2 instances, other users, start and stop, and delete the account. So the best practices we say are to log in as the account root user when you first set up the account, create an IAM user because an IAM user cannot delete the account, give that IAM user permissions to create other users, then take the account root user username and password pair and lock them in the fireproof safe, never to be seen again unless it's an emergency. And that way, if you're working on the system and you go to the internet and you go to a site that has malware or something and it captures that username password pair, at least you can't have your account deleted. Now, again, between you and me, in case you ever have a customer who does get their account deleted, you have 90 days to contact support and say, please do not delete the account. So we don't delete accounts straight away when the deletes are requested. So that's something just to be bear in mind because I did have a customer once, a very complex government agency that had hundreds of accounts. And one of their users set up a test environment just using his own credentials. And it went into production somehow because he was part of like a lead developer. He was experimenting. He goes, hey, this works really well, put it in production. And then he left the organization, so he deleted the account. And so there was a major panic. Hey, something's wrong with this app. And it took the customer a long while to work out, hey, the account's been deleted because it was part of a linking one system to another system. And it took them a long time to work out what broke. They finally worked out that someone had deleted this tiny little account on day 85. So that was a major panic to talk with support to go, okay, don't stop the deletion on this because it linked two major applications together. So if it does happen, again, jump onto support as fast as possible. But usually you'll use these IAM accounts profiles in production, and this one gets locked away. So what is an IAM user? An IAM user is just an identity, username, password pair, much like you would have to get into your own corporate networks. And the best practice is everyone has their own, none of this shared generic thing. And we'll see why a little later. But the whole idea is have meaningful names for the IAM users. Because if you create a support case as a partner and you say this is an urgent case, I have been in a situation where a partner has done that using a IAM profile account of DBA001. What's the mobile? Who do I call? Because it was an urgent case and support, we're all scrambling to work out, well, who is this? And it took a little while. If you could put something that identifies you, if you are working on a customer account and they say you've got to use these generic ones, if you create a support case, can you please put your actual name and your contact details in the support case, please? Because there's nothing more frustrating for everyone going, hey, AWS hasn't called yet, and AWS is scrambling to work out, who is this? Who do we contact? Anyway, that's an IAM user. Username and a password pair. And from there on, what access do you have? Well, this is where policies come in. Now, another word pair. A policy is a document. And the rest is all blah, 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 blah for purposes of the exam. If ever there's a question about what is an IAM policy, it's nearly always, it's a document and it'll be the one line. Everything, other answers will have something else. But the document grants or denies permissions to the AWS services and resources. Best practice here is only give me enough permission to the system for me to do my job. So don't give me unrestricted access to do things. Here's an example. This is a policy document. So what am I allowed? Am I allowed or denied access to do the following? So you can have either allow or deny in there. What am I allowed to do in this case? Well, it's an S3 permission. I can list all the objects. So I can see the names of the objects in a bucket. And I can get them, so I can download them. I can read them, so I can do that. You notice that put's not there, so I can't upload or I can't write. I can just see what's there and download it. Then a resource, well, what's the bucket? And here's the name of the bucket, so it's this one. And then / says, and everything inside that bucket, because an AWS bucket can have folder structures, much like your laptop can. So that's an example of a policy document. What I do is I attach those policy documents to IAM users, or more importantly, I can attach them to groups. Unless you're a single user account, now if you've got most customers, they'll have groups of users based on typically the role. So we might say the cashiers. Well, every time we have a new cashier, we'll attach that cashier's IAM profile to the cashier group. And best practice is assign the policy documents at the group level. And the reason you do that is if you assign them to each user down here, if the cashier one got moved to baristas or to the back office system, you'd have to remove all of those policies from here, and then you'd have to attach all the policies that go with their new role. Well, that would be kind of tedious and error prone. What you do, you just assign the policies here. If this user got promoted or moved, you remove this user from that group, you attach them to the new group, and they automatically inherit all of the permissions of their groups. So it's a lot easier, especially where you get customers with thousands or tens of thousands of users. How do you make sure everyone's got the right permissions? Create groups and attach the policies to the group. Okay, another pair of words. If I want to give temporary access or permissions, I use an IAM role. So role and temporary go together. So if I'm working, say, in a coffee shop, and I, as the owner, say, hey, I will give people the ability to change roles. So I've got the cashiers, and they can access the FPOS system, but they can't access the back office systems for inventory and tax and payroll. But we might have stock take at the end of the month. And we ask the cashiers, hey, can anyone help out with stock take? Which means that they have to get access to the inventory system, because as they go through the stock and count what's on the shelves, they have to update the inventory system. We might say, because you can change roles, temporarily a cashier can become or assume the inventory role. Now, while they're doing that, they lose access to the cashier role because they don't want to accidentally do something here that would impact over here. There's a lot of other use cases for this. I mean, if you've got an S3 bucket and you want an AWS service to do something with it, sometimes we give the objects a certain role that the service can assume. But just for this purpose, whenever there's a question about how do you give temporary access to resources, you use an IAM role. So it's just purely temporary. So while this cashier is acting as an inventory person, counting on the shelves, what have we got? They've got access to the inventory system. As soon as they stop doing that, they're back to being a cashier and they lose access to the inventory system. So they're one or the other. Multi-factor authentication you've probably used if you do things like online banking. So you've got your username and password pair. Then you may have a little device that you say push this button and it comes back with a set of numbers, or you may have an application on your phone. I mean, I've got Google Authenticator. And every 60 seconds it says, here's the new code to type in. So that when I go to log into AWS, I've got to have all three: username, password pair, this device. Now, this is becoming increasingly common in AWS space for all users to have. It used to be not so long ago that only privileged users like server administrators, database administrators, anyone who had, higher than normal access to the system, they'd have it. But because there's been a huge uptick in social media engineering apps, Many of the customers I've worked with are saying, no, every user has to have this multi-factor authentication. The reason being, if you have a username and password pair and that gets captured by a hacker or malware or something, they'd also have to have this device to be able to log in. So you've got to have all three. So it's not enough just to capture the username and password pair. You'd have to know what this code is, and it changes all the time. So if you've ever used that, that's called multi-factor authentication. And yes, best practice is to assign multi-factor authentication to the account user that you locked into the Fireproof safe. It's just another layer of security for logins. That's IAM. So Identity and Access Management. I am Glenn. What am I allowed to do? And I can belong to IAM groups. This next service, Organizations, is designed to help manage AWS accounts, because in a large environment, customers can have tens or hundreds of AWS accounts. So Organizations only works at the AWS account level, not IAM level. And what it does is you set up an account structure. So you have a root account and you invite other accounts, member accounts, to join. And this root account can create what's called service control policies. And it can push or force those policies onto these accounts. For instance, passwords. How often should you change a password? How complex should it be? Well, this root account up here can say, here is a service control policy that says you must change your password every 90 days. It's got to be this complex. And for other accounts, it might say you've got to change it every 30 days and you must have multi-factor authentication. The problem it solves is that I don't have to log into every one of these accounts and set that up. I can sit up here as a systems administrator, as an organization administrator, and say, here's the policies. You get that policy, you get a different policy, you get a different policy, without needing to log in and do things. So it operates at what we call the directly linked member accounts. So these two, they may have must change password every 30 days, must change password every 30 days and have multi-factor authentication. Or it works at what we call the organization unit level. So I can create an organization unit and I can have multiple accounts in here. And I can say, look, you all have to change your password once every 90 days. Think about a large government agency that has department, say a transportation, one that has multiple agencies, say planes, trains, and automobiles. So you could have an org unit for planes, and you may have their test accounts, development accounts, production accounts, all that. And then you've got trains, they have a different set of rules, and then automobiles, they've got something else again. And I can sit up here and go, okay, planes wants to have this kind of password rule, or production account, all that kind of thing. I can set up the rules using service control policies. So remember, Organizations does not work with IAM. It only works at the account and the organization unit level. Got it? Because here's a typical sample question. Okay, most people are going for C and E, and that's good. Organizations does not work with IAM. So that rules out A, B, and D, leaving only two answers. Unfortunately, that's the two that you want. So Organizations works at directly linked member accounts, so this level, or organization unit. So it's got nothing to do whatsoever with IAM. So that's often the most confusing of the questions that we do. That one. Okay, compliance. So we've talked about typical IT teams. Now let's look at compliance people. So governance. Glenn, we work in finance. We're subject to these financial controls. Where do I find the results? Where do I find how compliant is AWS? Well, that's where we have the artifact service. I'll briefly describe this and then I'll show it to you because it makes a lot more sense when you see what it's doing. But Artifact has two main features, plus it also makes available our auditors' reports. If a customer said, we want to audit the AWS cloud, not going to happen. It just doesn't happen. But what we do is make available the compliance reports from our third-party auditors, and that's always enough for your customer. They've never ever insisted to be able to audit the cloud. But the other thing Artifact does is it says, here is those compliance reports, so you can find them and customer can see them. And it may also have some agreements that your customer, not you, but your customer needs to agree to. It could be, if we're operating in this country, we agreed to abide by these rules. So let me show you what it means, because it makes more sense when you see it. If we go to here, I should refresh that. Yeah, see, that was a disk we upgraded before, now in service, just to prove that I was telling the truth. Artifact, that one. So we said you can view reports and agree to view agreements. First off, let's view reports. So this is all the compliance things that are available. So in Australia, for instance, if you are working with a financial services customer, we have a regulatory authority called the Australian Prudential Regulation Authority, or APRA. And they have a workbook that your customer has to work through. You could go, well, click, I want that. And it says, basically, it asks those questions. Who's responsible for this, or what are the processes? Who can get access to the computer room? You go, well, that's an AWS responsibility. We know that from the shared responsibility model. No one can unless they're authorized to do whatever it is. And it just spells that out. So it's all the answers to whatever regulatory body you're reporting to. I mean, I think there was a New Zealand one, Taiwan's there, Korea's there. Oh, yeah, Bank of New Zealand. I think they're the common ones. There's probably lots and lots of others in here. So you would just type in the name. It may take a little bit of hunting sometimes because, say for New Zealand, I usually type in NZ. It wouldn't find that. It just goes, no. So if you're looking for one of the workbooks and you can't find it, ping the AWS account team and they'll go, oh yeah, this is what you're looking for here. Here's the words to type in. Usually you can find it, but sometimes you can't. So that's all that is. I download this workbook. Here's the answers to it, supply to the auditors, the governance people. The other thing it says was agreements. This is a little different. This is what your customer would need to accept. So for instance, my account is running in the Australia, New Zealand area. So I would have to accept the Australian notifiable data breach. Basically, my customer is of a certain size that if they had a data security breach event, then we have to mandatorily report it. And that would say, I've read that as an officer of the customer. I will do that. So that's what those agreements are about. It's just saying we will comply with whatever is required to operate in this country. And again, you can find all of those there. Typically, these are the standards that you're looking for. So in Australia, we've got IRAP. Singapore, there's a Singaporean one. Some for Japan. We've got ISO up here. So depending on what your customer or their auditors are asking for, you jump into Artifact and you can download the reports. We have the Compliance Center. It's a lot of information. And again, it's easier to show than talk through. Compliance Center there. Let's say that you're working with a customer in a regulated or governed industry. Here's where you can find some great resources. So here is a software developer that you might know. Here is a bank. Here are some more customer compliance stories. In terms of resources, lots of white papers. So risk and compliance overview, the auditing checklist. You can find more white papers. Here are some samples of customer videos where they talk about that. Here's some of the fast starts. So how do I build out frameworks to monitor what we're building? So this is customer application development or systems building. So that's the Compliance Center. So in terms of what we did just then, what are the two tasks I can do with Artifact? Well done, A&E. Yes. Consolidate, manage multiple AWS accounts. That's organizations. Create users to allow people and application to interact. That's IAM. Set permissions using service control policies. Again, that's organization. So A&E. That's that artifact. Looking at the reports and agreeing. Okay, application security. This is the big one. I have my application running in my virtual private cloud, and I'm using CloudFront. And I want to control who gets access or not to my application. This will come up, and this is where this WAF, Web Application Firewall rule service comes in. If I'm using it, and this is a question for the technical people. We talked before about virtual private cloud, network access control lists, and security groups. Then we said CloudFront sits on top of edge locations. Do edge locations and CloudFront sit inside or outside your virtual private cloud? What do you think what do you think? Inside or outside? Is it inside your VPC or outside? Outside. Well done. It sits outside, which means CloudFront is not protected by your network access control lists and security groups. So it's sitting outside. Let's say I want to stop certain internet addresses from accessing my CloudFront systems. This is where Web Application Firewall comes in. So it's really good at that. It will pretty much stop attacks before they come anywhere near your virtual private cloud. Now, to give you an idea of how simple this is to set up, let us wander back to this and we'll type in WAF, because this can be a real eye-opener when you're talking to a customer who says, hey, you're on the internet, public cloud, that's security issues. If we go to here, I'll show you what WAF looks like. I'll switch to Sydney. We'll find the coffee shop. This is always fraught with, I have no idea what's going on today, but here's the coffee shop. This is WAF protecting our little web servers and our load balancer. It's really protecting the load balancer. Here's all the activity that's been going on the past few hours. Oh, what's that? Oh, people have been trying to get into my website. Not nice people either. WAF is like network access control lists for CloudFront and for the load balancer. Here's a sample of the activity that's been allowed. Here's a lot of the people, bots from anywhere. So a bot in the US is trying to browse to see if my website has WordPress on it. So that's what that's doing there. The WAF is counting how many times does this happen. So you can see it's really persistently trying to see, have I got WordPress on here? If it finds it, they're probably going to launch known attacks to break into my website. Good luck with that, because the web page that you saw is my really pathetic attempt at HTML coding. It's hand coded. There is nothing sophisticated like WordPress, but you can see people are trying to get in. So it's handling bots doing that. Further on down, at some point in time, here we start to block. So this is someone trying to get into a certain activity, but using a known hacking type technique. There's no user agent header. So WAF just goes, no, you're not even getting close to the load balancer. If I go to here, we'll manage rules. Here's common rules. So someone is really trying to get in. So someone in these different countries, they're really trying to get into that poor little coffee thing. So feel sorry for my little website. Here's someone, really trawling through, using all these different combinations, trying to get in. And WAF is just going, no, you're not even getting to the load balance is protected. If we go on further, you'll see that it blocks. Where's Anonymous? Yeah, people who are using Anonymous like Tor browsers. They're hidden. VPNs, all that kind of thing, where it's really hiding where they're coming from. WAF is just quite happily blocking this. And all this is costing, I think, for WAF, for Web Application Firewall, it's something like $5 a month. And for the bot protection, it's another 10 on top. So it's really, really cost effective. I can tell it block any kinds of SQL injection attacks. I can tell it whatever I want. I can put in IP addresses. Do not allow any traffic coming from this set of IP addresses to get anywhere near my systems. So even though it's probably overkill for my little class, what else do we have? Do we have anything dramatic? Because this is a lot more attacks than I usually see in my class. I just tend to, first time I saw it, I got nervous. But hey, it's doing a great job. Yeah, this is an attack. It's trying to assume that my website is sitting on a home router. And that's a well-known home router attack. But you can see all this stuff is going on. The math's just going, no, go away, go away. Great example of a, $5 a month. Your small customers can take advantage of this, and this is protecting their website from many common types of attacks. That's that. That's web application firewall. Then your customer goes, but Glenn, denial of service attack. So Glenn, the hacker, is sitting in his basement and he's attacking your website. I'm sending lots of traffic to it. And I'm trying to get it to auto scale, because remember, if it auto scales, things start to spin up, pay as you go. I've just sent, you're going to get a big bill. And I think it's hilarious. Your network team sees all this traffic coming from a single source. So remember, all network traffic, who's it coming from? Who's it going to? And they see there's all this rubbish network traffic coming from Glenn's network address. I can add that either to a WAF rule, or I could add it to a network access control list, whichever is easier. My attack gets blocked. Because remember, those rules just block traffic, stops dead. So this would auto scale back down again. Not a problem. Well, then I go, I'm going to jump on the dark web. I'm going to rent or hire a botnet army, which is hundreds of compromised PCs, with malware on it. And I can take control. And I say, hey, everyone, hit this website here. Hit Glenn's website again. This is a tougher problem to solve for, because I don't see the single IP address from over here. These attacks are coming from all over the planet, all different IP addresses. And it's either causing my auto scaling to happen, or it's slowing down traffic for my genuine users, or both. And so customers might ask you, what happens in this scenario? And this is where Shield comes in. Every customer by default gets free access to Shield, which is a system designed to protect against distributed denial of service attacks. Basically, it's the economies of scale piece coming back in. That because we're running millions of customer accounts on our global network, we know what an attack looks like, and Shield is capable of deflecting them. Now, to give you an idea of how often this happens, if I go to here, and this is, if a customer says, okay, why AWS? Here is the global threat dashboard, and this changes every day. Close that, close that. Oh, things have got quiet lately. The other day when I ran this class on March 6th, this was up to 50,000 distributed denial of service attacks per day. Over the January break, this was tracking at around 10,000. It's gone up a bit, but you see we get spikes for distributed denial of service attacks. Customers get access to this service for free. It just deflects these. What's the biggest attack? This is quieting down a bit. Yesterday it was 400 million packets per second. It's these kind of attacks. This is just a normal day in AWS network land. So Shield is quite happily sitting there deflecting, what was it yesterday? 16,000 attacks or thereabouts. And customers get access to this for free, so they don't have to pay for it. So again, a small customer gets access to our global enterprise class systems for nothing. This is some of the power of the cloud. Now you might be thinking, but Glenn, my customer has, they're a government agency, very high profile, could be controversial. They have a very big website presence. Their auto scaling groups go to 100. What happens if there's an attack? Well, if the customer has those kinds of concerns, Shield, they can subscribe to Shield Advanced. So it's an extra cost option. But it means that if there is an auto-scaling event that happens because of a distributed denial of service attack, the customer gets it's either a refund, a rebate, or a credit. I can't remember the exact commercial terms, but basically they get their money back. Plus, we have a team that Shield would alert. And if the customer has given access to this team, this team can jump in and they can start setting up additional web application firewall rules without waiting for the customer. So proactive support. So if, Sunday night, when their customer's asleep, if something happens, this team just jumps in and they start deflecting the attack, because it's not just about the costs, but it's about the impact for genuine visitors coming to that site. So if you've got large customers, highly visible, controversial, like governments, things like that, they're being subjected to these attacks daily. This is par for the course. This is what we see. For many customers, free version of Shield is sufficient. But where your customer has like big auto-scaling groups or big presence, or they're concerned about costs, then you can subscribe them to Shield Advanced. It works really well. If that was attacks from outside in, Inspector periodically scans the settings for security on the all of the resources, and it gives you a report. So Inspector will sit there, it runs, tests, it checks to see who's allowed to get to these servers. Remember when we had the EC2 instances and we changed the security group? I will probably get an alert today or tomorrow that says, Glenn, you had EC2 instances with publicly accessible IP internet addresses. Why don't you use the load balancer? Now, you and I both know that we just set that up so I could show it, but that technically is against best practices. Put a load balancer in front for publicly accessible services and let the EC2 instances just talk to the load balancer. Well, Inspector would find that and say, hey, Glenn, there's a better way to do it. A couple of other security services we have. Another word pair. You use cryptographic keys to encrypt and decrypt data. And the way you can manage and create those keys is with the key management service. So if ever there's questions about cryptographic keys or encryption and decryption, key management service was there. And you can use that to simplify creating those keys. GuardDuty is an intelligent threat detection service, and it's brilliant. From a partner's viewpoint, this is a vastly underestimated service, and it works brilliantly. It's very easy to set up, and if you do managed services, I would strongly recommend turning it on. I had a government agency as a customer. I was their TAM, and they were extremely secure, probably one of Australia's most secure sites. And they had everything. Multiple copies of antivirus, malware detection, intrusion detection, the whole shooting match. And as their TAM, I went out there on Wednesday afternoons. I go out there and I said, we've just released this new service called GuardDuty. And they said, Glenn, do you remember where you are? And I went, yeah, I know you've got all that security stuff. They said, good, keep talking. And I said, well, GuardDuty, it's intelligent threat detection. And they went, Glenn, do you know where you are? I said, yeah, I know, but this apparently is really cool. And I said, because you come out every week and we like you, even though you don't know as much as we do. They didn't say the last part, but it just went without saying. We'll turn it on. I thought, really cool. That's great. I turned up the next Wednesday. I said, how's GuardDuty going? And they went, it's broken. It doesn't work. What do you mean? They go, it's finding things that our other systems are not finding. It's generating this alert, and it can't be right. Nothing else is finding it. And so we worked with the service team who built GuardDuty, and the service team came back and said, have your customer check this EC2 instance. It has some extremely sophisticated foreign government agency malware. It is trying to do a very slow crawl through Route 53's entries, its domain records, looking for other government agency entries. Basically, a foreign government was trying to trawl through my customer's Route 53, looking for entry points into other Australian government agencies. And the customer was both horrified and stunned. Nothing else picked this up. They go, this is good, but then how did it get in? And so GuardDuty, if you have managed services, especially security services, it's a wonderful tool. It finds stuff that you really don't want to see. But when you find it, you go, okay, something's happened, away we go. I don't want to guarantee, but many customers that when they first turn GuardDuty on, it starts to come back with a report. Hey, check this out. I'm seeing strange behaviors. So it's a really good tool to complement any security managed services that you offer to customers. In terms of knowledge check then, okay, what can you do with a policy? Or what is a policy, I should say? Okay, a lot of people are voting for B. Now, the next question is, how many people got to B? They said a document and they went, click, it's it. And you didn't bother to read the rest because that's very common with these Cloud Practitioner essentials. It's usually that crystal clear that when you see IAM policy, you look for the word document. And yes, it does grant or deny permissions to services within the AWS cloud, but that's an example of the word pairs that we talk about. So it's B, it's the policy document. What's best practice to give temporary access? What would you use? Yep, again, an IAM role. So it can give access for up to 72 hours. When you request, I want to change roles, you tell it how long do you want it for, and you've got that access for that time. So C is the best practices way to give temporary access to resources. What's the concept of least privilege? Yep, B. And you can lock down permissions a lot. You can say, for instance, especially if you're working in a data sovereignty environment, Glenn can only access the resources available in Sydney region. Can't go elsewhere. You can do that. Or you can say Glenn can only work on EC2. He cannot work on databases or can't see costs. Very fine granular control. Which service helps against distributed denial of service attacks? Okay, so yep, this one is Shield. So that's the one that had that chart that showed the global attacks per day. That's Shield, and it's extra cost cousin Shield Advanced if you want protection against auto scaling. Correct. What can you do with KMS, Key Management Service? Cryptographic keys, because you need those keys. Now, to give you an example of when do you use it and when don't you use it, when you get your email that says, here is the slides that we talked about today, that is a link to a zip file in an S3 bucket. That's not encrypted. Why not? Because I would have to give everyone a set of keys. And basically, I've been running these. Yeah, this is, I think, day 5 of running Cloud Practitioner. That's a lot of keys I'd have to manage. And KMS would help, but then I've got to generate them and send them out. So that S3 bucket zip file is not encrypted. But if I was going to store, say, backups, I'd set the default for storing to S3 is encryption is turned on. And that way, if someone did download my database backups, they still would need the key to get access. So they don't have that, so they can't. So cryptographic. That was security in a nutshell. Some very powerful concepts in there that you'll probably need in the field if you're talking to an on-prem customer, because there are sometimes concerns get raised about public cloud, and you've seen a lot of techniques in there about how to address those concerns. We'll take a 5-minute break. We'll come back and do monitoring and analytics. Then we'll have 2 more. We'll do monitoring and analytics. We'll do pricing and support. We'll take another quick break. We will then do innovation pieces, so migration and innovation, and then we'll be done for the day. So not too much longer to go. We're actually on time. Now it's just after, I think, 12:15 for our friends in ASEAN countries. Is 5 minutes enough, or do you need, say, 15 for a lunch break thing? We could go to that. I'm happy with that if you need it. Only if you need it. Otherwise, we'll get through the day much faster without it. I'll give you 10 seconds if you want 15 minutes. Otherwise, we'll just stick with 5. 5, 4, 3, 2, 1. Okay, we'll go with 5. Yep. Oh, someone said 15. Let's split the difference. Can we go 10? Will 10 work? Because the next modules will fly through. I guarantee it. Yep. 10's fine. Okay, we'll do 10. Yeah, we try to make it so that people are comfortable in the learning environment. We'll do that. Let's do that. See if I can type it properly. Yep, 10 minutes. Okay, 10 minutes, and then we'll come back to do monitoring analytics, pricing and support. Then we'll be set up to do the last module after that. Okay, 2 more sessions and then we're done for today. So we've got 2 modules in this session because they're both very short modules. Monitoring and analytics, very powerful tool sets to be aware of. We're going to look at 3 of them: CloudWatch, CloudTrail, and Trusted Advisor. What do they do and how can you as a partner leverage their capabilities to really help customers automate what they're doing? First one's CloudWatch. Coffee shop. Let's say you've got certain metrics that you're watching. How long do people queue up in the shop? How long are they waiting? And then the other metric, well, how many products have we got left? And do we need to order in or make some more? So you'll say, well, if people are waiting for more than 5 minutes, open up another cashier station. If there's fewer than 10 pastries or if we're running out of coffee beans, get some more. And that's all that CloudWatch is doing. It monitors your AWS and on-premises infrastructure if you require. So where you're doing a migration, you can set CloudWatch up to monitor your on-prem hardware. It then takes all the metrics that you've told it to collect and it aggregates them into a single location that you can view, you can take action with, or you could send on to, say, your own billing system. So if you're offering managed services, you could say, yeah, collect it all and send it off to the logging system so we can do bills. The most powerful piece, though, is this. You can configure automatic alerts and actions, and you've kind of seen that already when we did that auto scaling group and we terminated a instance. CloudWatch in the background went, hey, something terminated. We're supposed to have 2, generate an alert. It lets you produce these kinds of dashboards, and these can be useful, but not in the way you think. The first time you show it to a customer, they go, great, we can have the equivalent of NASA's mission control with all those TV screens up and all this stuff coming out. And that seems really cool for the first week. And then you realize, well, is that a good number or a bad number? Should I do something if that gets down to 2? What should happen? Now, in the hands of a subject matter expert for, say, in this case, RDS, they go, oh, wow, I can see this pattern here. This is what's going on. But in general, it means that someone would have to be watching these screens and understanding it, reading it. It's far better to use CloudWatch's automated actions to do something in the background. Now, I'll just check to see if we've still got it. If we go back to EC2, you'll see these things in action. I'll do that one there. And section terminated. No, don't terminate my session. Sorry, that was another example I was running. Here we've got our instances. If we scroll down to the auto scaling group, and I think we did this on Monday's class because they wanted to see a different type of failure. I'll go to the scaling group. I go to activity. Let's see if I can find it. Not that screen. Here is where we actually ran the stress test. So we simulated stressing out the EC2 scaling group, i.e. they were getting really busy. You can see here that a CloudWatch target tracking Glenn's Coffee website alarm high. It increased the server count from 2 to 3. So basically, we simulated a lot of activity coming to the website. Give me more instances. Here's another one where it goes tracking alarm low. That says, well, the servers have gone idle. They're not so busy anymore, and they've been like this for a few minutes. Terminate. So go from 3 down to 2, the number of instances. This is CloudWatch doing all this behind the scenes. CloudWatch is monitoring what is going on. So if we go up to here, we said monitoring. It's tracking what's the capacity of the auto scaling group. So how many instances do we have? And I think if we do it over the last week, we'll see bumps in here. Yeah, here's where it went up. Number of services in count. It was only for a very short period. So that's why it just looks like a strange number. But this would go up to 2, then it would probably skip across to 3. Yeah, or 2 to 3. Yeah, I'd have to focus on it because usually you do one at a time. Oh, a small few. But you see it jumped up in response to that test we ran. It'll also track what's the total compute capacity of the cluster at any one time. So again, you would see these spikes where we were doing tests. Again, if I go to 1 week, yeah, you'll see that it got super busy a few days ago. So you get all these little spikes, and you can set all these different thresholds. And When something happens, you as the solutions architect or operations manager, you can say, if CloudWatch sees this, go do that. Now, it's not just about traditional IT either. There is a website we have, I think some of you saw it before over the long lunch break, well architected, where I can have my applications produce these metrics as well. Now, the one that's of importance for many customers is, how do I match my IT AWS costs to business costs or business outcomes? So I could drop down to, this is an example of where we do things. But that's the high-end ones. Let's not do that. Let's just pick the simple ones. Here are what we call intelligence dashboards, and partners and AWS teams spend time showing customers how to build these dashboards up. So basically, it's just collecting cost data and it's mapping it into actual business outcomes. So here is one that the technical account managers sometimes use. When it shows it, if it shows it, here we go. Yeah, customers can see, so how did my invoices, how have they been changing? How many accounts was it monitoring? How many services did we use? So CloudWatch is brilliant at doing this in conjunction with some of the cost tools that we have. So, when a business leader says, so our bill went up, but our revenue skyrocketed. Wasn't that the best thing ever? Like for a Black Friday, Cyber Monday type sale event. Because having AWS costs go up is not necessarily a bad thing if there's a corresponding improvement in a business outcome. And these are the things that you can track. CloudWatch and the cost tools let you do that. So that's the power of CloudWatch. If it sees something happen, for instance, every time someone comes to the website and they order something and they go through to checkout, your application could say, okay, I checked out an order. Here's the value of it. CloudWatch could collect those so you could graph out, well, here's the number of orders we took. Here's the value of them, total and average. And then match it to, here's the AWS auto-scaling costs if you want. I used to do that a lot with finance or technical teams and non-technical teams because everyone had a common dashboard. They could say, hey, our costs went up this day, but here's the business outcomes. So CloudWatch, very, very useful for monitoring the cloud. CloudTrail is the audit trail. So when you want to see what happened, such as, you're working in the coffee shop and a courier turns up with a box of beans. Here's the beans that you ordered. Why did we order beans? We only order beans at the end of the month. So you go back through the inventory system. Yep, 2 days ago, we ordered a box of beans. But why? Why are we running out? 3 days ago, there was a very large order. That fleet of tourist buses turned up and we had a lot of sales. But it meant that we used up our inventory. CloudTrail is the same. Remember when we talked about interacting with the cloud and I said application programming interfaces, APIs. CloudTrail tracks every API request. It knows when did it happen, who made it, and what did it happen to. So that I can then filter out the API calls if I want to see, well, who created this user or who stopped Glenn's EC2 instance or where did this EBS volume come from? What's been happening with it? CloudTrail is perfect for that. It also automates the detection of unusual account activity, such as someone trying to log in unsuccessfully as the account root user. Especially if you've got multi-factor authentication, it's going to detect someone continuously trying to get in like that. So CloudTrail is really good when you suspect a problem. Sample, who created IAM user Mary? Where you could say, well, here's the object. I want to see all of the events related to that IAM user Mary. Come back and say, well, John made the request to create the account. He made it at this date, this time, and he used the AWS console. So CloudTrail is your audit trail. It lets you filter out all of the API requests. So in this question for CloudTrail, well done. People are picking B's and D's. Don't forget, if it says select 2, no half marks for you in the exam. but we'll talk about exam strategies right at the very end. Yeah, B and D. A, that's CloudWatch, monitoring the infrastructure in real time. CloudTrail is monitoring the API requests. Viewing the metrics, that's CloudWatch. Filtering to see what's going on, that's CloudTrail. And configuring alerts and alarms, CloudWatch. So, yeah, sometimes it can be confusing because we have CloudFormation, but CloudWatch is watching the cloud, looking at the numbers. CloudTrail is the forensics, the audit trail. The last tool in this section is Trusted Advisor. And this is an underestimated tool. Every AWS account has Trusted Advisor, but very few people look at it. And all it is, it's like having a consultant continuously sitting in your coffee shop reviewing operational practices. And remember, Inspector looked at security practices, Trusted Advisor is looking at operational practices and making recommendations. You get real-time reviews of what's going on. It compares your settings in your account to 5 pillars of AWS best practices, and it gives you guidance. For instance, these are the 5 pillars that you should probably make a note of their names. And it says, Glenn, I've checked those pillars. I've run some checks. A lot of your, you don't have issues anywhere. It then has, well, you should probably look at these when you get some time, as opposed to, you probably need to look at these right now. And to give you an idea of what it looks like, again, you know where this is going. We'll fire up mine, and this is always, could turn up anything. Trusted Advisor. Trusted Advisor. The nice thing is it sends you an email. I get an email every week that tells me how I've messed up my training accounts, but here's my dashboard. Oh, 4 today. Wonderful. Here it's saying, Glenn, there are some things that you should probably look at after the end of class. Now, I'm going to be so busy that I'll just leave it, but I'll review definitely what they've got. Here's a couple of ideas for improvements. And here's some checks that I've said, look, don't worry about it. I know what this is about. So, S3 block public access for a certain bucket. So I've got, potentially I could set this bucket up that people could read whatever's in there. Then it's saying that's not best practices. What else is checking? Yeah, load balancer, it's doing that. I've got the load balancers right, that's a good thing. I've got some IAM user access key, so a security issue. It just says, Glenn, they're kind of old. You haven't changed these in 90 days. So not like passwords, this is something slightly different. In fact, this is how you get access to the slide deck. You won't actually see the keys in operations, but it uses the keys when you get the link to say, here's the slides for today. It's using that, and I haven't changed them for a little while. Probably I should do that later this week. Here's some EC2 instance optimizations. So Glenn, you could probably save some money by doing this. And this is just a clue. If I pick security, for instance, you'll see what kind of checks it's running. So yes, I have a machine learning setup that goes to a publicly accessible data source. It's going, hey, may not be best practice, but I can tell it to exclude it if I want. I know what this is about. Don't remind me about this check. This came out of the well-architected classes, and we just simulated a security fail, and it's picked it up. Here is one about the S3 bucket settings. So you'll see what's going on here, that it is like having this advisor, but why don't customers look at it? So this is field experience. As a TAM, we used to look at every customer's trusted advisor report every week, and we would say, hey, there's a couple of areas here that need attention. But for many people, it's like if you haven't been to the dentist or the doctor for a few years, you go, oh, I'm not going to go. He or she's going to find something wrong. Yes, and that's probably a good thing, don't you think? And that's the same thing here. So as a partner, this is another source of value add. You go through here, you look at, okay, what's a really easy fix? Especially if it's one of these red ones, can I improve the customer security setup? Can I improve the performance? Can I improve their cost optimization? Fault tolerance? Fault tolerance is usually, have I got all my eggs, all my EC2 eggs in one availability zone? So that if something happened in that availability zone, for instance, I'd be in trouble. Well, that's what that could be talking about there. All these different things here. In fact, I'm kind of amazed. EBS snapshot. Okay, this one says, Glenn, you've got some EBS volumes you haven't taken a snapshot for. That's my little web servers. Now, there's nothing on them that I need to be worried about. So I could say, Don't worry about that. Suppress that setting. Trusted Advisor, very useful for people in managed services roles. It's a great way to help customers improve their operations. So back to the slides, quick knowledge check. What can you do with CloudWatch? Yep, everyone's getting it A and D, those two. So that's CloudWatch. Okay, next question in that case. Which of the tools we looked at can look at S3 buckets for permissions? Yep, C. See, it's Trusted Advisor. It was the tool that just goes and checks. CloudWatch just says, hey, here's a metric. It doesn't try to interpret it, good or bad. It just says, here's a metric. You told me to tell you if you breach a threshold. CloudTrail says, here's the audit trail. It's Trusted Advisor that's looking for S3 buckets. Oh, which of the two categories are in Trusted Advisor? Yep, B and E. Now, what's going to annoy you a little later is there is another tool we look at called Well Architected, and it swaps fault tolerance for reliability. But for Trusted Advisor, it's performance and fault tolerance. Now, between you and me, I don't know anyone, including the TAMs, that could go into Trusted or that would tell you these off the top of their heads. We just used to use Trusted Advisor. We would jump in and we knew what we were going to find in terms of the headings, but we didn't know the actual name. So whether it's fault tolerance or reliability, so you may have to remember it for the exam. But if you don't get it, don't worry too much. Now that was the monitoring and analytics pieces. So very, very powerful, especially in the automation. To give you an idea, one of our media customers, they took CloudWatch events coming out of the security system. And if it saw certain security issues, they had CloudWatch send alert notifications to their Slack messaging system. So Slack is a very common messaging system. It's like Facebook's Messenger for geeks. And so they just said, CloudWatch has seen a security issue, and they ran Lambda on it to process the data and said, hey, this is related to a user or it's related to an EC2 instance. So that their security team could go to their mobile phones or their hand phones. And they go, oh, a message from Slack, event around a user. And basically it would say, I see a security event with this user ID. Do you want me to disable the IAM account? If it was about an EC2 instance, they could go, do you want me to apply a security group that basically isolates that EC2 instance? So these automation capabilities, they seem really simple, but they can be extremely powerful. We've seen it with auto scaling, but customers use this a lot to link and automate responses to incidents. Let's do pricing and support. We've already done a lot on the pricing side, so this will just be skimming through it. So we're going to do how do customers pay and budget for AWS services? That's important. We've seen some tips there. And where can you find third-party software? So in terms of pricing, the free tier, some services are always free. For instance, Lambda. The first 1 million requests to the Lambda service every month, they're free. Now, before everyone says, oh, great, so if we convert our EC2 instances to Lambda, customers don't get any kind of bill, hold that thought, because that's usually people's first reaction. Some services are available for a 12-month period for testing, say, EC2. If you set up an AWS account, you can use a small EC2 instance for 12 months for free. Other systems we have, they're available for a trial period, maybe 7 days, 30 days, something along those lines. But if something is available for a fixed period, the period is always 12 months. In terms of the concepts, we've done the first two a lot this morning. This is a newish one, pay less with volume discounts. So some of our services, especially ones that are based on capacity, so storage, networking, once you pass a certain consumption threshold, the incremental price drops. So S3, for instance, I think once you get over storing 400 terabytes or 450 terabytes, the cost per terabyte comes down a little bit. It's only small numbers. It's nothing as dramatic as these two, but it still adds up, especially for our large customers. Now, how do you find how much things cost? And there's two aspects to this. One is the pre-sales sales environment, and the other one is the operations environment. So I'll just show it to you first, and I'll explain it as we go. We jump into the pricing calculator, and you're working with a customer, and they say, okay, let's build out this trial of SharePoint on AWS. So you jump in and you go, let's find EC2. Okay, I want to configure this quote. Then it's going to ask some simple questions. Which region do you want to operate in? So we'll pick Ohio, for instance. What operating system and software do you want? So Linux, well, it's probably, if it's going to be SharePoint, I probably want Server Enterprise, for instance. You may not, but I'll just pick this one. How many CPUs, how much memory? Well, that'll do. And it comes back and says, well, this is the instance that matches that. So you don't have to know their specific instance names. You say this, or the solutions architect will tell you, we want whatever we want here. Or if they tell you the specific instance name, you could pick it. But you say, okay, for purposes of quote, 4 CPUs, 16 gigs of memory, sounds about right. How many do I want? Well, high availability, I want 2. How do you want to pay for it? Do you want to use on-demand? Do you want to use savings plans? Do you want to use reserved instances? Well, if it's a proof of concept or a pilot, let's just go with on-demand. What kind of disks do you want? And it pops up with a number. Here it's going to be, what, $2,500 US per month. Great. You can work with the customer on that, plus your services on top. Here's the cost per month to run this system. And away you go, and that's what it should cost. If you're in managed services, you can do the same thing with running systems. You can see how much should it cost. And then there's another tool we'll talk about soon, how it can act as a guardrail. If you completely have changes in characteristics of the way the service runs, this would act as a guardrail to say, hey, Glenn, things have changed. And I'll give you a great example of that in a moment. So that's the pricing calculator. You can assemble, I want this service, keep adding the services in, and it will generate the quotation for you. In terms of pricing, well, Lambda, as we said, you only pay for the times that it runs, so up to 15 minutes. You pay for how many times, but there's also this free tier element. The first 1 million requests are free. And you're probably thinking, great, let's use that. Here is an actual story from the field. 2019, one of the other TAMs in the team I worked in, she had a customer who was Australian government, and they processed paperwork. People would bring their paperwork into their closest office. The agency or the office would process the paperwork, maybe 5-10 minutes, and then people could go home. Great if you're in the city, but some of our population lives like 2, 3, 4 hours away from the nearest office. So they drive for 3-4 hours, 5 or 10 minutes in the office, turn around and go back home again. Now people are going, oh, this is horrible. So the government agency said, well, is there a better way? And they said, well, most people these days have a mobile phone or a hand phone. What if they took a photo of the documents, uploaded them to the website? Website does its magic, uploads it into the back-end processing systems, and then we can send out the documents to the customer. Saves them a lot of time, basically a day's worth of travel. They thought, great. So they said, yeah, well, if a person uploads a photo, they can send it to Lambda. Lambda can do the virus scan, it can do whatever. And in fact, I'll show you quickly, super quickly, the service that they used, because as a partner, you might be interested in that. This is the difference between AWS and, say, the other clouds. If you ever get asked, I'm not trusted advisor, text tract, this one. What they did was people took a photo of the document. Document arrives into the S3 bucket. Lambda goes, new object, run a virus scan. Then it goes, it's a photo, send it off to this text extract service. So text extract takes a photo looks at a photo and extracts the text. And then it sends that text, or it uploads that text to wherever you want. And so they had it uploaded to their document processing system, whatever it was, and then it mailed out the documents to the user. So it's fine. In fact, a lot of customers do this. One of our other customers does something exactly like this for insurance claims. So that if you go to a doctor and you get the receipt, you take the receipt, take a photo, upload it. Claims processing dropped from 2 weeks down to 2 hours because TextRack can extract the text that it sees from any kind of document, and it just uploads it. And, usually a person wants to check, this looks right, this looks right, this looks right. As someone says there in the comments, similar idea. So this is why a lot of people, when I ask my customers why AWS, it's this kind of capability to link one system to another system to improve business efficiency. So, customers who drop their claims processing from 2 weeks down to 2 days, customers are happy. Hey, I'm getting my money back. The customer themselves, they're going, well, yeah, we're getting less errors, less manual intervention, less all this. So worthwhile bearing in mind. However, back to this one. They worked out how long it was going to, they could do this. So they said Lambda, away they go. And they said, well, how many times will this happen every month? And they worked out about 100 times because they knew from their regional offices how far away people lived, and they just did some calculations. They said, about 100 per month. March 2020 kicks in and people go into COVID lockdowns and shutdowns, or they just didn't want to travel. The 100 per month of this Lambda function kicking off, suddenly people went, hey, this government agency, we don't have to go to their office. We can just upload our stuff. In some cases, it was 100 per minute. And they smashed well past this free tier because Lambda was firing a lot more often. And Lambda will do that. If you give Lambda lots of things to do, it will just fire up simultaneous Lambda functions. That's the good thing about it. So it handles peaks and troughs. But because it was getting slammed with workload, the cost shot up. The Lambda went well past $1 million. The TAM rings me up. Hey, Glenn, we've got a problem. This customer who was getting zero cost for their Lambda functions, now they had thousands of dollars worth. And this is where we looked at what was going on. We said, well, in this case, Lambda's not a good fit anymore. So we said, why don't you have a couple of EC2 instances continuously running, scanning S3, is anything new turned up, and if it did, process it. And we reduced that thousands of dollars per month back down to, I think it was just under $100 per month. So I don't want to have anyone thinking, oh, yes, the ultimate goal is to have serverless everything. Sure, it works fine in many cases, like that claims processing that we just talked about. But just bear in mind, how can I put some guardrails in place? And we'll see that really soon. We looked at EC2 costs. So we said, on demand, all that. Pricing calculator will spill all this out. So the cost of EC2 plus its operating system that it's running, cost of storage plus load balancers, it's going to call that out. With S3, we looked at the different pricing options because we have different S3 storage classes. This is probably one of the more complex products that we have to cost up, but it gives you an idea of what's going on there. This is a hangover from the other day. We did that and we did that. But what I want to show you, go back. What I want to show you is that Lambda function. Remember I said that Lambda customer who went from zero to several thousands of dollars? We have a service that's included in your account called Cost Explorer. Now, Cost Explorer from a partner to a partner viewpoint has a lot of capability. And I want to show it because this is where you can add huge value when you're working with your customers. First thing, here is my costs for my little class account. You can see it varies a lot. Here is where I'm running machine learning classes, and my costs there go up because I'm running some very big accelerated instance types. The Cloud Practitioner, I have those two tiny little EC2 instances. One is running as Spot, one is running as on demand. My costs don't vary too much. So Cost Explorer visualizes my costs. In fact, I can go up here. I can go view the cost in Cost Explorer. It's going to launch it. It will come back and here's my costs again, but I can say, show me the costs per service. So this is where I get a cost breakdown. What have I been doing for the past few days? which service is my most expensive. And you can see here, SageMaker, that's our machine learning environment. So that's when I ran those classes. And then when I stopped running those classes, you can see my cost dropped. This gives you an idea of what's going on. If you saw this kind of blip and you were my manager, you go, hey, Glenn, what did you do on that day? Oh, yeah, you ran the machine learning class. You could see that. But if there was a blip there that we didn't understand, or there was an increasing trend of costs going up like this, hey, Glenn, are we storing snapshots on EFS again? And then there is a chart I have in another class where I show exactly that, where you just see these storage costs going up like this. And that tells you that something's not being tidied up. So Cost Explorer, that whole notion of pay as you go, is a great way to say, we're paying, how are we going? So, it's a great opportunity for partners to look at customers' costs to say, hey, why is this cost going up? You'll also see over here there is right-sizing recommendations. Remember we talked about the different instance types, and I said you don't have to worry about it. The system will make recommendations. Well, this is where those recommendations live. Now, my classes do not overload my servers, or if they do, it's only for about 5 minutes a day. So it has no recommendations, but I have seen this in the field where it says, customers running this kind of instance, here is a better choice. They would save this amount of money. Or this customer is running these instances and they're not being used. Think about whether they should be turned off or not so that it can save the customer some money. So this is where the right sizing options sit. Here are where the recommendations for savings plans and reserved instances sit. So if you do work with a customer and you are allowed access to a Cost Explorer, if you click on here now, I won't have anything. I shouldn't have anything. I don't have anything because, again, I have tiny little systems that I've pretty much optimized them, but they're not running all the time. But this would come back and say, hey, Glenn, I see some on-demand instances that are running like 24 hours a day, 7 days a week, or close enough. It would be more cost effective to ask the customer, should we set up savings plans? And you can see you get all these modeling options, 1 year versus 3 years. How do they want to pay for it? Things like that. So again, it's going to help you if you have a customer who's been running for, say, 30 days or 60 days. Things are fairly stable by now. This is going to tell you, hey, I've got some options to reduce their costs. Cost anomalies. Now, this is always hilarious on my accounts because it'll talk about, Glenn, your costs varied 30 cents compared to previous months, or $1. But if this had zeros behind it, this is another place to say, hey, our behavior using this service has changed. The tool I really want to show is budgets, because as a partner, this has saved people's careers in partner land. I'll show you how. Budgets, all it says is that I have gone into the pricing calculator. I have said that this project that we're going to run with these servers should cost this amount of money. So for the purposes of this project, I'd go into here and say, I'm going to create a budget and I'm going to put that amount in the budget amount. Great, cool. The budget then starts to track the costs associated with my project, associated with my business unit or my department or my region, whatever I wanted to track. And as soon as it detects that, Glenn, based on the behavior that it's observing, you are going to exceed that budget, it generates an alert. Now, this is super useful. It doesn't wait till you breach that amount. It says that I see that it's generating a forecast amount, and it starts from day 1 of the month. And if it generates a forecast amount that's greater than this, it sends you an alert. Now, 2 examples, one where it worked brilliantly and one where it worked terribly. The one where it worked terribly is I had a partner with one of my customers and I kept saying budgets, budgets, budgets. I keep seeing these cost anomalies where someone would make a mistake. Just people make mistakes. You're under pressure, stress, long day, customers yelling at you, whatever, and you go click, oh, I've done the wrong thing. Glenn, don't worry. Don't worry about this. We've got it under control. We've got systems in place. I said, yeah, but budgets. And they ignored it. They were working not with the government customer. This was a commercial customer, but they had SAP. And they were setting up the backups because I said the costs are going up. You may want to look into that. And they said, yeah, we know. And the person that they assigned to look at the backups accidentally changed the backup schedule. They went from daily to hourly backups. Now, SAP, as you know, probably running on EFS, and it was, and that's our most expensive storage system. The customer got a bill at the end of the month for tens of thousands of dollars more than they were expecting. You can imagine as the account team for that partner meeting up with the customer. Oh, sorry, we made a mistake. And I'm going, do you want to talk about budgets now? So we talk to them about budgets. And that, because of the way budgets worked, it would have picked up that error within a day, as opposed to waiting for the AWS invoice, which you get usually in the first or second week of the following month. So, maybe 30 days worth of mistake. Now, to tell you when it does work, another one of my customers had a partner who looked after their virtual desktops, our workspaces service. And they came in on the 10th of the month, which was a Saturday, to patch up Windows 10 for the virtual desktops. And it just went longer than usual because, a lot of work to do. And when they got to the end of the night, they forgot to stop the virtual desktops. They left them running. And this customer's normal operations were, if you use a virtual desktop, at the end of the day, shut it down to save money. Customer's IT manager gives me a ring on Monday. Hey, Glenn, I've got this weird email from something called a budgets. And it says our workspaces service is going to exceed a budget. I went, oh, that's pretty cool. And, I thought they must have set it up. I said, well, someone was probably working on the weekend or Friday. They made a change. Did they create more instances or did they do something? He said, well, the partner was in on Saturday patching. I said, well, they probably just forgot to turn things off. And he goes, how do you know? And I said, well, budgets is very good and very quick at finding those operational changes that increase costs. I said, so it probably meant that they left the things running on Saturday night and Sunday. And the IT manager got annoyed. He said, so what? They're going to cost me money. I said, well, how much is it? And he did the math. He said, well, so far it's about $100. I said, well, what happens if they didn't have that budget in place? I said, they're really smart. They know that occasionally people make mistakes, pressure, projects, whatever. People just do those things. And I said, but they put a guardrail in place that if someone did make a mistake, you were told as soon as possible. If they had not set up budgets, you wouldn't know till next month's invoice turned up. So that mistake was made on Saturday. You found it on Monday due to budgets. If budgets wasn't there, you would not find out till next month. And $100 per day times 30 days in a month, that's a much bigger error. So from a partner's viewpoint, budgets can be an absolute career lifesaver. So just be aware that budgets, it costs next to nothing to run, but it can pick really major mistakes up and tell you about it. So that's the pricing tools. What we'll do is we'll just do a quick review, because I think we can then skip through the next slides because that shows what that demo does. In the free tier, there is one period where some things are free. What's that? Wow, that was quick. Yep, 12 months. Well done. Okay. Consolidated billing, we've made everyone in IT happy, but what about poor old finance? The issue we're solving here is every AWS account that a customer has, and bear in mind some large government agencies get hundreds of accounts, every account gets an invoice. And that means that procurement has to filter through hundreds of invoices every month, and they will get really upset with you really fast. Consolidated billing addresses that concern. It says, if you tell me what all the accounts are for this customer, I'll give you a single invoice. The customer can review them, it can slice and dice, it can dive right into the individual charges, but ultimately they see one number that they have to pay. And it has this nice effect that it will aggregate the usage across all of the accounts for those services that have a volume discount. So I've got 4 accounts here. I've got my root account, which is the management account, and I've got 3 accounts underneath. That means I'd get 4 invoices every month, but consolidated billing says, no, you just get 1. And this can be a really big deal with, large customers, because I have heard people start to not yell, but go, why am I getting all these invoices? Make them stop. Well, this is the easiest way to do it. The other thing it does is it aggregates the usage of, say, services that have thresholds. Let's say they're using a service that has a volume discount at 10 terabytes. Well, as it is, none of them would get that discount. But under under consolidated billing, they do. It aggregates the usage of all of the accounts. It goes, 14 terabytes, 4 terabytes gets the discounted rate, and it pro-ratas it back to these accounts based on their usage. So it's a nice, easy way to make life easy for your customers' procurement or finance teams and give them a discount. In terms of the pricing tools, we looked at budgets, so a huge value add, especially and a career saver if you work on site. We looked at Cost Explorer. It visualizes, lets you understand it. You can go back over 12 months. You can go down to daily if you need to. So show me my daily costs. You can do hourly, but there's a better way to do hourly, and it's not part of the exam. But if you do want to go down to fine details, that well-architected lab site for the technical people, that's got some samples in there to go to how to go far deeper into the AWS build. But for Cost Explorer, many people, they stick with this for at least the first year. Just show me my costs, show me the changes month on month, show me the different services, all that kind of thing. So it visualizes the costs over time. In terms of support plans, everyone gets basic level, smallest account up to the very largest account, and then you can pay for additional support. So everyone gets a basic set of trusted advisor checks. Everyone gets access to the service health dashboards. You can see what's the status of AWS services in the regions you operate in. In terms of support plans, your customers typically will have business or enterprise. Now, both of these have the full set of trusted advisor checks. By that, I mean it goes across many more services that a corporate or government customer will have compared to, say, a Glenn's private personal account. So the full set of checks. Your customers typically will have this, or if they have the high-end premium support, enterprise support, they get all of that, plus they get access to a technical account manager. So that's sometimes a question. What level of support do you need to get access to a TAM? That's enterprise support. If you do work with customers that have enterprise support, I would strongly recommend find out who the TAM is, get their contact details, get them to talk, because TAMs do the following. We are only available with enterprise support, but we used to provide technical guidance. So when we're going through, say, the cost bills of all invoices for the monthly business review, if there was something that didn't look like it was quite right, we would say, can we talk to the partner? Can we say, well, maybe next month you could work on this, or have a look at this, or see if this can be reduced or improved or whatever. Same thing with Trusted Advisor. We would take all that data and say, look, there's a problem here. This has just turned up. Maybe you might want to look at this. So TAMs can be your friend if you let them be so. Mind you, if you ignore using budgets, hey, you're on your own. So that's support plans. Very simple, but a lot of scope available in there. Marketplace. Let me show it, because this addresses a couple of questions that came up during the lunch break as well. How, if I'm working with a customer and they say, I've got 100 servers in my on-premises data center, and you go through it and it says, some of this is Cisco, some of this is Palo Alto, some of this is Splunk. What's a really quick and easy option you get? This is the EC2 console. I'm going to launch a Splunk instance. So here is the software that I want to put on my EC2 instance. But if I go into Marketplace, this is where our technology partners, let me see if I can make it a little bigger in case you're on a small screen. Yeah, here are pre-built software installation setups by Splunk, by Trend Micro, by Juniper, thousands of these in there. So you're a technical person, you're going, a customer's got Splunk on site. What are we going to do? Well, you can just jump into the marketplace and you go click, and it's going to build up a Splunk system for you, so that you might just have to move the customer's database across, rather than, which operating system does it want? Where do I find the Splunk software? All that. Same with these. So we call this software as a service. It's a great way to help customers migrate those apps to the cloud, because you just go click, new license, done. So that's Marketplace. You'll see there's thousands of these applications sitting out there. So if you do help a customer migrate, just have a quick look into the Marketplace to see if there's any of these pre-built systems. And it has the cost. So what's this? 1 cent per hour per host. Here's another one that has a per hour or a per year quote price. And that just gets added to the account. So the customer, it's a very easy way for you to set up these and then just go in and configure them for the customer's environment rather than needing to build them up and then configure it. So it just makes life easier. So that's Marketplace. So it's a digital catalog, or the technical term, it's a digital catalog of third-party software. It's very much the software as a service piece. And it spans multiple categories. So a quick knowledge check. What can you do with consolidated billing? Many votes for C. Excellent. Consolidates. It makes finance teams' life much easier, especially if it's a very large department with hundreds of invoices floating in. Things just get lost. It just simplifies it. Which tool visualizes and manages costs over time, please? Ooh, haven't seen that happen before. Okay, this is the one that's just going to graph up what your costs have been. So I clearly didn't get that one. If I go into, say, Cost Explorer, here are my costs. I can break them down. This is per month. These are my monthly costs. This is by service. I can go back 12 months, or 1 year, I should say. Well, same thing. Do that. So it's Cost Explorer that visualizes it all, and you can graph it. I can show where were changes, and you can see here, typical of production one, these would be relatively flat or slightly increasing. Now, someone asked before about how do I track costs. I can use tags. I can have cost center tags. So I can say, show me the cost by my different cost centers. This is me all the time just messing around. So here is the cost to run classes. Now, I only set this up I change it from class to class, month to month. But I could track, just show me Glenn's costs, show me Glenn's project, show me Glenn's government department or whatever. I can use these tags to do that. But it's Cost Explorer that shows the costs over time. So it basically is visualizing your AWS invoices. The pricing calculator forecasts costs. So this will show me what my costs have been over time. Pricing calculator shows me what the forecasted costs are going to be. So this is Cost Explorer is actuals. This is projected or forecast. The one that tracks the thresholds. So to give me an alert if I exceed what I think it should be. Yeah, this one is budgets. So this is the really useful one. Okay, if a customer wants access to a TAM, which support model do they have to have? Yes, so my old manager will be happy because he used to get requests and he go, are they on enterprise support? Anyway, enterprise support for that one, correct. Which is the service that finds third-party software? So that's the one that we just looked at. Yeah. And it can make life easy during a migration. So if you're in a migration team, Marketplace can be your friend. Okay, now let's see where we're up to. We take a break. We have one module to get through, and that won't take that long at all. And then we can do the exam pieces. So we'll be finished right on time, which is a miracle given we had 1.5 lunch breaks. So we'll take does anyone need a break now? If you do, just send it to me rather than send it to everyone. Because otherwise we could keep going. But I know it's late in the day for some people. It's early in the morning for others. If you need a 5-minute break, we can take it. Someone needs a break? Easy. Take 5-minute break. We'll come back. We'll do migration innovation. We'll do the exam basics, and then we're done for the day. So we'll finish well on time. So the question, what time are we scheduled to finish, please? 45 minutes from now. or earlier. Okay, last module. Migration and innovation. And this has all different bits and pieces in it, but there's a few exam questions that sometimes pop up. So it's going to seem like we're rushing through it. We're not. We're just doing it at very high level. We're going to cover a lot of stuff, a lot of little bits and pieces in here. But the first one is the cloud adoption framework. When you're talking with a customer about a project, moving to the cloud, one of the traps is just focusing on the IT side of it. And we're going to look to see a framework that we use that works much more successfully. And that's to look at all of the customers' stakeholders. For the salespeople, this is often talking to senior execs outside of IT. And this can often be used to find new projects to help a customer. For other stakeholders, it makes sure that we're addressing all of the concerns that they have. So we look at the stakeholders and we group them into 6 areas of focus that we call perspectives. So we have the business capabilities, perspectives, and the technical capabilities. So in the business side, we have the business people, so the leaders, chief exec, chief marketing person, chief financial person, plus any senior directors. And they're just concerned with, is IT delivering business outcomes? They do not care how it's architected. So is it using Windows or Linux? Don't care. Is it using EC2 or serverless? Don't care. They just want to know, when can we have the improvements? How much is it going to cost? People, that's HR. They're typically looking at their people skills. Have they got the skills, or how do they acquire the skills to implement these radical changes that you're proposing? Governance, that's pretty much the artifact service. We operate in financial services in Australia, for instance. Is the cloud certified, compliant with that? Then we get the technical capabilities. This is where the architects are. So, which operating system do they pick? Which EC2 or compute or containers? What should they pick? Platform team, the architects make those decisions. Security, how can we know that we're automated in terms of detection and prevention of issues? So, setting up those security groups, that's a key piece. Setting up guard duty, that's another preventative piece. Then operations, can we automate all this stuff, so that people don't get phone calls at strange times of the night because the web servers have crashed or something along those lines? So that's why it's important when we do this to work with all of the stakeholders. So business, they just want to make sure that IT is aligned with the business needs. That's all they care about. And these are the typical roles when you're having those conversations. So if you started to talk about, we could do containers, we could do this, they'll tune out. They'll just go, how does that deliver what my customers want? People, this can be a great source of opportunity, especially if you offer managed services, because I've seen this happen, that a customer engages a partner to help them move to the cloud. And the whole idea was, then you help us get to the cloud, then we'll run it. But then the personnel people go, wow, there seems to be a lot of skills required. What if you, Mr. Partner or Mrs. Partner, what if you run our systems for us, and our IT people can act as business analysts and consultants within our company? And I've seen that work really, really well with one customer. They were in an interesting industry. IT got freed up. IT teams are out working with the business. Hey, we could do this using this cloud technology. Hey, partner, can you build it for us? That worked terrifically. That was a win all around. Governance, they just want to make sure that whatever you're proposing complies with the industry regulations, and that's where that artifact and compliance center come in. Platform, it's the platform team that implements new solutions. So they'll design the AWS solutions to make sure that it's aligned with the business objectives. So, architects live here, lead developers live here. Security, this is just, again, the people preventing unexpected, unplanned downtimes due to security events, and detecting and being auditable, checking, are we complying? What are our status? Are we working to AWS best practices? Then you've got operations, just the automation, the people that have to keep things running. So this next question, often we get 50% of the class picking one and 50% picking the other. Now, I will give you a clue. The wrong answers are C and D. So the right answer is either A or it's B. Which one do you think it is? And this is a great example of a question that you read it twice and sometimes read it slowly. Okay, so the question is, it's not C and it's not D. Which perspective helps customers design, implement, and optimize the AWS solution? So who designs the AWS solution? Is that a business capability or a technical capability? Is where this comes from. Because the architects will design the solution based on what the business goals are. The business does not care. They go, serverless, containers, blah, blah, blah. But is this giving my customers faster turnaround? Is it giving them faster payments? So whenever you see questions about designing, implementing, and optimizing the AWS solution, that's a technical perspective. And the business perspective is in business capabilities. Platform is in technical capabilities. So the answer for this one is B. This often tricks people up. Now, it's been a long day. There's been a lot to learn. So don't get too down on yourself if you got that one wrong, because it happens in every class. Every class. We've been at this for just over 7 hours now. I'm surprised that people are still here and still awake. Okay, that was Cloud Adoption Framework. We explore more of this in some of the other classes like Cloud Practitioner, but this is all you need to know for Cloud Practitioner, Cloud Adoption Framework. Migration strategies. There are 7 migration strategies. Yes, it says 6 on this slide, but we'll cover the 7th one in case you encounter it in the field. So you work with a customer. Glenn, we've got 100. Yeah, don't worry, be happy. Yep. You work with a customer and they say, we've got 100 servers. We've got 100 servers in their computer room. Well, are they physical or virtual? Are they private cloud? So how many applications do you have to migrate? So you do a lot of preliminary work to assess, yes, this customer has got 110 really old Dell servers. And some of them are running VMware, so there's so many apps. Then you've got this list of these are the applications. How do we get them to the cloud? First one is rehost, otherwise called lift and shift. Basically, take what the customer has and you end up with EC2 instances. So the tools will copy the disks of the on-premises servers while they're running and generate EC2 instances. So 100 servers in the computer room becomes 100 servers in the cloud. That's the easiest, fastest, no thought required. But you might come across, well, there's some database servers in there. And when you talk to these database teams, they might go, yeah, we're sick of patching and maintaining hardware. Can you take that away? And that's where you go, well, AWS has got managed database services. We've got RDS, we've got DynamoDB. What if we just copy the database across? Leave the servers behind. So we don't copy all of the disks across. We just take the databases across while the databases are running. We call that replatforming. We replatform the database into a managed service, sometimes called lift, tweak, and shift. These 2 techniques are the most common that you encounter during a migration. Refactor or re-architect. Now, I hate this one because this exploits the English language. If you're not an English native speaker, sometimes the question will say things such as redesign. And as the redesigning, re-architecting, it sounds about right. No, the question specifically wants refactor or re-architect. And this is where the customer has an existing system, say a really home-built data warehouse that kind of doesn't work, it takes a lot of time. And you go, hey, AWS has already got a pre-built one, Redshift. Perfect. So you take whatever it is that they've got in their on-prem system, and then you take the data across, put it into Redshift. So you refactor or re-architect the system to use that cloud-ready system rather than migrating that across. That's refactor or re-architect. Repurchase. This is software as a service. This is marketplace. The customer says, we're running this third-party software on-prem. Marketplace has got the same license in the cloud. You just repurchase the license, so migrate the licenses across. Happy days. Very easy way to get systems up and running in the cloud. You just come along and reconfigure it, which is much higher value add. So from a margin viewpoint, if you're in sales and pre-sales, that generates more margin. You're doing the consulting there rather than let's build an operating system, let's install software. Next to retain. that is hybrid cloud, where you're linking those on-prem systems such as safety cameras or manufacturing systems or health into the cloud. Retire, that's where you've got such really old systems that you forgot to turn them off. And that does happen. I started with a project once, or quite a few years ago, walked in the computer room and they give me the tour and I said, hey, there's a cable there that comes out of that switch, goes under the false floor. We opened it up and there were 2 Windows servers running down there that we were still paying for that no one knew what they did. Turns out that my predecessor set them up. We turned them off. No one called. Nothing broke. Yet we were paying for licenses and hardware up to that point. So just retiring old systems. The 7th strategy is relocate. And that's where the VMware and Redshift and containers comes in, where the customer preserves that environment in the cloud so that they're still running VMware, for instance, but they're running it on our hardware. So they've just relocated all their operations from their data centers to our data centers. So that's the 7th one. So which migration strategy involves moving from traditional license to software as a service? Yep, repurchase. Yeah, just in the interest of time, we'll keep motoring because I know some people are really starting to fade, especially if you're overseas. I don't even want to think, what was it, 1 o'clock, 1 a.m., 2 a.m. over there? Yep, repurchase. That's a really common strategy. Snow family. Now, I never watched Game of Thrones, so I don't know who Jon Snow was, but Snow family devices are where we physically move data. So, for instance, let's say you're an archaeologist or you're a geophysicist, you're out in the outback of Australia, you're in one of those planes that does that radar mapping looking for minerals. Well, what you can do is you can take one of our snow cone devices. It's a tiny device. It goes into a backpack. You can plug it into the radar system or you can give it to the archaeologist. He or she can copy their data onto the snow cone and then you physically ship that unit into one of our data centers. So a courier picks it up and it gets carried into one of the data centers. Great for 8 terabytes. Slightly bigger device is a Snowball. Now, it will do up to 80 terabytes. I'll just put it in the chat. That shows you how important this answer could be. But a Snowball, it's like a small little box. It can take either one person who goes to the gym a lot or 2 people, they can carry it. Plug it into an on-premises, say a mine or an oil rig, copy your data onto it, then ship that into one of our data centers. The biggest thing of all is the truck, the monster truck. So we try to cater for every requirement, and monster trucks, it's a truck that tows a container, that drops the container at the customer's data center, they plug it in for up to 100 petabytes. Now, even with the fastest comms links, the fastest direct connect, say 100 gigabits per second, that would take weeks to move that. When you plug it into the customer's network, let's say they've got 10 gigabits or 100 gigabit worth of connection into this thing, then it might take only a day or 2. And then the truck literally drives the data back to one of our availability zones. It's not necessarily available in all countries. I mean, I've never seen one. I don't know if we have them in Australia or New Zealand. I've got no idea elsewhere. But it sometimes turns up as a question. What's the capacity of a Snowball? 80 terabytes. What's the capacity of a Snowmobile? 100 petabytes. In terms of doing interesting things, this is the purpose behind the class today. You've seen the basics. How can we take a customer's existing environment and optimize that? But many times a customer goes to the cloud to add new capabilities that they cannot easily do in the cloud. Size matters, exactly. As someone put in the chat. The hot topics at the past year have been serverless apps. So we saw an example, take documents, take a photo, upload it, Lambda gives it to TextRack. Hey, here's my data. That's great. Many customers are doing that to handle payment processing and claims processing and documentation. Artificial intelligence and machine learning is a big one. It's a hot topic right now. People are going, can I take all the data that I've got so much of it, but can the computer find a value out of it? Now, we have many examples of that where customers are using it across sporting, retail, scientific applications, for detecting frauds, looking at transactions and predicting, is this a fraudulent transaction or not before the goods get shipped out? If you're running a website, a lot of activity in that space. But how do you plan for it all? What are the processes? If you're building systems, like if you're migrating a customer to the cloud, how can you make sure that they're taking best use of the cloud? That's where this well-architected framework comes in. It looks across 5 pillars that look somewhat similar to Trusted Advisor, but this is the tool that has reliability rather than fault tolerance. What this is saying is it's a process, and there is a well-architected tool in an AWS account, and it lets you and the customer have very guided conversations around, well, we're going to take this and we're going to implement this project in the cloud. Are we working to best practices? Now, no customer ever gets everything right. It just never happens in real life. But it does say, well, we need some attention here, or this could be a risk, but we're okay with it. We've got a timetable to run to. We've got to be out of the data center by this day, or we have to renew the entire lease for another year. So it lets the stakeholders make intelligent decisions about compromises where they need to be. It gives you a plan for, yes, we can live with this kind of system now, but then the next steps would be to modernize it. For instance, operational excellence. Are we running operations as code? Now, you might be able to look at things such as auto-scaling groups, for instance, a CloudFormation, and go, yeah, this is great, but we haven't got time just yet. Let's get the customers' workloads into the cloud, and then we'll implement these pieces. That's fine. Well architected has that in mind. It knows not everyone is going to be absolutely correct, but the operational excellence piece helps to anticipate failure. Helps customers always have in mind, hey, is this fully reliable? Is it mission critical? Is it business? And what aspects? We could go multi-availability zone. We could go auto-scaling. We can do lots of things in there. We can do templates. Making small, frequent changes. You know, we have customers that make changes daily to their apps, small ones. Now, most customers with legacy applications tend to do major releases. Well, saying, oh, you should do this, that could be too hard with those apps as they are right now. But keep it in the back of your mind that if an option came up, if a customer goes, look, this is running under Windows or Linux, but if their software vendor that they buy that app from says, oh, we've got a container version, maybe that could be a better way to go in future. So well architected is almost like a living document for a project that periodically you come back and review it. Same thing with security. I sat once in a review. We were doing a well-architected process on a customer site. And usually it takes about a day, and the different stakeholders are in the room. And we said, automating security best practices. Who gets the guard duty alerts? And the IT manager said, oh, they go to the security team. And security team goes, no, they don't. We haven't seen them. And it turns out all they did, they had misconfigured the email address and they put in an old email address and no one was getting guard duty alerts. So well architected found that, and that was a quick change, but potentially they had a security exposure that it detected. In terms of reliability, you know, we simulated server fail, data center fail, and up it popped. You know, that third little EC2 instance just appeared magically in one of the availability zones. Well, is that capability suitable for your customer? You know, can they do scale out, scale in, or do they have applications that need to grow and shrink in size like databases typically do? And how fast can they implement those changes? And that's what reliability is looking at. Performance efficiency. This is where you experiment, you know, using those additional frameworks. I mean, one of my customers wanted to add value to their website. They worked with a partner. They spent a day and a half implementing virtual reality. And they showed it to the CEO and he goes, wow, if 1% of our customers who come to our website used this and it generated extra sales, that was $90 million in a year. Now, that was a very simple thing to do. The partner used our managed virtual reality framework, configured it for the customer's website. It was so easy, yet that's the kind of business outcomes. Then cost optimization, moving to this idea of pay-as-you-go. And we've seen how sometimes it's a struggle for a customer to first get their head around, you know, everything's in the computer room. As soon as it comes in, we rack it, stack it, turn it on, and then we come back 5 years later when we have to decommission it. And you're going, well, does it need to run all the time? Moving to that model, it's a huge advantage for a customer. So a quick knowledge check. In fact, this question is so dull. We'll see how we go. Oh, yeah, this one. This one's about permissions. Permissions always talks about who is permitted to do what, who is allowed to do what Perspective controls access and permissions, and that would be, yep, a couple of answers came in, security. Security always focuses on who's permitted to do what. Basically, the IAM service, for instance. Correct. Now, the next question I absolutely hate, because this is really English as a first language type question. But have a go at it. See what you think, because I don't like this one. Yeah, B and E is correct. Retain and rehost. This redeveloping, I mean, redevelop, re-architect, rewrite, refactor. But yeah, it's classed as wrong because it has to be refactor or re-architect. And you can see now why I hate it, because I don't know how this translates into various other languages, because I only speak Australian English. But yeah, this is one I don't like. Same with the next two. What's the capacity of the truck? Yep, 100 petabytes. What is the capacity of the little two-person box? 80 terabytes. Yep. This one. The ability to recover from service disruptions. So keeping systems going. Yep, reliability. So we did a lot today. We did an awful lot today. We've covered just about all of the content for the exam, which brings us to, we won't take a break now, we'll launch straight into it, the exam basics. If you're not going to do the exam at all, if you're just here for to learning the basic content, then fine, we've finished for the day. So feel free to drop off the class, go to bed for some of you, or go out partying, or have breakfast, because we've seen a wide range of time zones. But for those of you who are thinking of doing the exam, it's extremely useful certification to have. It's an industry recognized certification. It's straightforward to pass. I'm not going to say it's easy, because that would be disrespectful to those who've got it. Last year, I had over 1,000 people in my classes doing Cloud Practitioner, and only one missed out. And I'll show you why he missed out. And he knows he made some mistakes, and we're going to go through that right now. So we won't spend too much longer on this. Let's look at the exam. The exam is 65 questions. Not all of them are marked. I don't know why we don't, but some of them are really hard to choose just to see who gets them right, who gets them wrong. But the exam questions that are marked are over these 4 domains. Now, the domains, is it a free certification? No, it's not. I'll come to that in a minute. The domains are spelled out here, but we've very much covered the domains in a lot of detail today, and you've seen how to use the content in the field as well as in the exam. Recommended experience, it's either a basic understanding of IT and 6 months experience on the cloud, or one Glenn Cloud Practitioner Essentials class. Having said that, there's a lot of material to absorb today. We send out the slides plus additional material probably tomorrow. The strategy is, you've got the slides. If you missed any section today, jump into your APN, your Amazon AWS Partner Network class, go into the training section and search for the digital version of Cloud Practitioner. And you can review any module in any language that you want. To give you an idea, do I still have it up? Sometimes it times out. Do I have Skill Builder up? I'll show you in a minute. Yep. But you should be in really good shape, provided, and we'll come to that in a minute. You've got 90 minutes to complete the exam, unless you do the English exam but you're not a native English speaker. When you book the exam, you can say, I want a 30-minute time extension. Otherwise, you've got 90 minutes, you've got 65 questions. So about 1.5 minutes per question. Some of them are super easy. Some of them you may have to think, like that one where I said IAM manages AWS resources, and it had that second answer, manages AWS and on-prem resources. So don't get tricked up. You only need to score 700 out of 1,000. So there's only 65 questions, not 1,000 questions, as someone once asked, but they have different weightings. The medium and harder questions, you get more points for those. It has multiple choice and multiple responses. You've seen samples of that today. We'll walk through a couple of samples in a minute. If you want, you can tell it what language do I want the exam in. So it's not always in English. It's not free, but talk to your training coordinator to see how he or she wants you to book the exam. Sometimes some partners have exam credits. So talk with either your education person or talk with the AWS partner team to see how should you be doing the exam. I'm not sure. It varies from country to country and partner to partner. It's not run by AWS. It goes to one or I think there's two training exam partners. You can either do the exam online or you can do it in one of their data centers. If you do it online, you've got to have a webcam and you can't have anyone else in the room. You can't have any notes. So no notebooks, no pens, no paper. You just use your keyboard to do it. So it can be a little stressful when you're setting up for it, but that said, once you get into the exam, and we'll do some techniques in a minute, you're away. And you should be fine. As I say, of the thousands of people I trained last year, only one missed out. What were the strategies that we used? Well, there's no penalty for guessing. So the computer has no clue, how did you pick C? It doesn't know. And that's a strategy, because the next one is unanswered questions are marked as incorrect. And so are incomplete ones. So if it says select two and you only select one, it's going to be incomplete. Now, here's a great strategy tip. As you start and go through the exam, bear in mind you've got, what is it, a minute and a half, 90 seconds. Some you'll fly through, others take a little bit of time. But the person that failed, he had a few tough questions up front. The questions that you get vary from person to person. It pulls 65 questions out, I think, of a pool of 250. And he had a few tough ones start off, and he lost track of time. He spent too much time stressing over it. Here's the recommendation. If you think you're spending too much time on a question or you can't find the right answer, then mark it as I want to review it and then put in a guess. And use the strategies that we talked about. Rule out anything that you know is wrong. Rule out anything that we have not talked about today. And then anything else, if it's still like two options in there, guess. Some people go pick the longest answer. Other people say, well, if it's not that, it must be C. I don't care. The computer does not know. When you get to the end of the exam, if you've got time, you can say, show me the questions that I flagged for review. And you can come back to those. But the best strategy is go through the questions one at a time. Don't leave any out. Always put an answer in. Because if you guess, you've got like a 1 in 4 chance of getting marks for that. So don't get too focused on, wow, this question's really tough. Put in an answer that you think is right. Don't overthink it either. Some people overthink it. Just go, okay, I think it's this. In fact, we'll look at some more strategies in a moment. One tip, go through these white papers, say the day before the exam or a couple of days before the exam. We covered so many concepts today that your brain is probably hurting, because mine usually hurts at the end of the day teaching. And you go, oh, what was this about? What was that about? This will help refresh, especially on those sections we didn't spend too much time on, like how does pricing work? What are the pricing tools? What are the support plans? All those details, because a lot of people focus on the cool technical stuff and kind of overlook this. This just helps to refresh. Strategies. Read the full question twice. Go hunting for those keywords. Try to predict the answer before you look at the responses. So if you saw what's the best practice for giving temporary permissions, you'd go IAM role, and then you'd skim through, there it is there. Or what is an IAM policy? Document. Boom, there's the answer there. If you can't see it, as it says, rule out any incorrect answers. And I'll give you an example of one of those in a minute. You may cover this. Is it an open book exam? No way. It's not even open desk. They do check for everything. So there's no books. It's relying on how well you studied. But that said, people pass all the time. As it's not easy, but it's straightforward. If you had goes at the knowledge checks today and you did well, you'll be in good shape, but wait for the slides to turn up. There'll be a second document in that zip file that's got just some of these links in there to run through. We've seen sample questions and how to handle it. This just says go picking, okay, it's the minimum score, so you want that. Select 2, don't select 1. There is an assessment that you can do. Now, this will be in your slide link that you could try this. It's a sample set of questions. In fact, this gives you the world's ugliest looking certificate at the end of the exam. This is just an assessment, like a quiz. The actual exam is not run by AWS, it's run by third parties, but when you get the slide deck, you can try this out. But I'll show you some actual, sample questions. Certified. Okay, sample questions. Let me pop this link into the chat. Puppy, please hear the link. Yep, okay, calm down. Yep, there. Please paste that link. Got that. Yep, got all that. Okay, first question. Why is AWS more economical than traditional data centers for applications with varying compute workloads? What do we think would the answer be? And what are the key phrases? Yeah, varying compute workloads. You don't really get that in data centers. We're turning things on and turning things off. What was the pricing model we used for that? On demand. If you got that one right, well done you. And that's not to make light of it. I mean, now you're seeing the types of questions that we covered today, but with different wording. Here's a simple one. What would simplify the migration of a database? Migration, database. Some of them are this simple. Now, this isn't going to give you a lot of marks compared to some of the other questions, but now you're getting the idea of it. What offering lets you buy, find, and use software solutions in their AWS environment? Now, we didn't talk about config today. We didn't talk about OpsWorks today. We only mentioned SDK as software-defined software development kits. Marketplace. So that one. Let me find a tricky one. Okay, not that one. Yeah, that was the one about AWS responsibility. So which is an AWS responsibility? Now, this may be one or more questions, but you'll know when you answer it, how many answers does it want? So configuring third-party apps? No, that's customer. Maintaining physical hardware? Yeah, that's AWS. So you say that's one. But then keep going in case this is one of those multiple choice questions. Secure applications? No, that's customer. Managing guest operator? No, that's customer. So the answer there is B. Now, where is an answer that you have not seen before? Oh, this one. We haven't talked about the right answer today. So where can a user find information about prohibited actions on AWS infrastructure? Trusted advisor? No, it doesn't tell you what prohibited is. It just says you're doing this right, you're doing this wrong. So it's not that one. IAM. This just controls security, access to the resources. No, that's not. Yeah, IAM, we never talked about prohibited actions. The billing console, that's costs. This one. So if this pops up, you have now seen acceptable use policy. This is one of the ones that we just never get time. It's one of those, when you first sign on, it goes, you promise not to do, snooping other people's networks and things like that. I mean, our systems will find that you're doing it, but you're not supposed to do that. Now, at the bottom, here are the answers. This gives you an idea of what the level of questions are. That assessment too, I'm not sure if you can still see these or not. I'll show you where to find the assessment that goes with this. And I see it somewhat differently. I'll show you how to find it because my account has weird and wonderful pieces. If you go into your AWS training account, which is called Skill Builder these days, you will see the digital class. I'll show you where it is. Oh yeah, we're still on track ahead of time. Cool. This takes a little bit. This is a relatively new system. You have to sign in. So you'll have your account. I have to sign in with my Amazon profile. Yeah, I'm an employee. In fact, you can find training for this and many other subjects. So Skill Builder is our new training content website. When it gets here, if it gets here, yeah, it'll get here. The easiest way to find some of these sample questions can be here. Now, I don't speak Italian, but I keep having to create new logins to show people. Sometimes you'll go Cloud Practitioner. And it's going to come back. The one you want will be Digital Essentials. Now, mine's going to say you've already completed it. So I'll just find another one that I haven't done. So I can kind of read a little bit just to show you what you might encounter. Digital Essentials. Digital, well, Greek, I don't speak Greek. Polish, no, I have no trade for that. Internet, definitely not with that. French. Okay, we could probably have a crack at this. I just want to show you what it looks like, what you would see. So you would say, I want Cloud Practitioner Digital, enroll. If you clicked on enroll, then you'll see all of the digital content for this class. Now, I don't want to do this. What I will show you is everything else I've got. Just so, assume you've enrolled, then what would you see next? I picked the English one because I'm okay with English, somewhat. You then go, yeah, start now, and all the digital content for the class turns up. So you could review anything that we did today. For instance, connectivity. I have no idea. There'll be a video. You can play the video. You can see the English transcripts. Here's all the terms. Blah, 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 blah. Any other content? So these would be the notes. So when you get the slides, the slides are not as detailed as this, but there's this Explore, say, Direct Connect that could take you to links. But you'll see right down the very bottom, where is it? A final assessment. So this is another sort of sample quiz. So if you click on final assessment, oh, look, I'm halfway through because I do this all the time. This tells you, here's a question, here's an answer, and it tells you whether you got it right or wrong. Now, just in case anyone's wondering, containerized apps would be Kubernetes. But here's another one. So this has got 30. If you want to store data that's attached to an EC2 instance, which service should you use? Well, Elastic Cache is a service. Did we talk about it today? No, it's not that. I want to attach a volume to EC2. S3 object? No. Elastic Block Store? It's probably that. We'll just check. No, Lambda is a serverless system, so it's not that one. It's probably this one. So this is a second set of sample questions you can go through. Submit. Yeah, I got it right. But it goes through the other pieces as well. So if you want to practice some exams, that assessment will help. You just enroll in the digital. You jump straight down to the assessment. You don't have to go through all the modules again. You can just jump down to here. What else have we got? What describes an availability zone? Ooh. We should let people have a go at this one. What do you think is an availability zone? Which one should we pick? B. People are picking B. Yep. Okay. Let's pick that. Let's try it. What did I pick? Now, why wasn't it this? Because I knew the right on. It's not that I didn't know the answer, but this is a geographical location with multiple locations that are isolated from each other. This is a fully isolated. Ooh, I can see why people picked that. This is a new question, and I'm going to report this one. I don't agree with this, and I can see why you wouldn't agree either. It's technically fully. I don't like this answer. Because here's a description. It's a single data center or group of data centers. That's correct. They're located 10 miles apart, well, 20 kilometers in Australia. Provides all this. The other ones are incorrect. Why is this incorrect? Separate geographic location. What response describes a region? Well, technically, you can hum and ha. I would argue about it. I don't like the wording. And again, if you're not an English speaker, I'd argue this one as well. I usually get these wrong. This is a new question that's popped up, and I don't like the wording, so I'll see what we can change. But again, this is a sample question, not an actual exam question. Well, question 14. Make a note. Yep. Okay, let's keep going. Which pillar focuses on using resources in a way that meets system requirements? You could pick something. You could pick anything. Could be that. Yay. Because this one's going to meet it. So again, I mean, that one before, I'm not exactly sure what happened with question 14. That's a brand new question that pops up, and I think it's not that well described. This is, now you can think, especially for people whose English isn't first language, why sometimes I don't like some of these questions. But this is a sample one, not an exam one. You're running EC2 and you want to store data in an attached resource. Your data is temporary and will not be kept for long term. So temporary. Yeah, these are all new. I haven't seen this one before either. I know what the answer is. You probably know what the answer is as well. Yeah, and clearly you do. These are all new. Oh, there's going to be some messages back to the assessment team about this, that's for sure. Yep, that one, because it's temporary. Yep. What can you do with CloudFront? Okay, we should be on home turf here. Provide an isolated instance of cloud. No. Is it CloudFront? Oh, yeah. Yeah, get the words have changed. D. But this will give you an idea, but it'll also point you in the right direction. So hopefully the exam questions are not, these aren't sample exam questions, these are just test ones. Because, yeah, someone's going to get a message from Glenn about that one before, because it's very vague. Which perspective of the cloud adoption framework focuses on recovering IT? What? Okay, I know what it means. Yep, someone's got to drop off. Cool. Yeah, if we're right on the hour, but this will give you another test point to do with the exam. So don't be too upset if you get things wrong, like the one that we all got wrong before, because you only need to get 700 out of 1,000. Everyone does it. Yeah, some people think A. Let's put A. Yep, that one's right. So you get the idea of what's going on. Oh, we're almost, we're only halfway through. Which tool automates actions through AWS services and applications through scripts? Well, that was the PowerShell, that was the Linux scripts. So that would be the command line interface. Yeah, these are all new questions because I have not seen any of these questions before in this assessment. So that one's definitely that one. So just read through, the documentation that we get, see how you go. We've done for the day. We're actually right on time. So thanks everyone for coming along. I've now got an extra task. I've got to walk through this assessment and talk to someone. People are going to drop off? Yeah, go for it. Because I know some people it's early morning, some people it's 5 o'clock, others it's mid-afternoon. If anyone is going to take the rest of the afternoon off, if you need a note from Glenn, the AWS trainer, that says, "Dear manager, Glenn said I have to do private research," I can write that and put it in the chat box. Otherwise, feel free to drop off. We've done everything for the rest of the day. We're all finished, all done. And good luck if you do the exam. You'll get my email address with the when the slides go out, so you'll have everything. So if you get stuck, if you don't know who to talk to, shout. Talk to you all at the next class.